Dr. Avinash Murthy to proceed. Yes.
Hello all. Showing 8 minutes.
This paper is on application of convolutional neural networks for automatic detection and classification of power transformer winding deformation under short circuit. Over to you, doctor.
Excuse me, sorry. Time reset. Time reset. The time reset 8 minutes. Good morning, everyone. And I will be giving a presentation on the topic application of the CNN. Application of CNN for the automatic detection and the classification of power transformer winding deformation under short circuit test using frequency response analysis and the impulse voltage response. Here in this presentation, and I will be giving the short introduction on the transformers and the failures, after the overview of the frequency response analysis, and then the methodology to model the FRA and the impulse voltage response, and then its validation, and after that the methodology to predict the fault location and the fault deformation time, and finally the results and the conclusion. The transformers are exposed to stresses. It might be the mechanical and electrical, which may lead to the mechanical changes in the winding and the core. Here, some of the faults which has caused the deformations are shown here in this picture. Hence, the condition monitoring is of utmost importance in order to have the transformer reliability. Actually, some of the condition monitoring techniques here are the FRA, insulating oil analysis, and the dynamic resistance measurement, and then the PD measurement. Frequency response analysis is used to detect the mechanical integrity of the transformer active part. FRA is generated when the 10 volts AC is supplied to one end of the winding, and the output voltage is measured at the other end. And then the transformer model high frequency can be numerically simulated through the resistance, inductance, capacitance, and the conductance. If there is any mechanical and electrical faults in the transformers, it will be resulting in the parameter changes. However, the interpretation is still challenging. But there is no single study investigated all kinds of fault through the comprehensive experimental modeling and analytical approaches before. Figure 2 shows the flowchart of the modeling procedure. First, we will be computing the RLCG parameters through the quasi-state MOM method, that is the method of moments, and FEM. After this, the machine learning based adaptive meta model of the optimal performances is used to compute the RLCG parameters in order for the validation of our model. And then the simulation of various real life short circuit fault scenarios based on FEM is simulated. After that, the FRA signature and the impulse voltage response is modeled for various magnitudes and for all different short circuit fault conditions. The figure 3 shows the geometrical representation of this single disc of the HV winding, and figure 4 shows the external circuit coupled with the 3D winding model. 3D winding model which has the RLCG parameters. Here, the FRA is generated through the equation 20 log 10, the voltage across R out by voltage across R in. These resistances are the resistance of the probes. Here, the figure 5 shows the computation of the RLCG parameters through Q3D for a single disk. And figure 6 shows this is arranged and it is coupled to the external circuit in order to obtain the frequency response. Similarly, for figures 7 shows this disk are arranged and is externally coupled in order to obtain the impulse voltage response. model validation is done through the comparison of the simulated frequency response based on FEM with the measurement response. Here at the low frequency region and the high frequency region, it performs, the simulation performs better, and it is having lower error in comparison with the measured response. However, in the mid frequency region, this frequency region has the resonances and the anti-resonances. This might be because during the simulation we have simplified the model by reducing the complexity of the model. And also we have not considered the mutual coupling between the HV and LV windings because we are just considering the HV windings. However, the pattern of the simulated response is response follows the trend of the measurement. Hence, it is we can use this model for the further analysis. And the methodology to predict the fault location. Table 1 shows the failure conditions used in the training and the testing for the comparative process. Figure 9 shows the flowchart for the diagnosis and the interpretation analysis. First, the computation of the leakage magnetic field and the force for the different magnitude of the short circuit fault conditions were computed. After that, the simulation of the different sensitivity of the variation, in the FRA signature and the impulse voltage response for different deformed windings were computed. After this, the post-processing of the FRA and the IVR data for different fault conditions through signal processing techniques like the standard transformer and etc. And for the feature extraction, we are using the principal component analysis. It will reduce the data dimensionality. Here for the classification, we are using the deep learning based the CNN and also the machine learning based nav bias. And because the machine learning based nav biases is the commonly used classification method for different classification problems. And finally, the computation of the prediction accuracy has been computed for these classifiers. Table 2 shows the comparative analysis of the prediction accuracy between the nav bias and the CNN. Actually, the nav bias performs better in most of the cases, but at some places, at some failure conditions and some response types, it performs inferior to CNN. Hence, we consider that the deep learning based CNN was to be superior, and the prediction of the deformation location as well as the deformation type in comparison to the ML based nav bias. Machine learning based optimization, that is in order to optimize the RLCG parameters matrices, in addition with the deep learning based prediction method, will give us the greater clarity for the possible fault location in transformers. This will assist us to understand the short circuit withstand capability of the transformer during the FAT stage, that is a factory acceptance test stage, before the actual test. And this will help to improve the reliability, extend life, and reduce the downtime and cost. Thank you.
Thank you, Dr. Murthy. I will request Mr. Raja Ram Mohan Rai Chandu for his paper.
So is it for 8 minutes, sir?
Yes, I think it is for 8 minutes.
Okay.
Yeah.
Very good morning, my dear authors, delegates, and the eminent personalities from the industry. Today I am going to present a paper on short circuit testing of Scott connected transformers. In this paper, I am going to present the challenges seen by the laboratory for doing this test. Not only seen by the laboratories, the challenges faced by the transformers because of the available test method, I am going to present in this paper. Before I go into my presentation, I'll just give a brief of why SCOT is required in our grid. As we know, our country, we are progressing. We are adding electrified networks. We are adding high-speed trains, DFC, dedicated freight corridors, and we are having an ambitious plan of zero carbon emission. With this, we are electrifying our railway network. So because of this, the load on the grid is increasing. And when it comes to the basic idea of initially, majority of the traction motors are driven by DC series motors. So then why AC is used is because of the advantages outlined here. Because absence of DC conversions makes the substation less complicated in design. And using of high voltage transmission lines makes the high voltage overhead lines lighter and easy for erection. And it is having advantages of reducing span length of substations. And having a high voltage transmission and step down transformers on the loco, which makes the DC conversion ease and make operation of DC motors very advantageous. Because of this, the AC is used in place of DC. But using a three-phase AC for taking a single-phase power is having its own challenges. Something like if you draw single-phase power from a three-phase ins, it is having the power quality issues. Among the power quality issues, the unbalances generated by the single-phase power drawn from the three-phase system plays very crucial role. It is having a disadvantage of overheating in the drives, overheating in the motors. So to overcome all these things, we need special connection arrangements to convert a three-phase into a single-phase with a minimum amount of unbalances. Among the available methods, these are the prominent connections which are used for converting a three-phase to single-phase. In this, open delta or V connection, SCOT, LeBlanc, and impedance connected balance transformers, and even cyclic pneumatic conversions of the phases, that is single phase transformers connecting evenly across the phases for having a balanced power drawn from the three phase. This is one of the applications. Among this, the cyclic connection is having disadvantage of having complicated connections and need a lot of expertise and scheduling in loading. And impedance connected balancing transformer is having disadvantage of power limitations. We cannot draw more power from these transformers. And the three is having a decent advantage when it comes to bringing the voltage unbalance into decent limits. Among the three, SCOT and LeBlanc is having more prominent effect on reducing the unbalances. But among this, the researchers, scholars have chosen SCOT because of its design and maintenance advantages compared to LeBlanc. So that is how the SCOT has come into the picture. So whenever we choose this SCOT connected transformer, these transformers we have to place in a system where, as per the IEC 60034 part 26, we have to place where the unbalanced coefficient shall be less than 1%. Means the power drawn ratio to the power short circuit power available shall be less than 1%. So it means if there is a short circuit, these transformers will see more amount of current. So that is the reason this transformer will be subjected. One more reason why these transformers must be subjected for short circuit test as per RDSO is, RDSO says generally these transformers which are going to railway, they shall be designed for 200% overloading. In addition, what they said is these transformers will be subjected to at least 40 short circuits per month, and in extreme conditions it may go up to 120. I don't know the reason why it is, but they say this is the amount of short circuits this transformer will be subjected. For that, they say this transformer must be subjected for short circuit testing before it placed into the system. And the same RDSO has given test connection, surprisingly, that whenever you do the testing, you have to feed the transformer from LV side and short the windings from the HV side. So as you know, SCOT is having two windings, mainly teaser and main winding. I am not going to in depth of what is what. So these are the two connections they had given. But to highlight these advantages, I have developed the model in PSCAD to see this. So initially I fed the balanced load by motor simulation. You can see the secondary currents are balanced. The currents and these currents and voltages are also balanced in the primary side. So it proves that SCOT is having very much advantages when reducing the unbalances. But even when it comes to short circuit, I have simulated same thing. While loading, I initiated the fault by closing a breaker. In this case, when there is a fault on the individual transformer, individual winding of the secondary, something like you can see here, you see the teaser winding, I created a fault. When there is a fault on the teaser winding, the primary teaser winding only will see the fault, and the main winding will see half the amount of the current seen by the teaser in the center phase, and it will be distributed and returned to the grid. But if there is a fault on the both the windings, then even primary currents are also balanced. From this it sees that everything is okay. But the problem of crux comes when you are feeding from the LV side and shorting HV. What is going to happen? So in the simulation I have done these things. The middle oscillograms you can see. The top one is by disabling the core saturation in the model, and the bottom oscillogram in the middle one is the enabling the core saturation in the core. You can see the shape in change in the currents. The shape change in the currents is attributed to the heavy amount of inrush current seen by the transformers because of the inwarding effect. Because when you short the winding which is farther from the core and supplying the winding, when you short the winding which is farther from the core, supplying the winding which is nearer to the core, so what is going to happen is the inverting effect will take place. So with the inverting effect, the lot of amount of inrush currents will be seen, and it is force the transformer core into saturation. This forcing the transformer core into saturation will see huge amount of inrush currents. The left hand side top oscillogram you can see, the blue one is with the inrush currents. The peak has been increased by almost 28%. So this is how the amount of current the transformer will see when it is subjected to short circuit testing by shorting the winding which is farther from the core and supplying the winding which is nearer to the core. So the inrush current is also taken from the simulation. So same thing we have done for main winding. For main transformer, if you short the main winding on the HV and supply the main winding on the LV, the inrush currents will shoot up to 60%. We will come to that why it is 60% when it comes to main winding. The reason for this is the same thing we have tested in our laboratory, and we have found that when you do on 100 MVA transformer, the detailed technical specifications of the transformer are given here. In this case, actual testing also has seen the inrush peak of a factor of 1.3 for tertiary windings and the inrush current peak factor of 1.6 for main windings. The comparison is shown here in the table. These are the simulated values and tested values, both are completely matching. So from this what I can say is, as shortage of time I am concluding. From this what we can say is, I don't know the reason why the test method is used by RDSO. Because of this usage of test method, the transformer will be subjected to unnecessary forces because of the heavy inrush current seen by the winding, amounting to 30% for tertiary and 60% for the main winding. I was involved when we finalized this specification. So these specifications are made suit to match the testing requirements of foreign laboratories. And what I conclude is, when there is a facility available for testing the transformers by charging the transformer with the HV winding and shorting the LV, we better go with that. It will reduce the stresses on the transformer, unnecessary stresses. Maybe the foreign manufacturers, they may not design for this, but as I see local manufacturers are making. So by using this method of energizing from HV and shorting LV, unnecessary stresses on the transformer can be minimized. Thank you.
Thank you, Mr. Rajaram Mohan Roy. Now I will request Dr. Chawda for his paper on SFRA.
Good morning and thanks, Ima. Today I am going to present SFRA test. What benefit our organization? As we know, we are Gujarati and we always look हमें क्या मिलेगा. टेक्नोलॉजी तो है मगर मेरी कंपनी को क्या बेनिफिट मिलेगा, क्योंकि हम सेल्फिश है, वही हमारा मेन कंसर्न रहता है. तो टुडे इन दिस पेपर आई एम गोइंग टू एक्सप्लेन व्हाट यूटिलिटी have achieved from this. Okay, nowadays we also change our selfishness also. Now we ask the second question, environment को क्या फायदा होगा. This is our second concern now. Okay, technology is there, but it should be environmental friendly, help to environment. These two concerns, and I think it is very difficult to complete this presentation in 7 minutes, but I will try. Yes, SFRA is the same as a X-ray, and we are using now SFRA as a decision making to charge the ICT or not. Okay, to sit on this office and to give the decision regarding EHV class ICT in grid charge or not. So SFRA is very useful for us regarding to take the decision. The second, in early day we are always try to open the transformer after heavy short circuit fault or some doubt. Okay, so it's required main power, days and money also. So now by using SFRA, we have reduced the time, money and other. So here in one of the case study I am explaining, this is the 167 MVA 3 unit capacitor bank is there and tripped in differential among B phase with Bucco's alarm. So we have suspected that something is wrong. So we have take SFRA, okay, and compare all this SFRA with previous signature is available. SFRA is best when signature is available. Okay, so this is the HV plot, you know, and there is a difference between low frequency area. This is the LV plot, yes, there is a difference, and this is tertiary winding, and there is a difference. Yes, in low frequency area there is a difference, but compared to HV and LV, there is a difference in winding area of tertiary. Yes, so we conclude that there is a something disturbance in tertiary winding. So how to more clarify, we have take the magnetizing current, yes, it confirm, take the 10 delta, yes, it's also confirm. There is something disturbance in tertiary winding. Okay, all other tests are normal, so there is a no clear-cut indication of fault. Okay, there is a no gas in DJ, okay, and winding resistance okay, all other tests okay. So we have decided to open the, okay, yes. Now in SFRA it is clearly indicate there is a residual magnetism in low frequency. So demagnetize the transformer, okay, with use of kit. And after demagnetizing, see the graph, okay. Now the gap is reduced. So all the three phase, yes, it is after demagnetizing. Now it's okay, SFRA now it's okay. But however, there is a still disturbance in tertiary winding is there, okay. So we decide to open the transformer. This is bell type transformer. So we have to place the order and open the transformer. Nothing abnormality found, you see. Net and clean transformer, okay. It's required 35 lakhs rupees to give the contractor to complete this, okay. But nothing found. Again, oil filtration done, again, all the testing is done, results are normal. But we suspect that there is a disturbance in tertiary, so there is a chance transformer will withstand or not. So after due all the precaution and with all testing again, it is decided to charge the transformer, okay. So we have suspected and doubt, so we check all this logic, Bucco's, differential trip, it's okay or not, DC, DC, of course, and charge the transformer. Just after charging, transformer tripped, okay. So again all the tests carried out. Now see the SFRA. Now SFRA clearly indicate there is a ton to ton short, okay, in low frequency area, okay. C LV winding and C tertiary winding. Now here, due to limitation, I have not explained all this because it took 6 months to analyze all the results, and finally we have concluded that there is a ton to ton short in tertiary winding only, okay. We have complete all the short circuit, all the tests, and we opened the transformer at factory, tear out, and we found that there is a ton to ton fault in tertiary winding. So what benefit we got now? So now we take a decision on basis of SFRA. This transformer now directly sent to factory for repairing, no need to open it here or no need to do anything. So it save over 6 months, save over 30 to 35 lakhs rupees, and quick decision is also helpful. So our main concern is what technology we have adopted. It is really useful. SFRA is very test. Main SFRA is a very low voltage test, so non-destructive test. You can take in any situation of the transformer. Okay, in one of the transformer is totally fired, totally bushing is failed. So we take SFRA without bushing and we confirm that there is nothing abnormality in winding. So after replacing all the bushing, we put transformer back into service. This is the what benefit utility as I achieve. So approximately numbers of transformers we have saved by using SFRA, and money, time, and supply power contingency. All these are happen. So this is my conclusion. SFRA is a very important test, low voltage test, non-destructive test. We can take SFRA in any condition of the transformer, with bushing, without bushing, without oil, with nitrogen, vacuum. Thank you. Okay.
Thank you. Thank you, Dr. Chawda, for this very good paper. Now I will request Mr. Akshay Dave. Mr. Akshay Dave, please. Your paper is on the development of a cost-effective dual ratio 1200 kV three-phase transformer.
Good morning, and thank you, Ima, for giving me chance to present this paper. I will start my presentation from my last slide and with a question. Have you seen a transformer with different type of bushing on HV side? As you can see in the picture, center bushing is of 1200 kV and other two phase bushing are of 800 kV. Probably a big no from your side. So I am explaining how we design and what are the reason for designing of a such type of transformer. So BHL in the business of power transformer and shunt reactor, and we have started shunt reactor since 1986 are of 400 kV class, and from 2014 for 765 kV class. These are the main standardized rating, because shunt reactor is almost a standard product, standard rating product. Out of these ratings, main ratings which are popular in our country are also shown in bold, and typical voltage levels for shunt reactor testing are also indicated in the table. So, but there is a difference in testing of a transformer and a shunt reactor. In transformer, normally we test many tests we have done. We are doing with short circuiting or open circuiting of one of the winding and test from other terminals. So we can do all the test with a very smaller voltage supply from other side of the winding. But in shunt reactor, there is only a single phase winding and fixed type of shunt reactor. So we cannot supply from any other winding. So we require a source which should have higher voltage and high power from testing point of view to feed the supply and required MVR rating. So reaching that MVR level, we normally used capacitor bank, and for reaching the voltage levels or rated voltage or test voltage levels, testing transformer of high voltage class is required. Before this development, we have two plants, separate plants for manufacturing transformer and reactor, and two separate laboratories. In these laboratories, in one of the laboratory we have three-phase testing transformer for three-phase shunt reactors and a single-phase 1200 kV class in another of the lab to test the 800 kV class of shunt reactor. There was no redundant facility, and we have received 765 kV class reactors order from the major utilities, and there is a problem in testing. So avoid and to have a redundant facility, we have decided to build a transformer which can be used for 800 kV class single phase transformer as well as 400 kV class single phase three phase transformer. So finally we think that can we have a common transformer to address both the issue. So Finally, we have decided a specification of this testing transformer in which we can operate this in a two mode. One is three-phase mode in which MVA rating is 400 kV, 400 MVA, and 1200 kV single phase mode where the ratio is 66 by 800 and 66 by 1200. 200 MVA rating is of single phase. Impedance are also indicated. HV side is a star, open star, and LV side is open delta. So what are the unique feature in this transformer? We designed with dual LV winding. So if we take both LV winding in the circuit in series, then we can have the lower turn ratio, and we can have three phase 800 kV supply for testing the 400 kV class reactor. And if we take only one winding in primary side in circuit, then the voltage ratio will increase further, and we can have 1200 kV side and single phase side. We also splitted HV winding to have the lower impedance and lower size of the testing transformer to overcome the constraint of size in the UHV lab. We have provided different insulation coordination for different phase on HV side. Center phase for we have designed for 1200 kV, in which we have provided molded lead exit for 1200 kV side, and for extreme phase we have provided 800 kV class insulation, and we have provided aluminum tube with crepe paper insulation for extreme phases. And also for keeping this transformer inside our lab, we have decided to have unit coolers with very low sound level around 70 dB with this transformer. So outcome is like this, and around shipping weight of 366 ton. We have able to manufacture this transformer for our UHV lab, and with the help of this transformer we can we can either test 800 kV class single phase reactor or 400 kV class three phase reactor in the same lab. And we with this development in a very short time and very small price in comparison to three single phase testing transformer, we are able to complete the order in time for 800 kV class reactor. Thank you.
Thank you, Akshay ji. The next paper is by Mr. Durgesh Singh.
Good morning, all of you. First of all, I would like to thank Trafotech Global 2023 for giving me this great opportunity. In this seminar, I, Durgesh Singh from Technical Associate Limited, Sitarganj, would like to share with you my practical experience and research about the relationship between active and reactive power for the testing of large numbers transformer up to 200 MVA 220 kV class. I propose to test 500 MVA transformer 400 kV class using the study's output. The objective of this study is to build a test facility at the optimum price that is capable of handling temperature rise test, load loss test and no load loss test up to 500 MVA 400 kV class transformer. The second purpose of this study is to reduce initial investment cost in transformer testing lab. The third purpose of this study is to reduce per transformer testing cost. Three distinct rating transformer were used for this study: 150 MVA 220 kV class, 200 MVA 220 kV class and 50 MVA 132 kV class. Instead of using MG set as the source of active power for this study, we used a variable voltage transformer. Yes, as we know very well, for testing of 500 MVA transformer, generally we use a MG set, motor generator set. Roughly the rating of alternator is 10 MVA and motor rating is 2.5 megawatt. The cost of approximate this system becomes more than 3 CR. If we use a variable voltage transformer in place of MG set, our cost will be approximate 70 lakhs. So this is the huge difference between the cost. The rating of reactive and active power will be determined in this paper in order to conduct temperaturized test 500 MVA 400 kV class. This is the electrical circuit diagram during the temperaturized test. With the help of this this electrical diagram, we draw a phasor diagram. With the help of this phasor diagram, we have derived three equations. First equation is used to calculate active current required from the source, and this is I2 is equal to I1 cos phi 1 divided by cos phi 2, where I1 is the current during the temperaturized test, cos phi 1 is the power factor during the heat run of transformer, and cos phi is to the power factor maintained by capacitor bank. Second equation we have derived IC is equal to I1 sin phi 1 minus I2 sin phi 2. This equation is used to calculate reactive current required from the capacitor bank. Same phasor diagram we have drawn again into the form of power. With the help of this phasor diagram, we derive our third equation, QC is equal to P tan phi 1 minus tan phi 2, where P is the losses during the temperaturized test. So this equation is help us to calculate the MBR rating of capacitor bank. So here feasibility study of testing of 500 MVA 400 kV class test. The test parameter we have considered: no load loss 120 kilowatt, percentage impedance 15%, load loss at tap number 17 750 kilowatt, total losses at tap number 17 1040 kilowatt if we consider 3 winding losses. As we know very well, as per the CEA guideline, 3 winding losses is not necessary, or loaded tertiary windings not necessary in power transformer. So at that case your losses is just only 750 kilowatt, but for the burst scenario we have considered 3 winding losses. The total losses at tap number 17 during the heat run becomes 1160 kilowatt. The power factor maintained by the capacitor bank is 0.8, equivalent impedance voltage for 41.03 kV, and current becomes 1631.06, and power factor 0.01 transformer during the temperaturized test. Using our 3 equation, we calculate our active current, that become 20.39 ampere, reactive current that becomes 1617.2 ampere, and capacitor bank become 115.13 MVAR. So we draw a single line diagram with this whole arrangement. In this single line diagram, we take a 500 MVA transformer under test. Here is a capacitor bank, and the available capacitor bank capacity is 145 MVAR, and required capacitor capacity is 115.13 MVAR. You can see just after the capacitor bank, our current is remaining 20.39 ampere against the 1631.06. So we calculate this current and voltage at each stage of this single line diagram, and you can see our T2 transformer, this is variable voltage transformer. The input voltage is 415 and output voltage is 0 to 470 volt variable supply. So our rated capacity of variable voltage transformer is 2500 ampere and required current is 2119. So at each stage our required power is less than the rated power of circuit transformer. Yes, in T1 transformer we have used on-load tap changer so that our input voltage become stable. In T4 transformer, this is our intermediate transformer, have multiple tappings in HV side from 4 kV to 72 kV so that you can select appropriate tap as per the requirement of your impedance voltage. Now conclusion. This circuit is very helpful for those scenario if you want to upgrade your company from distribution to power sector, because the initial investment cost is very low. You can also reduce your per transformer testing cost using this circuit. The above logic is extended to study the feasibility of testing 500 MVA 400 kV class ICT. The single line diagram clearly demonstrates the adequacy of the source transformer T1, T2, T3 and T4 for the transfer of power needed for testing 500 MVA 400 kV ICT. Yes, we have some assumptions. The load power factor of at least 0.8 lag was maintained during the temperaturized test. The input power supply is free from undue frequency and voltage fluctuation. Thank you.
Thank you. Thank you. Thank you, Durgesh ji. Now I will request Dr. Pratak Bajaria for his paper. This paper is on transformer winding temperature estimation without the sensors using the time series data. Doctor, over to you.
First of all, good morning. This is Dr. Pratik Bajaria from Scope TNM and Oxford, UK. What I'm going to present is something which comes out of a techno-commercial viewpoint where you try to see the assets which are installed in line or in the substations have particular, requirements, right? So I'll give you a little bit of a background before getting into the presentation. We go to the customers, we take inputs from them, and we try to see that how these can be technically imbibed into the solution itself. So that is what happened. We went to few of our customers, we tried to speak to them, and they told us that, okay, majority of the transformers in line, they are legacy types, right? So they don't have these IoT sensors installed, or they don't come with pre-installed sensors even. In that case, what do we do? Because at the end, with all these buzzwords like AI, ML, data science all coming into picture, they help you a lot, obviously. I'm selling that, so yeah. So in that case, what happens is that majoritarily, you want these sensors to be installed, but if they are not, in that case, what do you do? So what we came up with is the idea of actually creating an algorithm, like on the software side, which takes into consideration some of the parameters. Basically, this is just a state estimator. Majority of you guys might be knowing about it. But these take into consideration the algorithmic approach of computing oil temperatures and winding temperatures if you don't have sensors pre-installed. So that's how this idea came up. This is the entire overview of what I'll be speaking of. So I'll be speaking about like the introduction, the problem statement, and the formulation in the mathematical fundamentals. Again, of course, that's how the paper goes. So I'll be, showing you some of the simulation results and validations, and then I'll be giving you some inferences how utilities and discoms, even the GenCos, can actually look into this as a viable solution for their transformers which are in line. So as I was telling you, there are non-existence of oil winding temperature sensors in the legacy equipments, which kind of becomes the primary problem statement for us to write down this paper, right? So we went and we kind of found out that majority of our customers comes to us and tell us that, okay, we don't have these kind of equipments, and how do you do the AI/ML and data science related activities for an asset which is in line for like 30, 40 years odd. So again, even if you do that, so as I told you, we are selling these products. So we ask them to install these, but again, it's a cost. So in that case, if we have a bucketed solution where the budget is predefined, so in that case, what do? You have to play around with the numbers, right? So that was one of the key features which actually prompted us to think in a direction where a solution is not something which is like too costly, and still is giving you at least accurate amount of data so that you can do your AI/ML and all the asset health indexing and asset management related portfolios. Okay, yeah, inaccessible environments, yeah, these are important because majority of the times when you go, and we have seen some of our transformers which are installed so in the vicinity or in the remote location that you don't even have the access of installing some sensors. And yeah, okay, so that's the most important one. Is the fourth one, which is the necessity to implement the asset health indexing algorithms, right? You want to optimize your OPEX costs, and that's the point where you want to understand and implement an IoT sensors in line. But again, the first three kind of makes you impossible to actually install these sensors. So that these were the key areas which motivated and prompted us to go ahead and create something which is on the software side or on the algorithmic side, which helps you do all your OPEX optimizations and asset health indexing, fault predictions, failure predictions, and whatnot, and still be on the side where you are not having issues on the first 3 points that I just spoke about. Yeah, so problem statement remains the same, so I might not go much into it. But then again, the idea is the same, right? You want to install IoT sensors and do all these SCADA services, which are kind of the buzzwords of this world. And again, OPEX optimization. Okay, so this is how we put down our mathematical formulation. We kind of wrote down a first order differential equation, which is nothing but an estimator. So what is an estimator on a time data series? I think majority of you guys know it, but if I have to just give you a brief about it, it kind of takes a time series data, and via a differential solution, it gives you an output which helps you predict or estimate, rather than calling it as a predictor, I would call it as an estimator. It estimates the output of a certain variable X. Now, in this case, my variable is nothing but the OTI or the WTIs, which I want to. Symbols and representations of the particulars are pretty much on the side of the physical parameters like load current and ambient temperature. We try to keep it on the liberal side, where we only take parameters which are too obvious, right? If I have to install few more sensors, again, it's like an added cost. So we try to keep it on the mellow side. On the left that you see in figure number 1 is nothing but the model in Simulink that we created. It's MATLAB Simulink model. And we kind of just implemented the load current, ambient temperature, and a top oil temperature of the oil temperature or the winding temperature that you could possibly get from the transformer. And on the basis of which, if you can see, we can actually create the model losses on the right hand side, where efficiency and the losses that we are actually trying to see, they are kind of on the intersection of the point where you want to optimize. What we found out after implementation of the model is that majority, or maybe I can call it as the overall accuracy of the model, was around plus minus 3 to 5%. And it kind of gave a sense, or the distribution, if I just have to put a distribution of where the exact error is lying, you could see that the temperatures around, so the majority of the distribution is around plus minus 4, which is being shown in the plot. And on the right hand side, you see that, okay, what we measured and what we estimated was almost something which is going hand in hand. These are the inferences. As I told you that these are not just MATLAB simulations, we actually did it in line. Few of the transformers in the substation, we implemented it in actual real site and tried to see whether our model is in conjunction to what we are seeing on site. And we kind of found out, like the same, we have a standard deviation of around minus 1.59 degrees. Again, as you could recall, I'm sorry I have very short time left, but as you could recall, we have created the entire model from the perspective of not a power transformer or a distribution transformer. We have characterized the model as a transformer itself. So it's not like, although this particular study was on a power transformer, but we can implement it for any transformer in itself, because it's just an estimated model. These are my references, and yeah, thank you.
Thank you. Thank you, Dr. Vajaria. So we have heard these 6 papers today in this technical session number 2. I thank all the authors for making excellent presentations and abiding by the reduced time limits for this session, because we are short of time. We have to cover 5 technical sessions today. So thank you so much. We all have heard some new concepts, some concepts which have been there, but new aspects of those concepts, some new testing methods like Akshay has presented. So I request you all, if you have any questions, please ask them. Let's start from Dr. Murthy. Yeah. So in the same sequence as the papers were presented.
I must congratulate all the authors for a very good presentations. Dr. Murthy, I just have one question to you. That is, your interpretation technique, is it a kind of a automated one? Like, for SFRA, like once you get the signature, automatically it will give you some kind of interpretation?
Yes, sir. Actually, here, and I have not mentioned in the paper because I have used for the constraints in order to interpret. There are some constraints. For example, for the clamping structure looseness, or the axial movement of winding and the radial movement of winding. We can see this in the based on the literature. So we can see in the high frequency range, the magnitude of both the axial and for the radial winding movement, there will be increase in magnitude. And in the frequency region, in terms of frequency, it will reduce. The frequency will reduce for the axial movement, and for radial it will increase. Increase means it will move left and right. So these types of pattern also can I included in this thing. This will assist us. Actually, in addition with for R, L, C and C, G, this one, the matrices, we will be having like the matrices for R example, because our the transformer I have used, it has 74 discs, and each disc have 6 turns, 6 conductors and 9 turns. So it will be it will be like it will be the matrices of huge size. So for example, if there is any change in the CSH, that is the shunt capacitance, there will be we can
no,
yes,
I understand you.
These all things or constraints will be kept in the deep learning, and this will help us to automate the process.
So basically, this can be, this you are using it in the factory, right?
Yes, yes.
So it can be also used at the site for the purpose?
Yes, sir, yes, sir.
I mean,
Anywhere,
because
anywhere.
like Dr. Chevda and all,
Yes,
this
sir.
type of personalities who are actually using it in the site,
Yes,
they will
sir.
get immensely benefited from there.
Yes, sir.
If you have
Actually,
that available,
Yes,
if you are
sir.
doing it commercially, you are making it available to the customers.
Yes, sir. Actually, one thing in addition to Dr. Chowda, actually, in my algorithm for the deep learning, I have added one constraint. This constraint is for core, for the residual magnetism or the core defect, and also for the shorted faults, like shorted fault of the line to line, and also the disk to disk is also mentioned there.
Okay.
So it has been one of the constraints. So this all will help us to give the automated that this will be.
Thank you.
perfect.
Thank you.
But it
Can I
will
add,
be-
sir, Bhavik sir, your question? Okay, particularly in SFRA, if you directly go to conclusion, okay, so you have to compare all these stress, not only single one turn to turn. Yes, software is available in market, but they compare only one phase, okay, before and after. But after comparing all these stresses, we can finally judge on conclusion. For one example, if there is a mismatch in transformer tap position and we take SFRA, then SFRA indicate there is a huge disturbance in winding, okay, but actually is not that. It is due to tap position change. So software should be developed in such a manner that it indicate it is a issue of tap change.
I
Okay.
mean, that is all the deep learning, that there's the machine learning.
Yes.
You have to just
will
use.
learn based on the.
Yeah.
Yes, I have developed
So I
one
think
software
Yeah, okay.
for
okay.
particular that.
That's good.
Yes.
That's good.
It's
okay. I have seen that paper before. So because there is not much of time, I have got one more question to Mr. Akshay Dave. I must compliment you for designing that transformer, with different voltage class and all. But why did you actually go for it? What is the motivation for designing such transformer? Was it the cost or the size? I mean, what was it?
Because we have two labs. In one of the lab we have 1200 kV single phase transformer, and we can test a transformer as well as single phase 800 kV reactor. In other lab we have 650 kV class transformer,
Yes,
from
the old
which
one.
we are testing 400 kV reactors. But we are manufacturing 800 kV reactor in our other block. So we have difficulty in testing of these reactors in both of the testing transformer. So with the help of developing this testing transformer, we can test 800 kV class transformer in both the labs, and in a very minor cost, because we have spent only a very less cost, I cannot disclose, but less than a 500 MVA 400 kV class transformer.
Okay, thank you.
Thank you.
Just my last one is for Mr. Dr. Bajadia. I must compliment you for doing whatever you have done. It's a very innovative work. You had mentioned regarding the health indexing of the transformer. Do you have any product like that?
Yeah, so at Scope what we are doing is that we are creating an asset management portfolio where we'll be giving you asset health indexing. We have deep learning models, as you know,
Okay.
they are mentioning. We have deep learning models, we have regression models and all those kind of things which help you from the electrical parameters and the mechanical parameters that you read from the transformer. We give you health indexing, fault predictions, malfunctions
Okay,
and everything.
thank you. Thank you.
Thank you.
Yeah, actually, PK Patnaik from this side. The query to Dr. Chawda. First of all, I compliment the way you presented, because SFRA is the way we have to compare and all. For other kind of things, I wanted to add it over here. Along with SFRA, other diagnostic tests, basically the example which you have shown there, if you have gone for the winding resistance, then definitely we will be getting to know that there has been some kind of turn to turns ratio problem and all. That is one point. In generic way, if you go for the total part of it, like SFRA, then diagnostic test wise winding resistance, then the turn delta matter whenever it comes up, other kind of things, then adding of voltage in LV side and starting on the HV side, the kind of quantum of current to record and all. So we wanted to listen from you, and this is August gathering also. How can you just correlate all these tests in a nutshell?
Yes. First of all, thank you, Patnaik sir. Very nice question. Yes, due to short of time, just I not clear what actually happened in this ICT. Okay, when after demagnetizing, okay, 7 times this ICT test with all the test. Okay, each and every test we have done. But before charging, yes, we know there is a no turn to turn short in tertiary winding. Yes, it's very clear. There is a no turn to turn short in tertiary winding. Okay, but at the time of charging, due to electromagnetic force, the tertiary winding is happen turn to turn short. It is clearly we are showing from the disturbance recorder DR. What happened inside the transformer after charging? Okay, so after charging, after one cycle, its fault is created in the tertiary winding. Okay, and then it is clearly indicated in SFRA. This is your first question. In second question, yes, generally SFRA is provide enrich information of the transformer, but in support with that we do all other tests also. Okay, but some in a few case study, yes, actually 3 transformer I have tested in which only SFRA indicate the fault, no any other test. It's why happen, but not. It's very rightly. So SFRA is the basic test to provide all the information inside the transformer, and for support, yes, definitely we do all other tests, DGA, winding resistance and that. This is my answer. Are you okay? Yes.
Okay, one more last question, please.
Thank you.
Mr. Moti, Mr. Moti, this is Sai Kumar from Power Grid. I just want to ask regarding the generalized model that you are building on ANN using SFRA interpretation. Actually, SFRA interpretation is specifically manufacturer specific. Like when we interpret at site, we take the factory tested signature or a sister unit signature to analyze the result. But as seen from your presentation, you are building a generic model does it practically work? Because whenever we perform at site, generally we take our expert opinion in power grid and we refer to manufacturer to compare the factory signature or a sister unit having the same geometrical dimensions. But if you are referring to a generalized model, does it work for all manufacturers with different geometries? And I have seen in your presentation, nowhere you have taken the oil, the impact of oil. If you see, if you feed a signature with oil and without oil, the resonant frequencies differ and we will land into different conclusions. Because the geometry and the oil quantity also matters a lot in developing a signature. I am finding it is a generalized model. Does it practically work for different manufacturers?
Actually, it is not a generalized model, because actually I have used machine learning based optimization, and I mentioned that it is RLCG parameters. Each parameters have the matrices. That is, in my presentation I have shown the each and also for each matrices. For example, for the resistance, we will be having 54 by 74 matrix. So, based on the machine learning based optimization, the figure I showed that compared the simulation and the measure, it is the measured response. And actually, my model first I set to the model to the actual response through the optimization. That's why it was optimized. All this, the RLCG parameters were optimized in order to match the measure response. After it is matched, this model has been used for the further analysis.
Okay, thank you.
Can I add something more? If you want to develop AI tool for analysis of SFRA, it's required basic signature must. Okay. Okay. Then and then we can develop. Generic model is not possible.
Vikrant, can I have one more question? Yeah. Yeah, I'm Jason here, and this question is to Akshay Dave for BHL. You have done a good job of combining a three-phase and testing and a single-phase testing in a single testing transformer. And in that, whether you have chosen 765 kV testing of reactor, and you have also chosen 420 kV three-phase reactor. And is this transformer is capable of testing a three-phase 500 kV transformer, 500 kV reactor also? Was it considered in your, because many of the European and other countries, there are 500 kV applications of three-phase. Whether do you have that considered in the testing transformer?
No, normally transformer are not required to raise such a high voltage.
No, not for transformer, reactor, three-phase reactors of 500 kV.
Yes, yes, we can do it.
You can do that,
Yes.
okay. And one question is regarding the Scott connector transformer question. You have concluded that because we are doing feeding the power from LV side and we are shorting on HV side, you are facing this inrush current phenomena on that, and because of that the overstress is occurring on the winding. So any action has been taken up, any representation has been, because this is the spec which is frozen by RDSO, whether any action is taken with the, as a representation, so that, you know, whether there is any possibility of revision of the standard, because in the practical situation, there is not going to be an HV short circuit and then power is going to be fed from the LV side. So it's the other way around. So any representation is made or any effort is made on from your as a test point of view?
So when this first transformer testing was initiated by Made in Japan in India. So when they are preparing the specification, that time itself I was involved in that, and I told Mr. Made in Shah, this is not the right method of doing testing. So they are the first people taken the approved procedure from RDSO. But somehow they insisted in going with this procedure, and RDSO also agreed. RDSO never consulted CPRA before approving this procedure. But we told manufacturers that by doing this, maybe those who have taken this approval, they might have designed the transformer for this heavy inrush current stresses. Something like to the order of 60% more current in the peak. You can see the amount of stresses that will be seen by the transformer. So now we told even recently some other companies also who are coming to us, we told you please review your method, take up with RDSO and come up with the revised method of shorting LV and applying from HV side. So this is going to be beneficial to the manufacturer, unnecessarily why you are stressing your winding. I don't know maybe whether it is taken up with RDSO or not, but from our side we never consulted RDSO and RDSO never consulted CPRI before finalizing this. Thank you, sir.
I'll just make one comment here on this same subject. Is it possible to magnetize the transformer core in the reverse direction of the voltage and then go ahead with this test so that the inrush currents can be eliminated?
Oh, if it is a question of saturation, sir, what you are saying is correct. But here, when you do the test on the transformer, even if it's completely demagnetized transformer also, these things you cannot avoid because of inverting effect. The flex linkages will be completely different. There is an imbalance. So it will create a more flex into the core. It will drive the core into saturation. So demagnetizing will not go into effect in this much.
I was asking magnetizing the core in the reverse direction, not demagnetizing.
Magnetizing the core in reverse direction, we have done, I'll tell you one thing, I have taken one test with positive polarity. So hopefully that has magnetized the core in one direction. Immediately I have tested with the negative polarity, but still the effects are same.
Okay, thank you. Okay, so I think this was a very good session and this session comes to an end. I thank all the authors for their presentations and replying to the queries from the audience. Thank you very much. Yeah. So we end this session now.
Thank you so much all the authors for making the presentations on very important topic of quality and testing, and Mr. Joshi for very effectively leading this session. We have with us the veteran of transformer industry, Mr. V.K. Lakhiani. Sir, I would like to invite you upon the stage to present mementos to our authors and the session chairman. I would request Mr. Lakhiani to present mementos to authors first. Dr. Avinash Murthy. Mr. Raja Ram Mohan Rao Chennu. Dr. A.J. Chawda. Mr. Akshay Dave. Mr. Durgesh Singh. Mr. Pratik Bajeria. And our session chairman, Mr. Vikrant Joshi. I would request authors to please assemble here for group photograph. Thank you so much, Mr. Lakiani. Thank you all the authors and session chairman. We'll now break for tea and come back here at 11:15. One announcement, the bound volume is available at the registration counter. So during the course of the day, you can please collect your bound volume from the registration counter. Let's see you at 11:15.
It's omnipresent, just like air. What is the force that surrounds us? What is it that gives wings to dreams and ambitions? It's energy. Energy that illuminates lives. Energy that builds a nation. Energy that brings cheer. Energy that unifies and unites.
Hello. Yeah, I would request all the authors to collect their boxes, memento boxes from here, please. All authors, please collect your memento boxes.
We request all the delegates to please submit their feedback forms today for the lucky draw. Thank you.
What is this energy that connects and binds us? It's REC. It's the core of an ecosystem that's all about energy. Energy for the now and energy for tomorrow. It's about industry and growth, integration and diversification. It's about opportunity and productivity, connectivity and community. For the here and for the future. REC unleashes the potential of energy. REC funds energy. Funding that catalyzes, funding that inspires, funding that transforms. It brings us together with each other and our partners. For sustainability and reliability, for investment and development, adding value every day in every way. This is what our energy is. This is REC. It carries with it the dreams, the aspirations, and the hopes of 1 billion, with the promise of endless energy and infinite possibilities.
Established in 1937, CG Power and Industrial Solutions Limited is an engineering conglomerate with an impeccable and diverse portfolio. Our products, solutions and services support our economy's power, railways and industrial sectors. Industrial Division. This is the largest business of CG and is primarily India-focused. 1 out of every 3 motors in India is a CG LV motor with international certifications. CG is the largest manufacturer of low-voltage motors in India. We are the first to develop a complete range of IE2, IE3 and IE4 motors in India. Our single-phase motors unit caters to agricultural, domestic and industrial applications. Our HD motors are designed to meet diversified application demands. Our Stampings division is fully equipped with the latest high-speed blanking lines, H-frame high-tonnage presses and CNC precision notching machines. Drives and Automation has over 40 years of experience developing, manufacturing and delivering state-of-the-art motor control equipment with cutting-edge technology. CG re-entered the FMEG segment in 2019 with a wide range of consumer electrical products like domestic and agricultural pumps, industrial and domestic fans and water heaters launched over the last few years. Power Division. CG is a leading Indian manufacturer of developing and supplying power and distribution transformers. We supply locomotive and trackside transformers of various ranges to the Indian Railways. CG manufactures switchgear products like condenser bushings and current transformers suitable for high altitude and seismic zones. Our various switchgear products conform to IEC, IEEE, ANSI and GOST standards. At the switchgear unit, we manufacture the finest gas circuit breakers and surge arresters, polymeric and molded to suit multiple industrial applications. We have indigenously developed gas-insulated switchgears from 11 kV to 245 kV class. We also offer customized power quality and automation solutions with crucial equipment. Railways Division. CG is a leading manufacturer of traction motors, alternators, control equipment, propulsion systems for electric locomotives, multiple units, diesel-electric tower cars and railway signaling equipment. Our TMS unit offers traction motors and alternator control panels for diesel-electric tower cars, loco and multiple units. Our RTTE unit offers propulsion systems, traction converters, auxiliary converters, vehicle control units, control panels and driver's desks. Our RSD unit manufactures a signaling product range with innovative expertise. Management transition. In November 2020, Tube Investments acquired a controlling stake. Working ahead, our plans include doubling the motor capacity to cater to the domestic demand, export EV, expansion of our transformer manufacturing capacity to meet the rising domestic and global demand, and to have technology tie-ups to participate in several projects announced by the Indian Railways. At CG, we are constantly working on empowering people to do great things every day. Let's energize the world together.
Transformers are static electrical machines, but need proper maintenance and operation, which is often ignored, leading to their failure. Transformer maintenance is a periodical and expensive affair, currently involving a lot of human intervention, resulting in data which may not be fully accurate or reliable. Therefore, it is difficult to monitor transformers with a reasonable sense of accuracy. However, what if your transformer could self-diagnose itself and inform you or alert you accurately about its health? In short, what if your transformer became an intelligent transformer and could speak for itself? In addition, you could extract enhanced power from your transformer at maximum efficiency and utilization with cost savings. Introducing BOLA, that is, Better Operation and Life Cycle by Analytics, for distribution transformers taking a leap to the next level of innovative digital and enhanced technology solution from CRIFS. an investee company of Toyota Motors Group Company. This would result in your maintenance staff managing your transformers from schedule-based maintenance, which is expensive, to condition-based maintenance. You can observe your asset location, critical and vital operating parameters in real time, spread across geography, and compare this operational data for productivity, cost, and plant efficiency parameters. BOLA can be fitted on new transformers or can easily be retrofitted on existing transformer at plant location. Installation of the sensor and hardware can be done with minimum plant interruption. CRIF's Technologies aspires to help utilities and industry to reduce failures in distribution transformers, thereby saving OPEX and CAPEX costs and making the distribution system more efficient and reliable.
Power Oil from APAR is the leading brand of specialty mineral oils. With 2 large lube blending plants, APAR offers cutting-edge technology solutions in transformer oils, industrial oils, liquid paraffins and white oils, and lubricants. Automatic filling and sealing of drums with centralized SCADA control. Driven by continuous R&D, APAR has developed a diverse product portfolio of more than 400 grades of specialty oils. APAR introduced several special grade oils for demanding applications, including transformer oil for 800 kV extra high voltage DC systems. Powering the performance of new generation vehicles in the South Asian market, APAR offers the world-renowned ENI brand of engine oils and greases through an alliance with ENI SPA of Italy.
Danish takes pride in being recognized as one of the leading quality-conscious power equipment manufacturers and exporters from India. At Danish, we believe in building a legacy by looking to the future. Established in the year 1985, we are manufacturing and exporting products ranging from power and distribution transformers to control and relay panels with substation automation systems. With a state-of-art infrastructure coupled with a testing facility accredited by NABL, we produce and test as per the highest international standards. With a detailed integrated management system including ISO 9001 for quality, ISO 14001 for environment and ISO 45001 for health and safety. We cover all aspects to make a quality and sustainable product. Our people are our strength. With an in-house design team, continuous design and development work leads to most robust designs. At Danish, exports continue to be a major focus area for Danish, and thus we are exporting to over 30 plus international markets currently. We are also manufacturing various types of special application transformers.
For eons the planet has provided, and we have taken. It worked beautifully until scientists realized that increasing contamination of ecosystems is disturbing the natural balance, and the rate at which we extract resources is not sustainable. The human race is ingenious, and when determined to find solutions, we usually do. At Hitachi Energy, we take sustainability seriously, and that responsibility is at the heart of our iconic transformers. Developing sustainability solutions, co-created with our customers, is the key to our iconic transformers to achieve decarbonisation, enhancing safety for people, protecting surrounding ecosystems, and responsible use of resources. A quantifiable, evidence-based approach built on our deep domain expertise in transformers offers transparency on environmental impact using scientific methodologies such as life cycle analysis studies, followed by best-in-class solutions to improve sustainability performance. Even small electrical
May I request all our guests and delegates to be seated, please. We are starting with session number 3 now. So session 2 discussed about the very important aspect of quality and testing, and equally important is the storage, repair, replacement, etc. So session 3 will focus on these aspects, the challenges and best practices for on-site storage, repair and replacement of equipment. It's my pleasure to invite our authors and session chairman. Session chairman Mr. Y.V. Joshi. Please welcome our session chairman and authors with a great round of applause. Author Mr. Komal Abbas Lakhani, Mr. Gautam Mazumdar, Mr. Shivendra Mohan Pandey, Mr. Jiva Parmar, Mr. Arindam Chakraborty. While our authors and session chair they are taking their seats, it's my pleasure to introduce them briefly. Our session chairman, Mr. Y.V. Joshi, he is the senior technical expert with Yash High Voltage. He is distinguished member of SIGRE, former head engineering of JETCO, past president of ERDA. He is secretary of Society of Power Engineers, member of SIGRE NSC. He was the nodal officer of EMA Transformer Standardization Manual. He is the committee member of CEA Transformers Manual. He is the member of various BIS electrotechnical committees. He has a very, very long association with Trafotech conferences. He was the committee member of Trafotech 2012, 2018, 2020 and 2023. Mr. Joshi is the member of EMA TISCO Technology Innovation Support Council and also the technical committee member of TechIT 2024. Our authors, Mr. Komal Abbas Lakhani, he has done his MTech in machine design and manager engineering. He is from Siemens, and his field of expertise include mechanical design of large power transformers. Mr. Gautam Mazumdar, he has done his bachelor in engineering computer technology, and he is working as a consultant with CGPIS. His field of expertise include power transformer restoration, rehabilitation, site repairs, transformer condition assessment, and transformer quality. Mr. Shivendra Mohan Pandey, he has done his BTech in electrical engineering. He is working as DGM in power grid. His field of expertise include operation and maintenance of extra high voltage transmission system, monitoring of transmission systems. Mr. Jiva Parmar, he has done his diploma in electrical engineering and working as assistant manager in TNR India Limited. His field of expertise include installation, testing, commissioning, troubleshooting, manufacturing and process control of transformer. Mr. Arindam Chakraborty, he's done his BE Electrical, he's working as a manager in power grid, and his field of expertise include substation maintenance and testing. Joshi sir, the session is all yours, please. Thank you.
Good morning all. Welcome to this 12th edition of Trafotech. Today we have a session for the storage in-situ repair and replacement. This is also a very good or a essential aspect of the transformer to be taken. We have a 5 papers in this, and in which we will be seeing the replacement of the large transformer, on-site repairs for the transformer with the, we will be having 7 case studies, and a 315 MVA 400 kV transformer site repair. There are also experiences being shared for the storage and processing of 420 kV class neutral ester-filled reactor, and a case study on the restoration of bus reactor at site by using the practical solutions. So without much of time, taking time, I will request the first author, Mr. Lakhani, to present his paper. He is from Siemens. Mr. Lakhani, please. Kindly adhere to the time, and I will just request authors to directly start with the your paper without any background, because we all are here transformer.
Right, sir. Okay.
Okay.
Very good morning to everyone. My paper is focused on smart replacement of power transformers. I think we have a lot of end customers as well as a lot of transformer manufacturers, and I'm sure a lot of individuals will relate to me that whenever you are looking to replace a transformer, we face a lot of challenges. And there are a lot of things that come up very late in the execution stage and not being considered at the engineering stage. So we thought that if we could assimilate all the challenges and maybe potential solutions and a part of a small checklist, that could help us execute a replacement of a transformer, which may be parallel operation or maybe a expansion in capacity, we could mitigate the problems that come up during execution and engineering. So let me go one by one to the agenda of this presentation. First and foremost, we'll talk about the need for the smart replacement of large power transformers, then quickly look at the design and manufacturing challenges as a holistic view. Then I'll focus mainly on the mechanical design challenges that are very frequently occurring to a lot of transformer manufacturers. And finally, we'll look at how we can improve the situation, give recommendations, and probably come to an overall framework which could help everyone get a smooth execution for the replacement. Quickly looking at the smart replacement thing, as times have progressed, our capacities have been rapidly growing in India all across states and cities. Along with that, there have been a lot of technological advancements looking at change in the mediums, change in terminations, and a lot of methods that are requiring an upgrade. Key upgrades involve maybe a voltage expansion as well as an MVA or a capacity expansion. Along with that, now the customers as well as the OEMs are focused more on the environment as well as looking at low turnaround expectations, and a lot of expectations come from very low downtime turnaround. So that is where smart replacement will help you mitigate all the challenges that come along, and we can really attack these problems at the outset. Let's quickly get into the overview of basically classifying the 3 main challenges areas, focusing on electrical, mechanical, and controls. When we talk about electrical, I'll just briefly scan through the electrical aspects that need to be focused upon. The most obvious ones, the voltages, the capacity rating. The regulation sometimes become a challenge because the step and the preciseness of the old transformer and the new replacement is always a point of debate. If you talk about vector group and parallel operation is something that needs to be addressed at very initial stage because a lot of things have to be planned in advance. So this is something that needs to be captured at the initial stage from the electrical perspective. Then looking at, quickly going on to the controls aspect. Controls is also a topic that is dynamically evolving. Today in the first half of the presentations as well, I saw a lot of method by which you could measure maybe the temperatures, the sensors. So it's important that the control requirement, the schemas are clarified whether the old schemas or whether you need a parallel operation, whether you need something like a master follower arrangement, and harmonization of accessories is also a big challenge till today. All of our technical committees are trying to actually assimilate and try to come up with more harmonization of accessories, because whenever we try to replace one of the transformer is of a different accessory and creates a lot of challenge. If you talk about cables as well as parallel operation for the controls also becomes a huge topic. Then I'll now quickly get you to the mechanical design aspects, which really creates a lot of havoc for a lot of engineering teams as well as our execution teams. I quickly scan through and just deep dive into a few points. The overall space constraints, the foundation, the cooling, the terminations, whether AIS or GIS, and transportation. Why I'm not going through, because I'll take you through in the next slide. When I look at the overall mechanical design challenges, with my limited experience as well as we have collected information, what has happened is that the overall dimensions are becoming more and more squeezed in. From the place where I am right now, some of the customers in Mumbai maybe are charging for maybe 1 lakh to 2 lakhs per square feet if we ask for an additional dimension and an overall dimension expansion and the footprint. So that becomes first and foremost that the GAs, the informations as well as is discussed well in advance in terms of setting up the replacement of the transformer. Another thing that always comes up in the discussion, that whether we can reuse the existing foundation, whether we can match the existing foundation, and whether we can do an upgrade or capacity expansion, for which we had some recommendations that health evaluation of such foundations need to be done before we go ahead of replacement over the old ones, because a lot of times the foundations are never looked at some point of time. They also create a problem when we are looking at replacement choices. Looking at coolers, now a lot of optimized and better cooling methods are available. A lot of engineering has gone into it. There could be options that we could maybe look at reducing footprint by using maybe tank mounted coolers, maybe modular coolers, unit cooler arrangements that could help the customer also save some space as well as make it more efficient. Also, this we have experienced a lot of times, customers come up with suggestions for us that can we use the old cooler, and for that matter we need to actually maybe perform some tests in terms of healthiness of these cooling arrangements, as well as try to look at in holistic view whether this is a good arrangement that can be reused, because otherwise you won't create a problem which is not there even when you take a new transformer. Next thing, that is something also coming up, that transformation from the AIS to the GIS, that's happening very rapidly all across the countries. The one suggestion I want to give all our customers as well, that whenever you are taking up a GIS transformer or maybe a reactor, the factories always create a test arrangement that can easily switch you to a arrangement which is air insulated system. I would recommend that you could also maybe include in your specifications to actually take it along with your transformer, maybe store it, and maybe you could switch it to an AIS site. So this could also give you a flexibility to replace your transformers maybe at a site which is not GIS yet. Also, some of the things talking about transportation, when we have dispatched or probably manufactured a transformer so late, or maybe earlier days, what happens is that the transportation and as well as surveys need to be accurately done. The methodology of transportation in earlier days has evolved a lot, from oil filled to dryer filled to nitrogen filled. All those topics are there. So you need to have a key focus on it, whether you will be able to actually transport it as well. So it's a key focus area. Along with that, lot of things have to be taken care whenever we talk about a replacement thing. It's a customized product end of the day for the end user. The substation layout is something which needs to be well taken into account. In my opinion, becomes a big challenge when we have to pull out the transformer. I'll just quickly take on to my last slide with recommendations and checklists. First and foremost, interchangeability is a topic that we already have but needs to assimilate into key points when we are talking about a replacement. Foundations upgrade need to be carefully evaluated. Plug and play arrangements for a lot of terminations could help, and interchangeability between GIS and AIS could also help a lot of end users. And harmonization of accessories, I want to very much focus if we talk about RIS and as well as RIP bushings as well. Removal as well as installation could be key focus area. And my final point is that a lot of organizations face a lot of challenges with regards to retrieval of documents, wherein I would suggest digital cloud storage, which could be maybe fetched through a QR code, and the old documents, maybe customer drawings, the control relays, everything can be fetched in one go. So that is something which I feel can help mitigate the challenges of execution and engineering and a smooth replacement. Thank you so much.
Thank you, Mr. Lakhani. I would just suggest that the transformer which we are replacing, if we can focus on that, because that transformer is also very important for us. If it is not repaired, if it is not failed, so we will be using that transformer to other place. So something we can also add to that, your paper.
Correct.
So that will be an addition to it. We'll now welcome Mr. Gautam Majumdar. He will
Please.
be presenting paper from the CG, that on-site repair of the power transformer and distribution transformers. He has given the 7 case studies of the same. Mr. Gautam Majumdar, please.
Good morning to all of you here. I bring this paper as an international collaboration between Mr. Sven Christian, who is the resident of Venezuela. He could not come down here, and this paper details some of the cases that have been faced and redeemed at site as a part of this thing. There are many more cases which have been carried out, but we are putting in some salient ones, and we have both distribution and power included in this presentation. So moving forward on this, presently with the environment which we are facing in terms of optimum utilization or higher use of the power transformation capacity, reliability of power supplies, we have seen a tendency to carry out repair activities at site. The process has been also substantiated and being pushed around in lot of European and North American and South American installations. We have slowly been seeing different standard bodies and international recommendations coming out, which are listed here. This presentation moves with a basic format of what was the issue, the systemic. Some of the language here comes from Mr. Sven Christian, who is basically having a Spanish background, so you'll find some difference in how we take it up and how he has taken it up. To maintain a bit of authenticity, I have not changed the whole of it. The failure and the systemic effects, the diagnostics, briefing of the redemption process, and the results. We have tried to use no brands, no names, nothing, but it involves supplies from majorly all over the world, and even some of them are in solar installations. The first case we discuss is a small 4 MVA transformer, DGA validation post charging, and the indications indicate that there was moisture in the solid insulation, which FDA analysis highlighted. The insulation resistance also partly contributed to it. Remedial actions, quite a standard procedure, and it was vacuumed, it was oil dried, cycling done, and done measurements. Results and diagnosis showed acceptable values in line with the factory acceptance tests which were there on the transformer. So this is a very standard procedure and methodology followed. Buchholz relay tripping on transmission transformers. This is a 100 MVA transformer. We had a systemic impact in which the substation had to be shut down because of only one transformer being available. Diagnostics performed included visual inspection, diagnostic tests, and a certain amount of DGA, tan delta, and other activities. when the DGA analysis indicated something on the core coil assembly. It was oil drained, it was checked, we found some missing insulation, slipped out insulation, and it was put back, and transformer dried out and proceeded. This was an oil leak from a transformer, very large transformer, 200 MVA. The process followed was what we call as partial vacuum method, which led to reduction or minimization of the leakage, and then it was in situ repaired under partial vacuum technique without really causing a serious time frame in terms of the time required for restoring it. Though the systemic impact has been highlighted as an environment issue, because these are considered to be very serious environmental issues in North and South Americas. So it was on a major way, the process avoided redraining of the oil or the replacement of the or attending to the complaint, which could have been a lot more time consuming. This is again for a small transformer, which led to the shutting down of a part of the solar plant, and the diagnosis involved indicated that there were limiting fuses inside the transformer which had failed. Of course, the transformer manufacturing and design was of the nature that it was possible to service the transformer at site without much this thing. So again, oil was drained, location identified, material changed, and analysis was done in terms of the fact that is there has been any corruption of the oil and the insulation. And once those were set right, we went ahead with the closing and vacuuming and then oil refilling and cycling, leading to this thing. This is a 100 MVA with a tap changer issue. This was a major shutdown, and the systemic impact was the delay in commissioning. And considering that, again, we followed certain procedures and it was restored back. Again, something related to off-circuit tap switches, but it is on a smaller transformer. Engagement of the contact, and again with lot of considerations and planning, it was carried out in the process, in the site itself. This is related to a very observation which has been highlighted here, is the painting and this thing. This transformer was installed at a saline environment area, and it was showing damages into the painting, which is very location specific. So initial treatment was carried out, it was not successful. Then we went through a process of surface washing, cleaning and this thing, and the aging of the process. After carrying out the process, the transformer or paint was found to be aging uniformly. Some of the things that we are trying to highlight here is the transformer repairs at sites are now a very viable option because of the improvement in the processes and the environment control that are possible to be replicated at site. May not be 100% in terms of a transformer manufacturing facility, but quite a lot in terms of the other things. Some comparison, some changes and some materials need to be procured in a specific manner to be what we call as ready to use, and that involves the manufacturer and his facilities usage in this. The major part comes on the third, a stringent detailed planning, quality checks and work parameter. This is very much in line with what is the procedure followed at the factory, and possibly a bit more stringent because we are working in in remote locations and there where we need to have a higher amount of control so that we achieve at least the basic minimum requirement. So basically putting it down is that it is possible with lot of engagement from both the customer and the manufacturer. Very briefly putting it in, the process consists of the points as highlighted, and it leads to cost effectiveness due to transportation cost, and repair turnaround time is also smaller if I consider the transportation. Cost effective definitely in terms of the fact that you're using a space which is available and you're not going into this thing. And because we will be using subcomponents, so the transportation of the subcomponents is also quite convenient. I'll take the opportunity to thank all of you, and we are available for any further this thing. Thank you.
Thank you, Majumdar Sahab, for giving the insight of these 7 case studies. I will now request Mr. Shivendra Mohan from Power Grid to present his paper for the in-situ repair of 400 kV transformer.
Thanks a lot, sir.
Please.
Good morning, everyone. The topic of my discussion is in-situ repair of 400 315 MVA transformer using various innovative techniques. As we know, majority of the faults of transformers and reactors in power system are caused primarily due to the failure of the installed bushings. In case of failure of the bushings of transformer and reactors, which gets converted into a HV to ground fault energy due to the flow of the heavy fault current to ground is too high. This leads to devastating failure of the transformers or reactors, including the bulging or rupture of the main tank body in some or many cases. Power Grid has taken various measures, including replacement of OIP bushings with RIP, RIS bushings in new specifications since 2014. However, there are certain cases where OIP bushings are failing without giving any prior indication, and unfortunately, one such case was encountered at one of the substations of Power Grid Northern Region 3, where a 400 315 MVA transformer tripped due to failure of Y-phase HV bushing, leading to a severe fire. In case of major fire or failure of the ICTs at site, the usual option of restoration is to replace the failed ICT with available cold spare of similar rating and parameters. But such replacement of ICT with cold spare unit usually takes many days for restoration, which leads to compromise of tariff, availability and reliability of the power system. Along with that, the cost of replacement is also too high. Considering these aspects and after assessment of the site condition, the challenging task of repair of the damaged ICT at site was carried out by adopting various innovative techniques. The ICT shown in the picture had been in operation for more than 24 years. All the condition monitoring tests were within acceptable limits. The ICT was having OIP bushings. There was sudden blasting of one of the 400 kV OIP bushing, leading to massive fire in the ICT, which was curtailed by the help of fire tenders and foam type fire extinguishers. Due to fire of the bushing and scattering of the shattered porcelain pieces of Y-phase bushing, it damaged the other HV bushing and IV bushings of the subject ICT. So it was decided to carry out the on-site repair based on the external and internal damages that had occurred inside of the ICT, and after assessment of all the electrical tests of the main and tertiary winding, which were found to be okay. The external damages were mainly HV, IV and neutral bushings, HV and IV side surge arresters, turret CTs and their housings, equalizer pipe assemblies, OLTC headgear assembly and gaskets of the transformer. The internal damages were damage of HV winding snout, damage of wall shunt insulation and falling of burnt debris and particles inside the main tank of the ICT. For the site repair of the ICT, following innovative solutions had to be adopted. because these were the mandatory requirements which had to be attended to bring the ICT back into service. It required replacement of HV snouts and repair of wall shunts at site, fabrication of copper sleeve at site from the draw lead of faulty IV bushing, and further jointing of HV lead of Y and B phase, which were damaged. The bushings of these were damaged. It was carried out by crimping them. Then finally, arresting of the belt tank gasket leakage with the in-house application of salite sealant and titanium putty under vacuum condition of the main tank. In the picture alongside, we can see for removal of the broken HV snout, of the Y and B phase of ICT, and for insertion and installation of healthy spare HV snout, it was mandatorily required to remove the HV lead cone, which is inserted and installed in the HV lead. But the removal of the HV lead cone by sliding it out of the HV lead was not at all possible at site, as the outer diameter of the bushing lead connector at the end of the HV lead was more than the inner diameter of the HV lead cone. After replacement of the HV snout and installation of the HV lead cone at its place, it was not required to join back the HV lead with the bushing and connector portion of the lead. But this joint should be durable and of least resistance possible for the system current. For proper jointing of the HV lead, it was decided to install a cylindrical copper sleeve of suitable inner dia as that of the HV lead. But to make this arrangement, following hindrances were to be resolved. Arrangement of copper tube sleeve of outer diameter 38 mm, inner diameter 28 mm compatible with the HV lead. For this, as I've already told, the 1 number copper draw rod of faulty IV side bushing was taken and used for fabrication of 3 number sleeve, 2 for the Y and B phase bushings and 1 as spare. After that, at site, it was also required to cut the HV lead. For this, the portable hydraulic cutter used for transmission line conductor was used for cutting of the HV bushing lead. Further, crimping tool used in transmission line for the conductor sleeve crimping was used for crimping. But the constraint at site was that the crimping size available as per the standard conductor dimensions were not available. So, the resolution was made by using stainless steel pieces in half hexagonal formation over the die set to form a suitable die for 38 mm dia, which was required to crimp the lug. Now the crimping tool was hung with the help of hydra over the transformer to carry out crimping and further jointing of the HV lead. After carrying out the rectification and repair of the ICT main tank and boxing of same with installation of accessories like bushings, equalizer pipes, OLTC and other connections, pressure leakage test was done, but vacuum leakage test could not hold due to leakages at OLTC headgear assembly, inner gaskets, and major leakage was observed from the belt tank gasket of ICT on the HV side, on the front side where the 3 number bushings are installed over a length of 8 meters. So, salite sealant was applied for an extended length of 13 meters covering the affected 8 meter part of the gasket. For this, the salite sealant inside the gasket gaps and the crevices of the gasket was inserted by using a special tool at site, and the outcome is shown in the next slide. Like means after insertion of the salite sealant through one of the holes, it was pushed over there to make place for the gasket till the salite sealant doesn't comes out of the next bolt. After attending the leakage and carrying out 2 numbers of dry out cycle of the ICT main tank, finally low frequency heating of the ICT was done to further remove the moisture content of the main tank winding, which ingressed inside the ICT during the repair exposure of the main tank. Finally, with the help of current heating and evacuation of the moisture by vacuum and dry out cycle, further dry out of the ICT was carried out, and after adequate dry out cycle and achieving required dew point, oil filling was done and transformer was successfully charged back on 7 July 2023. My conclusion is that every utility is facing failures of transformers and reactors in their substations. However, with the passage of time, confidence has been developed at site to take the repair activities in a time-bound manner so that the failed equipment can be brought back to service in the minimum possible time. Site repair not only helps in saving massive replacement costs of the transformer, but also helps but also saves restoration time of the equipment. With the help of these innovative approaches and the zeal to curtail the problem, there has been significant changes in approach of the utilities to take up these critical repairs at site. Finally, I would like to thank IMA and PowerGrid senior management for granting me permission to write this paper and present to you all. Thanks a lot, sir.
Yeah, thank you, Shivendra. If you could have included the results, cause of failure, because you mentioned that is a wall shunt was damaged.
Yes, sir. Actually, it got damaged due to the failure of the bushing, and after opening the job, means at the time of restoration, what we did is we brought out all the faulty bushings, and we had to ascertain whether the equipment is, whether the main tank is healthy or not. So during the course of testing of the equipment, we carried out all the bare minimum tests like winding resistance, magnetization current test, IR test, winding tan delta. And and also we carried out the IR test of the wall shunts, and we found out that the wall shunts were, the IR values were quite low, so it was required to be replaced at site. It was procured very timely from BHEL, and because of all the assistance from BHEL and PowerGrid senior management, the equipment can be restored in the minimum possible time, sir.
Okay, thank you, Shivendra. May I request Mr. Jiva Parmar to present his paper on the first ester-filled shunt reactor. Mr. Jiva Parmar.
Good morning to all. Today I am share my experience on processing and storage of first 420 kV class natural ester-filled shunt reactor. Natural ester, often known as a vegetable oil, generally made from soybean, sunflower, sesame, enjoy naturally neutral carbon footprint, ultimately biodegradable, less in toxic, and non-editable K-class fluid. Use of natural ester fluid in India limited to distribution and medium voltage class up to 66 kV transformer. Few installation of 132 kV and 220 kV. However, world over experience is 400 kV transformer and 380 kV of reactor. PowerGrid, a major transmission utility in India, took a pilot project of procuring a natural ester-filled 420 kV shunt reactor to gain a field experience. This is typical flow chart during the manufacturing of the reactor. It is including preparation, fluid receipt, unloading, storage, filling and processing, FAT, internal inspection, and dispatch activity. For the storage, we identify a non-moving transformer tank. The tank, before use, thoroughly clean with dry and wet. Replace all the sealings, gaskets from the tank, and pressure test was carried out to ensure that no leakage from the tank. Identify a filter machine and cartridges and sealings, all the gasket and cartridges of replaced from the filter machine. Filter machine was flushed with the natural ester oil. Natural ester oil having a high viscosity, and the filter machine is designed for mineral oil. So capacity of filter machine is derating to approximately 50%. New fluid handling hoses were procured and green strap was marked to identification. Unloading of fluid from the transport tank, the image is indicating a drain valve of the transport tank was connected to bottom valve of the storage tank. Partially vacuum was created in the storage tank, and during the unloading, continuous nitrogen was purged inside the transport tank. On finishing of the unloading fluid, vacuum was break with the purging the nitrogen, and positive pressure of nitrogen maintained on the storage tank. After drying of the active part, reactor was tanking, and bushing fitment was carried out. Internal clearance was measured, and dry pressure test was carried out after fully assembly. A vacuum cycle for 0.1 torr was carried out for 24 hours, and fluid was filling under vacuum. During the filling of the fluid, continuous nitrogen purging in the storage tank. A hot oil circulation of the active part was carried out with partial current injection. Top of oil temperature is maintained to 65 degree for 72 hours. Ester oil having a lower impregnation property compared to ester oil. There was 72 hours of settling time provided before the testing. 420 kV shunt reactor was successfully tested for all routine and type tests, including temperature rise test. During internal inspection and dismantling of the bushing, the nitrogen was purged into the reactor tank, and partially vacuum was created in the storage tank. To attempt this internal inspection was minimized within 2 hours, and minimum inspection window was opened. During the connection, during the dismantling of bushing and internal inspection, for safety aspect, dedicated self-contained breathing arrangement SCABA was used, which is indicating in the image. Dispatch of reactor tank with fluid filled with fluid, and top portion of the tank was pressure with the nitrogen. To maintain nitrogen pressure during transit and storage at site, constant pressure regulator provided during the transport. Remaining part like headers, Bucos pipeline, and accessories like conservator, air cell also pressurized with the nitrogen, and a arrangement of checking was also provided. A recipe at site, it is similar to mineral oil. The checkpoint is similar to mineral oil. The reactor was an augmentation task. So a newly supplied reactor took place of old shunt reactor was under service. Storage time is limited to 60 days. During the storage period, positive pressure was ensured of main tank and accessories. Erection is including 420 kV number of 3 bushing and 145 kV 1 bushing. During the erection, continuous nitrogen is purging in the reactor, and dedicated SCABA was used for working personnel. Bushing fitment and internal inspection activity completed in less than 8 hours time. Preparation at site, it is more or less similar to at the factory what we have explained for the filter machine and storage tank. The unit was dispatched with filled the oil for the connection of bushing. Again, oil was drained from the reactor tank. During draining, nitrogen purging in the reactor, and partially vacuum created in the storage tank. After completion of erection, pressure test using nitrogen was carried out. Purging cycle performed to improve dew point values, and final vacuum cycle for 48 hours. Under vacuum, the fluid was filled in the reactor. Air cell of conservator was activated, and hot oil circulation to maintain top oil temperature 65 degree carried out for 72 hours. After successfully processing and settling of about 48 hours, all pre-commissioning and electrical tests performed. Fluid tests also performed and value are compared with factory standard recommended. The 50 MVR transformer for 20 kV natural ester-filled shunt reactor commissioned on 27 August 2021 at Mathan substation, Power Grid Mathan substation. Until date, this reactor is servicing satisfactorily. Thank you. Thank you.
Thank you, Mr. Jiva. It gives me a remembrance that in JETCO, we started with this ester first time in India with the help of Mamtara sir and Lakhyani sir, that first 66 kV transformer. We just replaced the mineral oil with the ester, and then we got the results what we were desired. And today we are seeing that it is being used for the 400 kV shunt reactor. Thank you very much, Mr. Jiva. Now I will request Mr. Arindram Chakravarti from Power Grid to present his case study on restoration of bus reactor. Mr. Arindram.
Thank you, sir. Good afternoon to all the our session chairman, to all the authors, to all the eminent personalities and all the technocrats present here. Since all the discussion has been going on restoration and all the other things, all the devices like transformers, reactors at site, I am also presenting a study on restoration of bus reactor at site via adapting various practical solutions. There was initial failure of bushing of 132 kV bus reactor, which was operational since 1998. This reactor bushing, it had no prior history of failure. Actually, as Pandey sir is also saying in his paper like that, there are certain instances of OIP bushings where suddenly there is failure of the bushings without giving any kind of trace in any test results or anything, any such trend. Here also the same thing happened. The bushing blasted, and after the blasting of the bushing, the adjacent bushings are also, it damaged the other adjacent bushings also. That is, the Y phase bushing was blasted and it damaged R phase and B phase and neutral bushings also. So normally as per the norms, we carry out the DGA test of the oil parameters, and all the parameters are okay. And also the reactor bushings, reactor and the bushings are also tested 6 months prior, and all of them, all the values are satisfactory in nature. But however, after the DGA sampling, after the blasting happened, obviously the acetylene and hydrogen was present there in the bushing. So we carried out the RCA also for why this happened. But actually, my paper is, or the case study is mainly on the restoration of the reactor. So initially, as shown in the previous slide, that all the adjacent bushings, you can see this was the blasted Y phase, and all the adjacent bushings are all damaged. So afterwards, we carried out internal inspection. So this was actually a little bit small, but very important in the system. This bus reactor was there. So we had to carry out the internal inspection via the inspection chambers. It was very small in nature. It was not able to, we are not being able to enter inside. So we had to only take peek inside to take the overall scenario of what has happened inside. Whether externally no bulging of the or blasting of the tank was there. Externally it was okay, but internally we had to see what are the damages. So we found out that apart from the bushing damages, the snout of the lead, which was coming out from the winding, emanating from the winding, it got damaged. And the lead, when it comes out via snout to the winding, the main lead was damaged. The wooden structure which supports that lead also was damaged. And due to the bushing failure, various debris were found inside, obviously, because the blasting of the bushing was there. So our main challenges were, all the bushings are damaged. So normally there is only one, as per norms, one or two spare bushings are there. We had to, the main thing is there, this happened in a very remote place. So suddenly, logistically to arrange spare bushings from other sites is also a challenge there. Suddenly because normally we are not prepared for the failure of all the bushings. First we had to arrange spare of the bushings. So, and what to say, neutral bushing was also there. So we had to arrange spare for all the bushings. At that time there was only one spare bushing as per norms available at site. So we had to arrange for the other bushings also. So logistically it was a problem. However, there was another problem was there. When the bushings came at site, since this is a very old make, though the rating and the OEM was the same, but the bushings were not matching in dimensions. So that was another difficult case. So since the dimensions were not matching, so we had to take a decision to repair the bushings at site. The Wi-Fi's bushing was completely blasted, so it could not be repaired. So it had to be replaced with the spare bushing, which is matching in dimensions. However, in one of the bushing, we decided to repair it at site, the bushing. So what happened is that then the B and R phase bushings were damaged. So we first decided which one to repair based on the extent of the damage, based on the number of petticoats damaged. So the neutral and the B phase bushing we finally repaired. The damaged petticoats of the bushings were repaired by cleaning with a suitable cleaner solution, an absorbent, and then applying ceramic filled epoxy putty to form the base of the petticoat, and then finally applying brushable ceramic putty to give it a glossy finish to maintain the dielectric strength. So here you can see that the bushings we are being repaired. You can see, as you can see here, this is the B phase bushing which we are repairing. There are around 11 to 12 petticoats damaged there. So, and the neutral bushing is also there. So you can see here we have repaired using that ceramic paint and the glossy ceramic putty and the ceramic paint. We have repaired this this bushing here, and the neutral bushing has also been repaired. And then we tested the bushing at site, and we found that the values are very good. The IR, the variable frequency, turn delta, all the values are as good as a new bushing. So, so this was another one first major repair which we did, this bushing repair at site. Then the snout repair. The snout repair also came with its own challenge. That the snout, since the good thing was that the lead was not entirely damaged, so we had not to bring out the lead from inside the winding. So the and the support of the lead we had also to be repaired. So the snout, what happened? Since the leads are not broken into half or connected by bare minimum wounds, hence it was decided to repair both the lead as well as exit point from the snout at night. The snout was also of bigger size of 400 kb, so we adjusted into for a 132 kb size. And then we repaired the snout and rewound the lead. And then after rewinding the lead, and then the damaged portion was rewound, and then it was covered and packed properly with crepe paper, and the snout was replaced, new snout. And as I told that the snout this was a bigger size, so we adjusted it and set for a 132 kb size, and then it was wound properly with paper and insulation, and then we repaired the wooden support structure also, and then as you can see that the new lead was repaired here. Another problem came here was that, as you can see here, that here the lead is coming from the winding. This is the winding lead, and then there is the bushing lead. This winding lead gets connected at the bushing lead, and this bushing lead gets inserted into the bushing, which is the normal norm. So because the new bushings came, though they are of the same rating, there are also mismatch in size also of the bushing also and the size of the lead also. So in one of the cases, then we repaired, as we shown that we repaired the B phase bushing, the R and Y phase bushing we replaced with spare. So in one of the cases also, the lead was also not matching. The length of the lead was actually not matching. So we had to then repair the existing lead only. See normally what happens when the bushing blasts, the lead gets spot marks and damages here and there. So the spot marks were eliminated by procuring insulin cloth, and again we redapped the lead, and then we soaked it in oil, and then we tested the bushing overall with the lead also. So and then we fixed the lead, and then we take down the bushing and again fix the lead. Here the picture is, then the paper it is given there, it's not here. So afterwards, because it was very difficult, because the spares were not there, matching lead was not there, and actual logistically the location of the site and the importance of this reactor, it had to be restored at the earliest time. So afterwards, thankfully it had been restored in under the stipulated target time. And after that, charging, because we repaired the bushing, the major issue is there, and the snout changing is also there. So then afterwards we carried out all the tests, regular tests were as pre-commissioning test had to be done. It had been done before charging only. After charging, we checked the disturbance recorder currents also of the bushings, and regularly we have been checking on the DGA parameters of the oil. And recently, 1 month earlier, again the reactor has been tested. So until almost 11 months after charging, the values are all satisfactory in nature, which means that whatever solutions we adopted, thankfully proved to be fruitful. Thank you.
Thank you, Arindram. A good paper. You have given the insight for the repairing. Apart from the transformer, we are focusing on the transformer. Rather, I would also request the audience to present the papers on the accessories, because storage of accessories is also very important. And because of the small trouble with the accessories, the whole transformer get stuck up for the commissioning. So in that case, we can have, because bushing, OLTC, even the air cell, even the breather, fan, all these are very important to commission the transformer, and therefore we should also get the papers from these our authors regarding the storage of these items, so that we can have a as a whole storage package for the transformer. With this, I open the session for the question answer, and we'll start with the in the chronologically, the paper 1, 2, 3, 4, 5. You can ask the question to Mr. Lakhani. Any question, please? Yes, please.
Good morning, everyone. I am from Telangana State Transmission Corporation Limited. Actually, being a state utility, we have been facing lot of challenges whenever we are going for enhancement of power transformers, as our Siemens representative has spoken over there. So recently, in the 2009 or 10, we had a very big transformer failure, 315 MVA, and that substation was loading was around 70%. So what we have to do, now we had another 400 kV substation where the loading was less. So instead of to meet that challenge, we got that one transformer dismantled at that substation, and we transported to the substation where the transformer has failed. Now the challenge, biggest challenge where we found was that the radiator bank, it was on the right hand side, and this particular make of the transformer radiator bank was on the left hand side. And this challenge, when we understood, we had to go for the similar foundations for the radiator bank. So now the entire structure was dismantled, and the new radiator bank foundations were made on the left hand side. So this was the biggest challenge phase. So as our Siemens representative has spoken, this is the first time in this platform that it has been spoken regarding the interchangeability. So I request him to consider this type of challenges which the state utilities are facing for replacement.
Right.
Yes.
I just want to add to that aspect that I've also included this part in the paper. I did not mention in my presentation that initially itself that we could include the provision of radiator banks on both sides. So what happens is that whenever maybe a utility wants to maybe switch a site wherein radiator banks are on the other side, it could already be taken care at the initial design phase itself in the specification. I think in some of the specifications, I think PGCL, I think in some cases has this already inbuilt, and similarly that could be included in the specification itself. So initial design itself is thought with the flip option as well. So I think this can also be taken care of. Yeah.
And I will just add to it that we have covered this aspect in the IMA standardization manual, You can just refer to it also for any other queries also. Right? Thank you. Yes, sir.
Sir, my name is Venkateshwarlu from TS Transco, Hyderabad. Sir, in respect of the smart replacement of large power transformers, actually in TS Transco also recently in the last 6 months we have faced one bushing failure of 350 MVA transformer. In the part of the smart replacement of large PTR, power transformers, okay, replacement, but in the component side, for example, that bushing, X-make bushing failure. So it is very difficult to happen to in replacement of the bushing because that is a old transformer. So I request Mr. Lakani Sahab, and you have studied any, and also you please, I request Trafotech also to standardization of irrespective of the make of transformers. Any happen this like bushings, you standardization of the bushings to fix up the any make of the bushing for that particular transformers. So this is very, very important, sir. I request Trafotech as well as EMA management. So any component can change for mainly this bushings for irrespective of the make of the transformers can study on the for replacement of the bushings. And number one is number two is the actually we are planning to restoration of all the replacement of OAP bushings in place of the RIP bushings. So that from 132 kV to 400 kV. So how can we restore? Because this is a very big task. Can I change that all the RIP bushings? Okay, we are ready to give the LC and like that. But what is the design point of view? Is that any possible? And next, yesterday actually I missed to, because I have not got opportunity to ask the question. So I request Trafotech and as well as this, instead of this 60 and one specification, one nation in the part of that, instead of 60 months standardization, that's warranty, you please make the 180 months because we don't worry about any short circuit, we don't include the short circuit and we don't want require any take care of this stage inspection also we will remove, sir. You please, I request management of Trafotech. Thank you.
Sir, yeah, I'll just respond to that.
Yes,
actually,
please.
I completely agree with you that harmonization of bushings, especially the RIP and the RIS, is already a challenge, and I think some of our colleagues from PGCR also mentioned that now they have taken up this also task of switching from OIP to RIP and RIS bushings, and harmonization is a challenge. I think it can be done. It just needs a little bit of a deep dive in terms of the arrangements into the air clearance. A little bit of study is required, but in my opinion, it can be done with a little bit of modifications in some cases, but it can be done. So that is what I can only suggest at this point. Yes, sir.
And second thing that, sir, you can refer to this EMA standardization manual. Therein, all the bushings, standardization is already being done, and we can simply replace the existing bushing with the new one. And regarding the any requirement of the your replacement of bushing, you can contact any of the manufacturer. Okay, they can also guide to you, and you can also share with means you can discuss with the power grid. They have replaced so many bushings from OIP to RIP.
I have one question. Can I ask?
Yes, please.
Thank
sir.
you. I would like to congratulate all the authors. They have done a very good presentation, and especially Arindam, you have done a very courageous act of repairing a bushing and then putting it in service. I must compliment you for that. But my question is for Mr. Jiva Parmar regarding the ester oil. So since you have used ester oil right from the beginning, you are knowing it was not a retrofit. So I am sure you must have done some changes in the reactor design for the electrical design. I think Jhala can answer that, right? My second question is that now you have put a ester-filled oil. It's a power grid is the customer for you. But what is your plan in monitoring how the oil is how this oil is performing, right? In this thing in the future, because power grid of course is going to monitor, I am sure. but it is also your responsibility, I feel, as a manufacturer, as a supplier. You should also see, because it is the first time in a 400 kV you are using it. So you do have any plan in place for by T&R? Jhala?
Thank you. Good questions. Yeah, I would like to answer the questions on behalf of Jiva Parmar. Yes, for this particular pilot project of this 420 kV shunt reactor, which was filled with the natural ester fluid. From very beginning, it was known that this will be filled with the natural ester fluid, and significant design changes were made, especially for the dielectric design. To accommodate this natural ester fluid. Some changes were done in the thermal design also, especially for the design of the radiators, increasing the size of the fluids, the headers, and the number of radiator banks, etc. So that was done. So coming to this monitoring plan, right now we are really not directly monitoring this shunt reactor. It has been done primarily by this power grid officials, but yes, we are interacting with power grid, on frequent basis, to understand the behavior of shunt reactor, especially the fluid properties in due course of time. But I take your suggestion, sir. We will also, put more efforts, to monitor this. Yeah.
Analysis. This will give a usability of this ester oil in the 400 kV and above later. Okay. So this kind of, you can also, they will be only doing the oil parameter monitoring, but you can think of some more monitoring of the reactor itself. How the reactor, other parameters are also performing, the electrical and all everything. Like, I feel you should do that. Sometimes some test we can suggest that you do this test, some high voltage test or something, or not high voltage, of course, there. The side it's a difficult thing. But it is my suggestion that you should think of some kind of testing plan, and you can suggest to power grid, and you can also be a part of that. That will give you a better insight of the use of this in 400 kV. Right. Thank you.
Coming to the same issue of ester oil-filled transformers and reactors, my personal opinion is that all these transformers should be hermetically sealed. Once you do that, most of the issues of oil getting moisture is reduced. It's a challenge, but it's not difficult, and if we really plan it thoroughly, we can do that. There are no issues of not doing it. And I just wanted to ask one question to Sivendra. Sivendra, while repairing the transformer at site, you were talking about the low IR value of this tank shunts. So how does it matter? Suppose if IR value of the volt shunt is low, how does it matter? Does it matter?
Sir, probably it is installed to minimize the eddy current losses inside the transformer. So, being a measurable parameter at site, it was required to be replaced.
But I think, Jhala, I think it is not required. The IR value for the volt shunt, it does not matter. Does not matter at all.
Sir,
many times it is welded to the tank. It's just welded to the tank. So anyway, it's okay.
Because we had measured the IR values. Those values are found to be very low, so it was decided by us to replace those with the healthy ones.
Yeah, but it is not required. That's what I'm saying.
Okay, sir.
Yeah.
Okay.
Okay.
We are running out of time, so I think we'll conclude this session if there is no any major question. Yeah, only one question we'll take, and then we'll stop.
My question is from Mr. Jiva. Whether during transportation of oil from works to your oil manufacturer works to your works, as well as from your works to site, was oil transported with nitrogen blanketing or not? If yes, is there any measures taken for expansion and contraction of the oil during transportation?
from the manufacturer of oil to factory is transported with nitrogen cushion, and yes, reactor also from factory to site sent with the nitrogen cushion. We have provided positive pressure on the reactor and monitoring this pressure.
The nitrogen cushion is being provided all the time while transporting and while storage at the factory and while filling in the transformer also. You got the point? Okay. So we here conclude this session. I am very much thankful to all the authors and given the insight of the transformer. And I also thank IMA and Trafotech to give this opportunity to chair this session. I declare this session is over. Thank you. Thank you all.
Thank you so much, Joshi sir, for wonderfully conducting the session. So from quality and testing to on-site storage, repair and replacement of equipment, leading to the O&M best practices, then that becomes the life cycle management. We have with us Mr. Ajay Sanghi, the past chairman of IMA DT division. I would request him to come up on the stage and felicitate our authors and the session chairman, please. I'll call the authors first. Mr. Komal Abbas Lakhani. Mr. Shivendra Mohan Pandey. Mr. Gautam Mazumdar. Mr. Jiva Parmar. Mr. Arindam Chakraborty. And our session chairman, Mr. Y.V. Joshi. I would request the authors to please join for the group photograph. A request to all the authors to please collect your charges for the mementos from here. Just like humans, the mementos needs to be charged. I request the audience to be seated because we are immediately starting with session number 4, Reliable O&M Practices and Life Cycle Management. Before I call upon the authors and session chairman on the dais, I would like to introduce them first. Session 4 will be chaired by Mr. B.N.D. Bhaumik. He is graduated in electrical engineering from IIT Kharagpur in the year 1983. Immediately after passing out, he joined the transmission wing of NTPC Limited, where he was thoroughly involved in commissioning of first 400 kV substation of NTPC and later as a part of centralized team for O&M of transmission assets in the region. He joined Power Grid in the year 1991 and retired in 2021 as the head of corporate technology development in Power Grid. Mr. Bhaumik is specialized in condition monitoring and diagnostics of transformers and other substation equipment. He was also directly involved in various new technology projects of Power Grid, including National Test Station at Bina, 1200 kV test station. Our author, Dr. Gajanan Jaiswal, he has done his BE Electrical, DBM, MBA, MTech, IPS and MIEI, and also holds PhD in Electrical Engineering. He is working as Executive Engineer with Mahadiscom. His field of expertise include condition monitoring, power system, distribution network, consumer satisfaction and resolving consumer issues. Mr. Shubdeep Sarkar, he has done his BTech in Electrical Engineering and works as Distribution Engineer in CESC Limited. His field of expertise include asset management of HV and EHV distribution plant and equipment. Ms. Prachi Sharma, she has done her BTech in Electrical Engineering and works as Distribution Engineer in CESC Limited. Her field of expertise includes distribution transformer fleet management, and she is looking after distribution transformer, package substations and its accessories, specifications and quality control. Mr. Shrikant Atsul, he has done his graduation in Electrical Engineering, works as Executive Engineer with Tata Power, and his field of expertise includes O&M of transmission substation, where his responsibilities encompass a diverse array of critical functions, including equipment maintenance, installation, and rigorous testing of electrical system. Mr. Joachim Schaldin, he has done his MS in Electrical Engineering and works as Product Manager with Megger Instruments Limited. His field of expertise includes transformer testing. I hand over the session to Mr. Bhaumik. Thank you.
Good afternoon to all. I think this edition of the Trafotech is very unique. We have got the maximum presentations, representations and all, and we have got very good papers so far. I'm sure this session also will give us a very good paper, and I have gone through most of the papers in this session. So without taking much time, I will start the session, and each author will get about slightly below 10 minutes, I would say 9.5 minutes or so. So I request all the authors to confine their presentation within that time. Thank you. I first call upon Mr. I'm sorry, I don't have this here. Yeah, Mr. Gajanan Jaiswal of MSc DCL for online condition monitoring technique to enhance reliability of transformers.
Good afternoon to all the dignitaries on the dais, my presentation topic is online condition monitoring techniques to enhancement the reliability of the transformer. As we know, every place we found at least one distribution transformer who is supplying the power supply to the end user. So condition monitoring of the distribution transformer is very important as it is located remotely. So failure of this distribution transformer not only affects the revenue loss of the utility, but it also affects the loss of the industrial consumer or the end user in terms of the production loss. So monitoring health status of this distribution transformer is very important in terms of the revenue loss, in terms of the production loss of the industrial consumer. Here some analysis of the transformer failure. So for the 3 years 2020-21, 2021-22 and 2022-23. So in 2020-21 the failure rate for this year is 12.32. For 21-22 is 12.67, is slightly increased, and 22-23 it is 7.91. So here our aim is to reduce the failure of the distribution transformer so that supply to the end user can be maintained properly and we provide the reliable power supply to the end user. Our utility focus this on this issue to reduce this 7.91 failure rate for 20 to 23, so it reduced to 5% or below the 5% at the end of the 24. So for this there are the three maintenance strategies mostly used, that is, one is the reactive, preventive and predictive. In reactive maintenance strategy we are replacing the asset when it fails, and in preventive maintenance strategy it's costly because it includes the maintenance and inspection cost. So we switch to the predictive maintenance strategy, which provides us the reliable power supply. So different various condition monitoring techniques are diagnostic approach, feature extraction algorithm, data fusion, cross sensor platform, temperature calibration techniques. There are two types of the monitoring techniques which includes the parameters, that is offline parameters and online parameters. So health index of the transformer is calculated on the basis of offline parameters as well as the online parameters. So offline parameters consider the age of transformer, loading factor, loading history, then maintenance interval and consumer category. On this basis of offline health index of this transformer is the function of aging, load factor, maintenance interval and the consumer category. Similarly, the online health index of the transformer is calculated. So here we are considered the parameters like the voltage unbalance, harmonic load current, power factor, efficiency deviation due to the internal fault, winding temperature and heat dissipation due to the lower oil level are the online parameters. Summation of this one is provides us the overall heat index of the transformer. Here offline parameters, that is the health index for the offline parameters considered as a 30%, because on the study of the past record of the transformer failure, the 29.4% transformer found due to the offline parameters. So here we considered it as a 30% transformer failed due to the offline parameter and 70% parameters transformer failed due to the online parameters. So on this basis we calculate this table. 85 to 100% health index is good, that is the normal maintenance. 65 to 85% fair, increase periodical maintenance. 50 to 65% is the poor health index, start process to replace it because before disturbing the power supply, and 0 to 50% is very poor, immediate assess the risks. This is the experimental setup. We done experimental analysis in the lab. For this one, as there is no 11 kV supply in the lab, so we specially designed the transformer which is having the capacity 15 kVA, 3-phase transformer, and ratio is 400 volt to 400 volt. Different accessories is included here. Energy meters used for observation of the load current, load voltage, power factor. PT 100 type temperature sensor is used to record the temperature, top oil temperature. Again ultrasonic sensor is used here to measure the oil level of this transformer. Processor here used the Raspberry Pi 2 processor is used to provide the health index of transformer by using the algorithm here. The experiment setup, we here performs the different analysis for the normal conditions. We have kept the transformer oil normal, voltage normal, loading current normal, and we find the health index is here 100%. The second condition, we use the abnormal condition. There is the change in the supply voltage, that is the unbalance, providing the unbalanced voltage with the help of the 3-phase auto transformer from the primary side, and when we disturb the voltage on the primary side, so there is a reduction in the health index of the transformer, and that point 94%. Second condition is the change in the load. So when we are increasing the load beyond the rated capacity, 95%, if you assume the total load, normal load, we increase the loading of the transformer above the 90%. So we again the temperature of the top oil temperature of the transformer increase, and here is the health index reduced it, and it found as a 84%. Second case, change in the oil level. So oil level observation is done कि we are reducing the oil level 10%, and we are noting the parameters. So these all experimental parameters noted for the interval of first 5 minutes, then again 30 minutes, and samples are taken, and on this basis we are here observed that the health index of the transformer is a major factor to avoid the failure and to provide the reliable of power supply to the end user. On this experimental setup and experimental result, we found that we filed the patent, and on the 23rd October 2023, Office of the Indian Patent, we granted the patent on this particular issue of the online condition monitoring of transformer, and I am very thankful, and this is the need.
Can you please conclude, please?
Yeah, this is the need of our society to provide the utility, to provide the reliable supply to the end user of the our end user. I am very much thankful to the IMA and Trafotech and our utility to given me opportunity to present here such type of paper on this big dash. Thank you very much.
Thank you, Mr. Gajanand. That was a very insightful paper, and you have done a lot of good work. So, next will be Mr. Shubhadeep Sarkar from CESC for Transformer Health Deterioration Indexing in CESC. पेंसिल कहाँ चला गया? मैं पेंसिल रखा था.
A very good afternoon to everyone. I am Shubhadeep Sarkar. Today I am going to present my paper, which is titled Transformer Health Deterioration Indexing in CSC Limited. Health indexing is the process by which each and every transformer in a particular population is given a score based on its health condition. Now there are different methods by which the health condition can be assessed, like time-based maintenance, time-based condition monitoring, online condition monitoring. Now the scoring is done based on various physical test parameters, which can be intrusive and non-intrusive, operational conditions and physical inspection reports. Now this conventional method of health indexing has some challenges and constraints. Now first of all, the damage to the insulation system is irreversible. Now let's consider a case, a transformer that has been operating in a critical condition for a prolonged period of time, and take another transformer that has been operating in good condition, but for some reasons some of its parameters has deteriorated to the same level of criticality. Now when it comes to health indexing, both of them will be scored the same, but in reality the transformer that has operated in the critical condition for a prolonged period of time, that will have suffered more deterioration, So this differentiation cannot be made by means of conventional health indexing. Older transformers will tend to attain higher scores because usually age is considered as a parameter. Now, there might be cases when a new transformer might need more attention because of the rate of deterioration. Next, the rate of deterioration cannot be assessed by conventional health indexing data. So, in order to overcome the challenges, the concept of health deterioration indexing has been introduced. It considers both the past condition as well as the present condition. The past condition represents the irreversible impacts on the insulation, whereas the present condition reflects the parameters, the conditions that can be worked upon and can be improved by necessary corrective actions. Now, the parameters that are considered for present condition are moisture content, overall insulation condition, oil condition, bushing condition, OLTC condition. Now, for the past condition, the parameters that are considered are service life, which is basically the operational age of the transformer. Now, the moisture operation, acid operation and thermal operation, these are there to capture the operational history. We know that due to thermal operation, the aging of insulation occurs, and moisture, acidity, these are the aging accelerators. Now, the longer a transformer operates in a critical condition, the deterioration that happens, that is irreversible on the insulation. Now, to capture this irreversible effect, what has been done, these three parameters are basically summation of all the past condition scores. Now, this summated value, it is scaled down accordingly to bring them to a scale of 10, 0 being suggesting no deterioration and 10 suggesting the maximum deterioration. So, this way the irreversible impact has been we have tried to capture the irreversible impact. Then furan concentration is considered, DGA history, that is also taken into consideration by this similar manner. Now, a web-based platform has been developed to implement this health deterioration indexing. This is the overall condition dashboard that is shown here, and overall condition is given by the summation of the present condition score and the past condition score. And one interesting feature is that on the bottom left side, there is a graph, overall condition versus age, and here all that transformers are plotted. Now, if we consider an imaginary straight line through this, so we can easily identify some assets that are lying quite too far outside that straight line. So, they basically draw the attention of the asset managers. So, we can do some deep diving and find out what's wrong. And there are other salient features like per unit deterioration. This is given by the ratio present condition score to past condition score. So, this parameter highlights such cases like a transformer that has been operating in good condition till now, but because of some reason its condition has deteriorated. So, such cases will be highlighted because this ratio will be high. In this way, then there is a deterioration rate, that is increase in present condition score over a period of 3 to 5 years divided by number of years. This helps identify the fast deteriorating transformers. Then finally, another feature that has been incorporated is based on the present condition score, it recommends some corrective actions like oil filtration, dehydration, etc. that needs to be performed, and also the cost involved in order to perform that particular action and the return on investment. So, this with all this information, it is helpful for the asset manager to prioritize for the purpose of prioritization and for deciding on the corrective actions that need to be performed. Now, there are some limitations of this model. The manufacturing efficiency has an impact on the life expectancy of the transformer. This could not be modeled in the this could not be incorporated in this model. And next, the deterioration rate. I mean, the parameters that has been considered, they are all average parameters, but the deterioration is never uniform all throughout the transformer. So this could also not be modeled here, and presently we are thinking about incorporating them. We are currently working. Now there are future scope of work, that is network and location based risk indexing. This will help us identify the transformers that are very crucial from the network reliability point of view, and incorporation of solid insulation moisture content. This will help us get a better moisture profile of our assets. Thank you.
Thank you, Shubhadeep. That was a very good paper, good insights. So my next speaker is again from CESC, Asset Management of Distribution Transformer Fleet by Analysis of Winding Failure by Prachi Sharma.
Good afternoon to all. I'm Prachi Sharma and I shall be presenting my paper on Asset Management of Distribution Transformer Fleet by Analysis of Winding Failure. To start with, let's have a look at the SWOT analysis of DTR asset management in the Indian context. When we say DTR asset management, as a utility person, there are certain things that makes my task easy, which can be thought of as strengths. There are certain things which make it challenging, which can be thought of as weaknesses. There are certain opportunities up for grab. At the same time, there are certain risks associated with operation which can be envisaged as threats. Let's try to understand this one by one. First, the strengths. Asset management. This itself is a time-proven methodology. So we are not dealing with something new. Instead, we have to build upon our experiences from the past. Next is a relatively low per unit cost of distribution transformers that gives you the ease of experimentation. Another advantage is the relatively localized impact of outage. Let's have a look at the challenges. These include a very high and scattered population, a very low asset to manpower ratio, uneconomical time-based monitoring and intrusive condition monitoring, along with a challenge to mitigate a very high failure rate closing to about 10% in terms of national average. So now let's look at some of the opportunities amidst these challenges. Statistics show that developed countries have a failure rate of about 2 to 3%. So definitely there is a scope of improvement. And if we are able to bring down this failure rate, we'll also be able to enhance our operational efficiency and at the same time reduce the national asset bleeding. To think of the risks that are associated with the operation, any small change, say you want to bring about in the entire DTR population, it will incur a huge cost both on CAPEX and OPEX. Since the location is in public places, you have to be cautious about the safety. So having had looked at various aspects in terms of a SWOT analysis, one thing is clear, that distribution transformers are different from the high value assets like power transformers, switch gears. Hence, the conventional philosophy of maintenance that we use for high value assets like power transformers and switch gears are not suitable in this case. Instead, we have to go for something like asset management that focuses on the overall health alleviation of the entire population. So, any small change in design, maybe any small impetus on a quality parameter, any small change in the operational methodology that has the potential to bring about a positive change in the asset life shall be taken up. Now the question comes, how do we identify those small changes? In order to understand this, let's first look at the asset management process flow. This begins with an asset knowledge enabler, which is a system that captures everything about your asset, starting from its indent, to purchase, installation, breakdowns, maintenance, research and development, everything. This gives the basis of DTR asset management. The next task is the quality, risk and efficiency review of the assets which are already in service. At the same time, you also have to keep an eye on the technological changes and developments happening in the outside world. Combining these paves the way for research and development, which again has to pass through this cycle. In the context of the paper, our focus has been quality, risk and efficiency review. And one way of doing this is the analysis of winding failures. And having analyzed the winding failures in our system, we have come up with the following causes: natural aging, water ingression, overloading, accelerated aging, in-tank flash, some manufacturing defect, mechanical failure, winding hotspot, core insulation failure, or an ingression of foreign object. These are some of the impressions that we have observed. The one on the extreme left is natural aging. You can see the entire coil has deteriorated, oil has become sludgy. You have your asset knowledge enabler, so you can verify the findings. Next is an example of water ingression. The failure is usually localized at the bottom coils of HV winding. There is always some sort of evidence of entrance ports, like you can find some hole on conservator top or the explosion vent, or you can find brittle gaskets. Next is a failure due to overloading, more common in the dry type transformers. The impact is usually towards the ALT coil, but in most cases the impressions can be seen on top coils of HV winding. Next is an example of core failure. This can be both the mechanical failure of core and the failure of laminations, insulation. Next is a failure due to accelerated aging. This can happen because of too much moisture or because of the cooling circuit getting choked. We have mechanical failure. You can see in such cases there is huge displacement of axial and radial displacement of windings, usually accompanied by some fault in LT network. The impact on tapped coils is more because of the obviously relatively poorer mechanical strength. Next is a failure due to winding hotspot. May happen because of improper brazing. Next is a manufacturing defect. We observed that the insulation was not as per our specifications. So what exactly did we do with these findings? First of all, what we did was prioritize our cases, like prioritize the percent according to the percentage, the failure modes, and what needs to be acted upon. So these are some examples of modifications that we did. The first one is done with an aim to arrest the cases of accelerated aging arising out of choked cooling circuit. The top of the radiator valve was positioned below the LT bushing so that even if there is some leakage from LT bushings, the circulation never stops. So it's not like we are preventing oil leakage, but we are teaching the transformers to survive with that defect. Next is the modification of position of vent pipe and conservator, positioned at the side of the tank along with a deflector plate so that no rust particle, even if rusting occurs, falls on the windings. Next is modification of tapling board, use of slanted tapling boards and then phase segregated ones with an aim to prevent sludge accumulation. Later we observed that the tap changing requirement in our system was very less. So we decided to eliminate the tapling arrangement altogether. This also gives us better mechanical strength and also arrests the cases of in-tank flash. The one on the right shows the painting of DTRs at site that we have taken up recently. We aim to paint the DTRs at least once every 5 to 6 years because this was one major source of failure, ingression of water. Additionally, we have a quality control team that is tasked to review specifications. That also looks after the manufacturing and refurbishment quality, overhauling at go-downs, and also the quality of spares and accessories. Now, for some cases like overloading, we needed the help with technology. In order to do so, all our distribution transformers are now equipped with smart meters.
Time is almost up.
This allows a better load monitoring. this also gives us, this also allows geographical mapping of overloaded and underloaded sources. Hence, we are able to better utilize our assets. The one on the extreme right is just the asset knowledge enabler, which we talked about. So, apart from this, we have also taken up technologies that are coming up, like the IoT-based remote monitoring of critical assets and AI and ML-based dynamic health indexing, that with an aim to, that will help us making data-backed decisions, especially regarding investments. So that was all. To conclude, the paper's aim was to highlight our practices, at the same time inspire, or I would say that request other utilities to share their asset management practices, so that we at a time can take up this practice, find out what suits our requirement and reduce the failure rate. Thanks.
Thank you, Prachi. It's a very good paper. I must compliment you. My next paper in this session is by Mr. Srikant Atsul of Tata Power, Analysis of Electromechanical Stresses Due to Closed Terminal Fault on a 250 MVA Auto Transformer. Case study.
Good afternoon all. Basically, my paper is just a case study of one of the 250 MVA ICT, which is auto transformer at our 220 kV substation. Basically, as all we know that Mumbai MMR region transmission network is one of the oldest network in India, and the ICTs plays a crucial or the ICTs are the crucial transmission elements of the 220 kV or 110 kV grid, and overall the Mumbai network is supported by the 220 kV or 110 kV grids. So at Mumbai MMR, Tata Power has total 30 substations, out of which most of the substations are 220 and 110 kV. And as we all know that the total power requirement of Mumbai, out of which 60% power is catered through the outside network, which are connected to the Mumbai MMR through the tie lines, and 60% of power is from the other regions of the India. And ICTs at tap point plays crucial role in stepping down the power or transforming the power from 220 kV grid to the 110 kV grid. Now here the ICT under consideration is connected to between the 220 and 110 kV grid, and as we all know the 110 kV grid or the 110 kV overhead sector is suffer from the various faults, and all these faults are fed by the ICTs which are connected to the grid. And as the as the ICT fed the fault, as here from the formula we can see that the radial forces acting on the winding are directly proportional to the fault fed by the ICT or the transformer. Now, if we focus on the table, we can see that there are total 4 such faults which are very close terminal faults, and out of these 4 close terminal faults, 3 faults where the fault current fed by the ICT was close to the its short circuit rated capacity. And from the formula we can see that the axial forces on the winding are directly proportional to square of the fault current. So the very high fault current, very high radial stresses were experienced by the ICTs, and due to which, as the LV winding is close to the core of the ICT, so LV winding experienced the very large radial forces experiencing or deforming into the amoeba-like shape as shown into the figure, and HV winding is slightly away from the core, so they experience the outward forces. Now, after the closed terminal fault and the ICT under consideration gives some abnormal humming noise along with the vibrations, and due to the abnormal vibrations, the minor leakage, oil leakage started from the ST turret CT and ICT neutral bushing and OLTC chamber. And as this oil leakage was totally abnormal and humming noise was totally abnormal, this prompted a decision to take the ICT out of the service and to carry out electrical diagnostic testing. As we all know, we cannot afford to lose or failure of the ICT because it will make our whole grid unstable, and it can cause the further disaster. And after the carrying out the test, the SFRA played very crucial role, as the SFRA shows that the variation into the winding region. Here the SFRA graph of the short circuit test shown, and as we can see that there is a large variation into the high frequency range, which showed that there is a deformation into the winding region. And also the SFRA for the open circuit was carried out, but no major defect were observed into the low frequency region. Also, the DGA provided some significant understanding, as we can see that the DGA, the rising trend of ethane, methane and ethylene were observed, which showed that there is a fault into the thermal faults present into the transformer, and also CO2 by CO ratio was also increased to the 12 as compared to the previous readings from the November 2021. And also the dual strangle played a crucial role in providing the understanding about the insulation of the winding. As we can see that before taking out the before the closed terminal faults, the dual strangle showed that in triangle 1 the thermal fault was present into the oscillating between the region T1 and T2. But after the closed terminal fault on 29th September, the DGA analysis oil sample was collected, and also the dual strangle was plotted, and which showed that the thermal fault was shifted into the region T3, and some similar sudden transition were also observed into the triangle 2 and triangle 5. And after that, the critical decision was taken to send the ICT at the repair shop for the further investigation and testing. And at the repair shop, through analysis of the core coil assembly was carried out of the ICT, and during the core coil assembly, LV winding was shown totally deformed. All the 3 LV windings of the ICT can be seen like vertical buckling and manifesting the deformity, which looks like the amoeba-like shape, and the protrude section of the LV winding was forcing the MV winding, which caused the MV winding also the oblong. And after that, the decision which was taken to cut out the ICT was proved strongly corrected, and the overall results of the SFRA and DGA tests were provided total tangible and physical results as we observed into the SFRA and dual strangle at the time of the inspection at the repair shop. So the conclusion of this paper, or the significance of this paper, is that how important the real-time effective condition monitoring is. Because during the condition monitoring or manual condition monitoring, we have to connect with our equipment, so that whether the minor changes into the noise or the vibration of the transformer or any other equipment could be noticed immediately, and the effective actions can be taken, so that the further fault or the instability or faults into the system can be avoided. Also, it underscores the productive information, preserving the overall reliability and the reliability and stability of the grid. Thank you.
Thank you. Thank you for keeping in time. Thank you. Now the next paper is from Megar, Mr. Joachim Skolden, validating line frequency dissipation factor for reliable transformer condition assessment.
IEMA organizers and honorable delegates, thank you for taking the time to listen to me.
Can someone reset the timer, please? Yes,
Yeah.
okay. Please carry on.
So, while they are resetting the timer, I will talk about the line frequency dissipation factor, or tan delta power factor results for the transformers. It is a paper presented by Diego Robalino, me, and Ankit Purval. In order to describe and talk about the dissipation factor, I really would like to take some assumptions. I will assume you know what tan delta power factor is. My assumption is this is an important value because it is a factor of the solid insulation. When the solid insulation fails, your asset will need to be scrapped, because the solid insulation is the fundamental mechanical property of your transformer. Another important part of this is history. This is not a new test. It has been done for many years. And the line frequency value has been looked upon for 100 years. And there has been some advancement of this technology over the years. In 1990, as an homage to the technology and what we are doing here, sharing the information, the line frequency was actually taken at not the actual line frequency, and it was changed, and the measurements was done slightly off the actual line frequency itself. This opened up the opportunity, and after that, you started to make more measurements at even wider frequencies. And as history progressed, this has then developed into two different tests. One is described very well in SIGRE Technical Brochure 445, which was released in 2011. It is also described in the same way in IEEE C57, where you actually split the different test methods in two versions. One is the basic test, the line frequency, and then the advanced test, which is the wide frequency measurements. When you look at these results, the assessment is quite different. For the line frequency, you basically do a time comparison. You look at your dissipation factor value at different times, and you have an example here as a transformer is progressing over the years. And you can look at the acceptable level, and when you're above, it is not okay. While for the wide frequency, the actual result is the moisture content in the solid insulation. This is, however, important because as this has given us more information about the behavior of tan delta. And what we have determined and what we can see is that tan delta is changing based on a number of different factors, such as the frequency, the temperature, the moisture content of the solid insulation, as well as the quality of the oil. Now, if we then take the Arrhenius equation, the Arrhenius equation is one of the key factors in this paper. What the Arrhenius equation tells us is that if you take a number of frequency measurements, you can actually correlate the frequency to different temperatures. So if we see this as an equation system where you have two unknown, but you can then determine one by the other, you can actually then make your tan delta as a function of frequency and eliminate the temperature itself. So then this Arrhenius equation will help us to better understand the behavior of tan delta. So now, if I go back to the earliest picture where we do the assessment of the results, we can start to question ourselves, why is this values not going consistently up? Why are they going up, down, and so on? Because we have a lot of factors which we do not have control of. So what we have seen is with this frequency measurement, you can actually eliminate the temperature behavior of that tan delta. And I would almost assure you that you would see a much more consistent line unless you have done some specific treatment to this specific transformer. So what that leads us to is the next point of this paper. We come somewhere in between. So if I take the line frequency test, which is done at 50 or 60 hertz, or the advanced tests, which is done typically from 1 millihertz to 1000 hertz, and I do something in between, like 1 hertz to 500 hertz, I can actually use those frequency measurements to enable proper temperature correction, and I will also be able to see faults a little bit earlier. And it can help validate your normal line frequency measurement. This test would, of course, be part of your basic test, and it would just be an additional few minutes just to help you get a more accurate value. What I talk about with the 1 hertz is if I look for the tan delta values for normal paper at standard 60-50 hertz. I can also see the frequency behavior, and I can see at lower frequencies I have a slightly better resolution, which means it's much easier to see an earlier fault coming up much earlier. Together with this, we have also suggested some limits for the 1 hertz value to better help you understand this type of value. Now, as a last slide, I will show you an example. This, what I have been talking about, is of course for the transformers, but you can also apply this method on bushings. And if you take 3 bushings, where you have done the normal tan delta measurements at 50 hertz, you can see the 2 top bushings, H1, H2, are good, while the third one is slightly questionable. While when you look at the 1 hertz measurement, you can also see that, well, when you look at the 1 hertz data, it actually shows up a little bit more red, meaning that you can actually treat it with a slightly higher alarm. Thank you. That was the essence of everything.
Thank you, Joachim. It's a good paper, it's a good understanding. So before I throw the dais for the, for the question answer, I will not limit one by one. Anybody can ask questions to any of the authors, and I will request the authors to answer to the best of their ability. Before that, I would just like to mention one or two few points in this. The 2 papers on these distribution transformers. One was from MSCDCL and another from the CESC, and that was, I feel they are one of the very good papers, and if the distribution companies follow such practice, probably they will be able to control the failure rates of the DTS. I must compliment them for these papers, and about the CESC's paper on the winding failure, that is a very good analysis. And then, having said that, the Joachim had provided very good reasons why you should go for this wide frequency tan delta measurements and a better understanding of this method. CESC's other paper on the health indexing has also brought tried to give a new concept on the health deterioration index, which is generally we only talk about the health index in general, but they have brought out the concept of the health deterioration index. That was a good paper. And the lastly, but not the least, the paper from the Tata Power by Mr. Srikant Atsul. I feel that was a very good analysis of the fault what you have got, and that is a great learning from this paper. So now I would request to throw this dais open for the questioning. So we can have about some 10 minutes. About 10 minutes we will have the question answer, and then we will close this. Thank you.
Good afternoon.
Yes, please. Please ask your question. And you have the mic with you?
I am here.
Okay. Please provide the mic to whoever is asking questions. Kindly introduce yourself in one sentence and then ask the questions. Thank you.
This is Asad from Voltam, Oman. I'm asking the lady regarding your paper. You mentioned that the brazing, it will be affect the failure. So if we are using the crimping instead of brazing, it will be affect again?
Sir, I'm not very sure if that practice is done in case of distribution transformers, because for making coil joints, what I have observed, what manufacturers usually do is they join the coils with a brazing material, which often is a cause of high resistance at that point, and there is a hotspot. Crimping, with crimping, there is always a chance that the connections may come out. It poses greater chance of open circuit. So, as per my knowledge, since we do not have any experience with that, I can't really say if that would be effective, but our concern regarding that is open circuit of connections.
Thank you.
Hello.
Please switch on your mic.
Hello, I am Dr. Narasimhan from Savita Oil Technologies. My question is for the CASC paper on the deterioration rate index. If I saw it rightly, you have talked about acidity, moisture, and these are the two main parameters I saw on the slide. But then, did you take into account the temperature? Because the paper deterioration takes place essentially by two factors, mainly moisture and temperature. These two have very immense impact on the paper. So when we are looking at the past condition or the present condition, these two, the temperature plays a major role in terms of, that you can make an assessment in terms of the loading factor over the years or direct temperature measurement. So I didn't seem to see that being presented in the paper. So how did you take that into account?
Sir, temperature has not been taken into account, but the loading condition, the maximum loading that the transformer serves was taken into account, and that was in the past condition. So basically, so that way we tried to incorporate that.
Okay.
Hello. There is one question to Prachi. That how is your experience of this failure of distribution transformer in your CACS regarding the winding material particularly?
Sir, the winding failure rate in 2012-13, it was about 1.2% of the entire population. In 2022-3, the last data which we are having, it was less than 0.4%.
Okay, what is the population?
It's about 8,500, a little over 8,500.
Okay, all you have a copper wound transformer or?
No, yes, all copper wounds.
Okay.
Very like 2 to 3 aluminium wound, but that's only for trial purpose.
Okay. Next question to Mr. Gajanan. You have considered the in health index the power losses. So how it will be possible in a transformer which is in service to measure the losses on continuous basis? Yeah.
Sir, in our experimental setup, we are using the energy meters, electronics energy meters. So this we are using the data from the energy meter, that's the voltage and current and power factors. So on this basis of we are measuring the power losses, calculating the power losses, and that complete data fed to our processing units, and accordingly the health index of the transformers calculated, and once the health index of the transformer is found beyond the limit or deteriorated, that's given command to the remote end where our control room or the utility engineers to take the decision whether to keep that transformer in service or send for the replacements. In this way we are also calculating the power losses, and there is again facility in our algorithm to add any type of parameters to add this, such as capacitors, banks monitoring, or any other image monitoring. If you are fitting the microphones to the tank of the transformer, so that noise of the transformer also can be monitored, and or that parameter also should be considered in the calculation of the head index.
Okay, thank you.
Thank you.
Any other question? Yes, there.
Hello, sir. My question is regarding the variable frequency tan delta measurement, sir. Actually, what is the typical time required to measure in the frequency range from 1 millihertz to 1 kilohertz?
That it's
that is depending on which type of technique you use. But if you take a 1 millihertz signal, it's a sinusoidal signal. 1 millihertz is 1,000 seconds, which is 17 minutes. So just for one frequency point, it is 17 minutes. Then taking 2 millihertz is another 8 minutes. So you can go up for up to 2-3 hours or so if you would like to. But typically, what is done now, you do that whole measurement at around 25 minutes.
Yes, sir. At site, this is the problem we are facing, sir. We are having the test kit, but it is taking very long time of around 2.5 hours to 3 hours. But during the routine maintenance, this variable frequency measurement is a little difficult for the outage. Any solution in that direction, sir?
Which stop frequency do you use?
Sir, we are using 1 millihertz to 1 kilohertz, sir.
1 millihertz to 1
kilohertz. And the kit is having provision for 0.01 millihertz. But we are not going to 0.0 millihertz. It is showing the estimated time around 6 hours or 7 hours, sir. Sometimes at the end of 7th hour, we will be resulting in some connection issue and all. But when we are doing it 1 millihertz to 1 kilohertz, the typical time is 1 hour 20 minutes, 1 hour 10 minutes between the phases and also. But what I am feeling is this is a very special test we can do as a root cause analysis thing. But during the routine maintenance, we are finding it difficult to accommodate in the outage time to carry out the tests. Any solution for that?
There are a few comments, I would say. Solutions, there are a few, but comments is, if you do the separation between the two tests, one is basic, which is basically just the line frequency. The other one is an advanced test. An advanced test, is that a routine test? That is one question I would ask myself. So how often would you like to determine the moisture content? How often do you do those type of actual measurements? How relevant is it? How quickly does the moisture content increase? If you take all those factors into account, should that really be a routine test? What I'm saying and what I'm proposing in the paper we presented is you do the basic test, which is line frequency, and then you do a smaller frequency range, not the full 1 millihertz to 1000 hertz. If you would like to do the full frequency, there are a few solutions. The problem, what you're facing or what you're describing, is basically if you're in a high voltage interference substation, then you have an interference issue. You can then increase the test voltage. That will give you a better measurement. So it should be also a shorter time because you would need less integration. You could also look at how you apply the voltages. There are a few techniques where you switch between time and frequency domain, or where you do a multiple frequency injection, where you actually inject more frequencies at the same time. This will also reduce the test time. That's the whole purpose of these two different techniques of doing this. Time frequency, interchangeability, and multiple frequency injection. The other thing I could mention about that is also how far down in frequency you go. I say we mentioned 1 millihertz, but do you really need to go down to 1 millihertz for a service-aged transformer? Especially here in India, where the transformer insulation can be quite warm. Then I would actually question, do you really need to go to 1 millihertz, or is 2 millihertz sufficient?
Thank you. Do you have any other question?
Thank you, sir.
Yes, please. Please introduce yourself first.
Myself, Ravish Kumar from CSPCL Raipur. My question is from Subhadeep. In your paper, you have shown health deterioration index, different conditions, consider different conditions in present and past. But you have given equal importance to all conditions, all conditions like moisture or acidic or service life. But I think each condition will have different effect on transformer deterioration. They have different weightage. I think in a linear way, it will give incorrect result regarding health deterioration index of transformer. All have some different type of effects. What do you have to say?
Sir, actually, in the original formulas, that are used to create this platform, wave-based platform, the weighing factors are considered, but it is still at its trial stage. We have started with weighing factors 1 for all the parameters. Now, so far it has worked fine for us, but in future we will try with different varying weighing factors for different parameters to get better insights.
Okay, I think transformer has a very complex characteristics, and all factors, if all factors can be put together in a some rational method, then it will be very good result.
I do agree with you.
Thanks for the suggestions.
Okay, thank you.
I do agree with him because there are different conditions and different deteriorations, and there should be some weightages. So I suggest you should implement that, the weightage part, and sometime you should also see that the total health index number may be very good, but one or two components can completely fail the transformer. Okay, so that also to take care while doing it. So like say bushing, if the bushing condition is bad, the overall whole thing index could be high, but the one bushing failure can cause a total transformer loss. So these are the factors probably we have to incorporate, then it will be a very good index. Any other question, please? Yeah, please introduce yourself. Thank you.
Good afternoon all. My name is Bhumi Patel and I am from ERDA. My question is to Ms. Prachi Sharma. What was the failure rate for core failure and core insulation failure?
Core insulation failure, what we had observed in the past was mainly mechanical insulation of the failure. In the event of fault in LT network, the laminations used to get displaced. So for that reason, we took some measures, like we used additional clamping arrangements on top. So that gives a better hold or support to the coil arrangement. Core arrangement.
Okay.
So after that, we have observed that core failures have more or less been arrested. At present, in the past 2 years, I don't recall seeing any core failure.
And what about core insulation failure?
Core insulation failure is usually accompanied by some sort of overheating. Means I would say that suppose there was a fire in a cable. So that fire spread somehow to the LT box and it also had an impact on the windings. At that time, you will see that otherwise what we do is reuse the core. So like in normal cases, if the winding has failed but the core is okay, we reuse the core. But in that situation, we find that the core insulation has also got damaged. So we have to go for core replacement. So
any failure, percentage of failure rate is?
Percentage of failure, it's usually very less. I mean, if you see the contribution, it would be maybe 0.1% or even less than 0.05% around that.
Okay, ma'am.
Last 2 years, we haven't observed any. So current data regarding that failure, I don't have.
Okay, ma'am. Thank you.
Yeah, Bhumikji, this side, your left side.
Yes, sir. Please.
Actually, this is not the query. Bhumikji, this side. P.K. Patel.
Oh, acha, Mr. P.K. Patel. I know because. Okay, you please ask your question. Then Mr. Mamtara will ask.
Yeah, okay.
So, sir, just give me a moment, sir. Thank you.
I'm sorry, Mamtara sir. Actually, this is not the question. It is actually a sharing of a practice of utility. Basically, the very good question came from the variable frequency measurement and all. So here I mean to just address this house and to share one of our experiences. Our experiences basically, we do not go for this variable frequency measurement. This basically not been the routine kind of measurement. It is the special. Whenever the we can say your moisture content is becoming of objectionable or some other symptom is coming which is of need of the way to go for. That time we go for the variable frequency. So hope so also we can save the time and we can get to know, because the factor of keeping the transformer out is definitely it will be hampered to the commercial matter. That's why this is the way we are going for, as per our way. This is one of the suggestions.
Okay, this is the just philosophy of the each company will have, it depends on that. So sir, Mr. Mamtora.
Prachi, these questions to you, these are not the questions, these are my observations. I've seen some of the photographs which you had seen. One of the transformer was totally dark. So it is not a failure because of overheating or anything. It was because of the oil was removed from the transformer. I'm telling you that. I can work on that. There was no oil. The oil has been, there was a theft of the oil from the transformer.
Yeah, sir.
And then only it will happen. Otherwise, this kind of failure cannot happen.
Yes, what you are talking, absolutely, that was a failure. That's why I said the cooling circuit failure, because oil was removed at that time. It was a theft of oil, you're right.
And then another thing is, the failure of the core, core does not come out just like that. Core can come out only and only if there is a short circuit. If there is a short circuit, the core can move up, because of the top ring on the winding, because of the forces, axial forces, it will push the core up. So we have a practice of clamping the core, top core also and bottom core also. That is generally clamped. So it should not happen, but I don't know how it happened. And can you tell me what is the percentage of the oil theft from the transformer in Kolkata? Because I belong to Kolkata. I am born and brought up in Kolkata. Yeah?
Sir, first to add to what you said, that was absolutely a short circuit. That's why when she asked, I also said that it usually happens when there is a fault in the network. So clamping arrangement was not there on that transformer, that particular picture which you saw. So that was the reason. And regarding the oil theft, this has reduced, because one arrangement which I have already shown in that picture, you would see that the conservators and the whatever openings are there, they are guarded with rails. So that prevents anybody to just put a pipe and then drain out the oil. So that has helped us a lot in controlling the oil theft. Currently, we do not see such cases. Like those cases only come to highlight when you see the failed transformers returning from site. Such failures, what we have observed in the recent past, have been very limited. So I assume that they are not happening.
See, the Gujarat has a good practice of smaller transformer fully welded, hermetically sealed. Have you ever thought of going for that?
Sir, in our system, the transformers KVA range from 315 to 500.
Doesn't matter.
We were at present we were having a consideration of such transformer, but our consideration was whether negative pressure in the event of cooling or sudden load change, whether it will have some impact on the you can say that there are two things that we were concerned about. One was the mechanical strength of the outer arrangement, and the second was the moisture content of the paper windings, that tends to come out. So regarding both these considerations, we were not very sure about whether to proceed. So we have kept it at halt, but hermetically sealed transformers are not there in the system.
The moisture from the, see what happens, moisture when the transformer is getting heated up, paper releases the moisture to the oil, and when it cools down, it gets the moisture back to the winding, right, to the insulation. So it is not that the moisture can get into the transformer without any leakages. If there is a leakage, then only moisture can get out. If the breathers are not maintained properly, then maybe, while inhaling and exhaling the air through the breather, it may get some moisture. But hermetically sealed, you don't have to do anything. And for hermetically sealed transformer, you can go for, not the regular radiators, but the fins. So that, that will expand and that will contract when, so it becomes very easy. Anyway, we'll talk about it later on because...
Sir, sure, that's something which I need to discuss, because we are definitely planning for hermetically sealed ones, but we have not arrived at a conclusion. So, thank you, sir. Thank you.
Okay, thank you. I think to to, for the constraint of time, we have to close the session now, but all the authors will be available during the lunch, so you can always network with them and you can also ask questions them, so there is no harm in that. So, I mean, there is nobody is preventing you. So, with this, I would like to close this session, and I must compliment all the authors for giving us a very good presentations. Thank you.
Thank you so much, Mr. Bhaumik, for very crisply and wonderfully conducting this session. We are privileged to have with us Mr. A.K. Dhagat, past President IMA and a legendary leader of the industry. Sir, I would like to invite you upon the stage to felicitate the authors and session chairman. I would like to invite the authors first, Mr. Gajanan Jaiswal. Mr. Shubdeep Sarkar. Ms. Prachi Sharma. Mr. Shrikant Adsul. Mr. Yosim Skaldin. And our session chairman, Mr. B.N.D. Bhaumik. I would request Dhagat sir and Mr. Bhaumik and all the authors to please assemble for the photograph. Thank you so much, Mr. Dhagat, for doing the honors, and the session chairman and all the authors. We'll break for lunch now and we'll resume the next session at 2:45, session number 5 on emerging trends. Thank you.
Losses in transformers add up over the lifetime, resulting in significant carbon emissions and wasted power that could be saved by transformers with enhanced energy efficiency. Transformers contain large volumes of material which, through intelligent design and use of material, can be made more sustainable. Eliminating mineral oil leakages for protecting surrounding ecosystems and enhancing safety is vital. In addition, end-of-life recycling and reuse are an important step towards a circular economy. Our iconic transformers are just one of the ways we contribute to the energy transition, in which electricity will be the backbone of the world's energy systems. Let us be your partner in the sustainability journey.
In a world where energy drives
progress and shapes the future, Indotech Transformers stands out for its unwavering commitment to powering your world with reliable, sustainable transformers, leading the way in the global energy transition. Our manufacturing plant proudly features cutting-edge infrastructure and state-of-the-art equipment, a testament to decades of excellence. Our Winding Bay facility operates under dust-free conditions, ensuring the highest quality of production. In our NABL accredited lab, every transformer undergoes rigorous quality checks, ensuring reliability and safety you can trust. Our transformers extend their powers across nations worldwide. Our product range encompasses a spectrum of possibilities, powering your possibilities with reliable transformers. Distribution transformers, tailor-made for residential, commercial and industrial applications, come in various capacities. Large power transformers manufactured under sterile conditions offer capacities from 5 MVA or 11 kV up to 315 MVA or 400 kV, including substation, generator step-up or down and more. Inverter duty transformers for a wide range of solar applications. Skid-mounted substations, a game changer in wind energy, offer convenience and efficiency. At Indotech Transformers, we prioritize sustainability. Our commitment to values runs deep. We prioritize eco-friendly practices to reduce our environmental impact. Rooted in the principles of social and governance, we invest in our people, skills and careers, propelling our company toward greater growth and innovation. Because at Indotech Transformers, we nurture connections that power progress and light up a brighter, more electrifying future. Indotech Transformers, your partner for a sustainable energy future.
A simple flick of the switch transforms night into day. Helps make dreams come true. Spreads smiles, offers comfort, promises a better tomorrow. Transformation is the key to advancement. We are Technical Associates Limited, and we transform electricity into happiness. Established in 1969, what started as a humble endeavor is now regarded as a pioneer in transformer technology. Since its inception, Technical Associates has supplied more than 150,000 MVA equivalent transformers, both to domestic and overseas markets. And it is our consistent performance which makes leading customers trust us for their power transformation requirements. These transformers are manufactured at our state-of-the-art manufacturing unit located at Sitarganj in Uttarakhand, India. Continuous innovation and upgradation with single-minded focus towards customer satisfaction have defined our journey of over 50 years. As a result, we are one of the few Indian manufacturers with the capability to manufacture 500 MVA, 400 kV class transformers. Our engineering capabilities and stringent quality systems help deliver superior quality products to our customers on time and in line with global standards. We use internationally acclaimed and best-in-class transformer design software that helps validate our designs for withstanding the most stringent of operating conditions. This has also resulted in one of the best performances in short circuit testing, with many of our transformers up to 220 kV having successfully cleared short circuit testing in the first go. We also offer services of repair, upgradation, servicing and remanufacturing of EHV transformers upon request, helping preserve critical assets, hence their productive lifespan. Furthermore, our widespread sales network is backed by a strong service and support team to ensure that a technical associate service engineer is never too far from a customer when required. Constant focus on learning, training, skill upgradation and innovations has helped us transform the lives of our customers, stakeholders and partners for the better. And since we are in the business of transformation, our goal is to transform the future via our three-pronged strategy focusing on best-in-class energy efficiency, reduced global carbon footprint, a sustainable and inclusive future. The time to transform is now. Join hands with Technical Associates Limited. Let's transform for the better together.
What is omnipresent, just like air? What is the force that surrounds us? What is it that gives wings to dreams and ambitions? It's energy. Energy that illuminates lives. Energy that builds a nation. Energy that brings cheer. Energy that unifies and unites. It's in every form and it's everywhere. What is this energy that connects and binds us? It's REC. It's the core of an ecosystem that's all about energy. Energy for the now and energy for tomorrow. It's about industry and growth, integration and diversification. It's about opportunity and productivity. connectivity, and community. For the here and for the future, REC unleashes the potential of energy. REC funds energy. Funding that catalyzes, funding that inspires, funding that transforms. It brings us together with each other and our partners. For sustainability and reliability, for investment and development, adding value every day in every way. This is what our energy is. This is REC. It carries with it the dreams, the aspirations, and the hopes of a billion, with the promise of endless energy and infinite possibilities.
Established in 1937, CG Power and Industrial Solutions Limited is an engineering conglomerate with an impeccable and diverse portfolio. Our products, solutions and services support our economy's power, railways and industrial sectors. Industrial Division. This is the largest business of CG and is primarily India-focused. 1 out of every 3 motors in India is a CG LV motor with international certifications. CG is the largest manufacturer of low-voltage motors in India. We are the first to develop a complete range of IE2, IE3 and IE4 motors in India. Our single-phase motors unit caters to agricultural, domestic and industrial applications. Our HD motors are designed to meet diversified application demands. Our stampings division is fully equipped with the latest high-speed blanking lines, H-frame high-tonnage presses and CNC precision notching machines. Drives and Automation has over 40 years of experience developing, manufacturing and delivering state-of-the-art motor control equipment with cutting-edge technology. CG re-entered the FMEG segment in 2019 with a wide range of consumer electrical products like domestic and agricultural pumps, industrial and domestic fans and water heaters launched over the last few years. Power Division. CG is a leading Indian manufacturer of developing and supplying power and distribution transformers. We supply locomotive and trackside transformers of various ranges to the Indian Railways. CG manufactures switchgear products like condenser bushings and current transformers suitable for high altitude and seismic zones. Our various switchgear products conform to IEC, IEEE, ANSI and GOST standards. At the switchgear unit, we manufacture the finest gas circuit breakers and surge arresters, polymeric and molded to suit multiple industrial applications. We have indigenously developed gas-insulated switchgears from 11 kV to 245 kV class. We also offer customized power quality and automation solutions with crucial equipment. Railways Division. CG is a leading manufacturer of traction motors, alternators, control equipment, propulsion systems for electric locomotives, multiple units, diesel-electric tower cars and railway signaling equipment. Our TMS unit offers traction motors and alternator control panels for diesel-electric tower cars, loco and multiple units. Our RTTE unit offers propulsion systems, traction converters, auxiliary converters, vehicle control units, control panels and driver's desks. Our RSD unit manufactures a signaling product range with innovative expertise. Management transition. In November 2020, Tube Investments acquired a controlling stake. Working ahead, our plans include doubling the motor capacity to cater to the domestic demand, export EV, expansion of our transformer manufacturing capacity to meet the rising domestic and global demand, and to have technology tie-ups to participate in several projects announced by the Indian Railways. At CG, we are constantly working on empowering people to do great things every day. Let's energize the world together.
Transformers are static electrical machines, but need proper maintenance and operation, which is often ignored, leading to their failure. Transformer maintenance is a periodical and expensive affair, currently involving a lot of human intervention, resulting in data which may not be fully accurate or reliable. Therefore, it is difficult to monitor transformers with a reasonable sense of accuracy. However, what if your transformer could self-diagnose itself and inform you or alert you accurately about its health? In short, what if your transformer became an intelligent transformer and could speak for itself? In addition, you could extract enhanced power from your transformer at maximum efficiency and utilization with cost savings. Introducing BOLA, that is, Better Operation and Life Cycle by Analytics, for distribution transformers taking a leap to the next level of innovative digital and enhanced technology solution from CRIFS, an investee company of Toyota Motors Group Company. This would result in your maintenance staff managing your transformers from schedule-based maintenance, which is expensive, to condition-based maintenance. You can observe your asset location, critical and vital operating parameters in real time, spread across geography, and compare this operational data for productivity, cost, and plant efficiency parameters. BOLA can be fitted on new transformers or can easily be retrofitted on existing transformer at plant location. Installation of the sensor and hardware can be done with minimum plant interruption. CRIFS Technologies aspires to help utilities and industry to reduce failures in distribution transformers, thereby saving OPEX and CAPEX costs and making the distribution system more efficient and reliable.
Power Oil from APAR is the leading brand of specialty mineral oils. With 2 large lube blending plants, APAR offers cutting-edge technology solutions in transformer oils, industrial oils, liquid paraffins and white oils, and lubricants. Automatic filling and sealing of drums with centralized SCADA control. Driven by continuous R&D, APAR has developed a diverse product portfolio of more than 400 grades of specialty oils. APAR introduced several special grade oils for demanding applications, including transformer oil for 800 kV extra high voltage DC systems. Powering the performance of new generation vehicles in the South Asian market, APAR offers the world-renowned ENI brand of engine oils and greases through an alliance with ENI SPA of Italy.
Danish takes pride in being recognized as one of the leading quality-conscious power equipment manufacturers and exporters from India. At Danish, we believe in building a legacy by looking to the future. Established in the year 1985, we are manufacturing and exporting products ranging from power and distribution transformers to control and relay panels with substation automation systems. With a state-of-art infrastructure coupled with a testing facility accredited by NABL, we produce and test as per the highest international standards. With a detailed integrated management system including ISO 9001 for quality, ISO 14001 for environment and ISO 45001 for health and safety. We cover all aspects to make a quality and sustainable product. Our people are our strength. With an in-house design team, continuous design and development work leads to most robust designs. At Danish, exports continue to be a major focus area for Danish, and thus we are exporting to over 30 plus international markets currently. We are also manufacturing various types of special application transformers.
For eons the planet has provided, and we have taken. It worked beautifully until scientists realized that increasing contamination of ecosystems is disturbing the natural balance, and the rate at which we extract resources is not sustainable. The human race is ingenious, and when determined to find solutions, we usually do. At Hitachi Energy, we take sustainability seriously, and that responsibility is at the heart of our iconic transformers. Developing sustainability solutions, co-created with our customers, is the key to our iconic transformers to achieve decarbonisation, enhancing safety for people, protecting surrounding ecosystems, and responsible use of resources. A quantifiable, evidence-based approach built on our deep domain expertise in transformers offers transparency on environmental impact using scientific methodologies such as life cycle analysis studies, followed by best-in-class solutions to improve sustainability performance. Even small electrical losses in transformers add up over the lifetime, resulting in significant carbon emissions and wasted power that could be saved by transformers with enhanced energy efficiency. Transformers contain large volumes of material which, through intelligent design and use of material, can be made more sustainable. Eliminating mineral oil leakages for protecting surrounding ecosystems and enhancing safety is vital. In addition, end-of-life recycling and reuse are an important step towards a circular economy. Our iconic transformers are just one of the ways we contribute to the energy transition in which electricity will be the backbone of the world's energy systems. Let us be your partner in the sustainability journey.
In a world where energy drives progress and shapes the future, Indotech Transformers stands out for its unwavering commitment to powering your world with reliable, sustainable transformers, leading the way in the global energy transition. Our manufacturing plant proudly features cutting-edge infrastructure and state-of-the-art equipment, a testament to decades of excellence. Our Winding Bay facility operates under dust-free conditions, ensuring the highest quality of production. In our NABL accredited lab, every transformer undergoes rigorous quality checks, ensuring reliability and safety you can trust. Our transformers extend their powers across nations worldwide. Our product range encompasses a spectrum of possibilities, powering your possibilities with reliable transformers. Distribution transformers, tailor-made for residential, commercial, and industrial applications, come in various capacities. Large power transformers manufactured under sterile conditions offer capacities from 5 MVA or 11 kV up to 315 MVA or 400 kV, including substation, generator step-up or down, and more. Inverter duty transformers for a wide range of solar applications. Skid-mounted substations, a game changer in wind energy, offer convenience and efficiency. At Indotech Transformers, we prioritize sustainability. Our commitment to values runs deep. We prioritize eco-friendly practices to reduce our environmental impact. Rooted in the principles of social and governance, we invest in our people, skills, and careers, propelling our company toward greater growth and innovation. Because at Indotech Transformers, we nurture connections that power progress and light up a brighter, more electrifying future. Indotech Trafotech Transformers, your partner for a sustainable energy future. A simple flick of the switch transforms night into day, helps make dreams come true, spreads smiles, offers comfort, promises a better tomorrow. Transformation is the key to advancement. We are Technical Associates Limited, and we transform electricity into happiness. Established in 1969, what started as a humble endeavor is now regarded as a pioneer in transformer technology. Since its inception, Technical Associates has supplied more than 150,000 MVA equivalent transformers, both to domestic and overseas markets. And it is our consistent performance which makes leading customers trust us for their power transformation requirements. These transformers are manufactured at our state-of-the-art manufacturing unit located at Sitarganj in Uttarakhand, India. Continuous innovation and upgradation with single-minded focus towards customer satisfaction have defined our journey of over 50 years. As a result, we are one of the few Indian manufacturers with the capability to manufacture 500 MVA, 400 kV class transformers. Our engineering capabilities and stringent quality systems help deliver superior quality products to our customers on time and in line with global standards. We use internationally acclaimed and best-in-class transformer design software that helps validate our designs for withstanding the most stringent of operating conditions. This has also resulted in one of the best performances in short-circuit testing, with many of our transformers up to 220 kV having successfully cleared short-circuit testing in the first go. We also offer services of repair, upgradation, servicing, and remanufacturing of EHV transformers upon request, helping preserve critical assets, enhance their productive lifespan. Furthermore, our widespread sales network is backed by a strong service and support team to ensure that a technical associate service engineer is never too far from a customer when required. Constant focus on learning, training, skill upgradation, and innovations has helped us transform the lives of our customers, stakeholders, and partners for the better. And since we're in the business of transformation, our goal is to transform the future via our three-pronged strategy focusing on best-in-class energy efficiency, reduced global carbon footprint, a sustainable and inclusive future. The time to transform is now. Join hands with Technical Associates Limited. Let's transform for the better together.
What is omnipresent, just like air? What is the force that surrounds us? What is it that gives wings to dreams and ambitions? It's energy. Energy that illuminates lives. Energy that builds a nation. Energy that brings cheer. Energy that unifies and unites. It's in every form and it's everywhere. What is this energy that connects and binds us? It's REC. It's the core of an ecosystem that's all about energy. Energy for the now and energy for tomorrow. It's about industry and growth, integration and diversification. It's about opportunity and productivity, connectivity and community. For the here and for the future, REC unleashes the potential of energy. REC funds energy. Funding that catalyzes, funding that inspires, funding that transforms. It brings us together with each other and our partners. For sustainability and reliability, for investment and development, adding value every day in every way. This is what our energy is. This is REC. It carries with it the dreams, the aspirations, and the hopes of a billion, with the promise of endless energy and infinite possibilities.
Established in 1937, CG Power and Industrial Solutions Limited is an engineering conglomerate with an impeccable and diverse portfolio. Our products, solutions and services support our economy's power, railways and industrial sectors. Industrial Division. This is the largest business of CG and is primarily India-focused. 1 out of every 3 motors in India is a CG LV motor with international certifications. CG is the largest manufacturer of low-voltage motors in India. We are the first to develop a complete range of IE2, IE3 and IE4 motors in India. Our single-phase motors unit caters to agricultural, domestic and industrial applications. Our HD motors are designed to meet diversified application demands. Our stampings division is fully equipped with the latest high-speed blanking lines, H-frame high-tonnage presses and CNC precision notching machines. Drives and Automation has over 40 years of experience developing, manufacturing and delivering state-of-the-art motor control equipment with cutting-edge technology. CG re-entered the FMEG segment in 2019 with a wide range of consumer electrical products like domestic and agricultural pumps, industrial and domestic fans and water heaters launched over the last few years. Power Division. CG is a leading Indian manufacturer of developing and supplying power and distribution transformers, locomotive and side transformers of various ranges to the Indian Railways. CG manufactures switchgear products like condenser bushings and current transformers suitable for high altitude and seismic zones. Our various switchgear products conform to IEC, IEEE, ANSI and GOST standards. At the switchgear unit, we manufacture the finest gas circuit breakers and surge arresters, polymeric and
check 1 2 check 1 mic check.
We have indigenously developed gas insulated switchgears from 11 kV to 245 kV class. We also offer customized power quality and automation solutions with crucial equipment. Railways Division. CG is a leading manufacturer of traction motors, alternators, control equipment, propulsion systems for electric locomotives, multiple units, diesel-electric tower cars and railway signaling equipment. Our TMS unit offers traction motors and alternator control panels for diesel-electric tower cars, loco and multiple units. Our RTTE unit offers propulsion systems, traction converters, auxiliary converters, vehicle control units, control panels and driver's desks. Our RSD unit manufactures a signaling product range with innovative expertise. Management transition. In November 2020, Tube Investments acquired a controlling stake. Working ahead, our plans include doubling the motor capacity to cater to the domestic demand, export EV, expansion of our transformer manufacturing capacity to meet the rising domestic and global demand, and to have technology tie-ups to participate in several projects announced by the Indian Railways. At CG, we are constantly working on empowering people to do great things every day. Let's energize the world together.
Transformers are static electrical machines, but need proper maintenance and operation, which is often ignored, leading to their failure. Transformer maintenance is a periodical and expensive affair, currently involving a lot of human intervention, resulting in data which may not be fully accurate or reliable. Therefore, it is difficult to monitor transformers with a reasonable sense of accuracy. However, what if your transformer could self-diagnose itself and inform you or alert you accurately about its health? In short, what if your transformer became an intelligent transformer and could speak for itself? In addition, you could extract enhanced power from your transformer at maximum efficiency and utilization with cost savings. Introducing BOLA, that is, Better Operation and Life Cycle by Analytics, for distribution transformers taking a leap to the next level of innovative digital and enhanced technology solution from CRIFS, an investee company of Toyota Motors Group Company. This would result in your maintenance staff managing your transformers from schedule-based maintenance, which is expensive, to condition-based maintenance. You can observe your asset location, critical and vital operating parameters in real time, spread across geography, and compare this operational data for
Power Oil from APAR is the leading brand of specialty mineral oils. With 2 large lube blending plants, APAR offers cutting-edge technology solutions in transformer oils, industrial oils, liquid paraffins and white oils, and lubricants. Automatic filling and sealing of drums with centralized SCADA control. Driven by continuous R&D, APAR has developed a diverse product portfolio of more than 400 grades of specialty oils. APAR introduced several special grade oils for demanding applications, including transformer oil for 800 kV extra high voltage DC systems. Powering the performance of new generation vehicles in the South Asian market, APAR offers the world-renowned ENI brand of engine oils and greases through an alliance with ENI SPA of Italy.
Danish takes pride in being recognized as one of the leading quality-conscious power equipment manufacturers and exporters from India. At Danish, we believe in building a legacy by looking to the future. Established in the year 1985, we are manufacturing and exporting products ranging from power and distribution transformers to control and relay panels with substation automation systems. With a state-of-art infrastructure coupled with a testing facility accredited by NABL, we produce and test as per the highest international standards. With a detailed integrated management system including ISO 9001 for quality, ISO 14001 for environment and ISO 45001 for health and safety. We cover all aspects to make a quality and sustainable product. Our people are our strength. With an in-house design team, continuous design and development work leads to most robust designs. At Danish, exports continue to be a major focus area for Danish, and thus we are exporting to over 30 plus international markets currently. We are also manufacturing various types of special application transformers.
For eons the planet has provided, and we have taken. It worked beautifully until scientists realized that increasing contamination of ecosystems is disturbing the natural balance, and the rate at which we extract resources is not sustainable. The human race is ingenious, and when determined to find solutions, we usually do. At Hitachi Energy, we take sustainability seriously, and that responsibility is at the heart of our iconic transformers. Developing sustainability solutions, co-created with our customers, is the key to our iconic transformers to achieve decarbonisation, enhancing safety for people, protecting surrounding ecosystems, and responsible use of resources. A quantifiable, evidence-based approach built on our deep domain expertise in transformers offers transparency on environmental impact using scientific methodologies such as life cycle analysis studies, followed by best-in-class solutions to improve sustainability performance. Even small electrical losses in transformers add up over the lifetime, resulting in significant carbon emissions and wasted power that could be saved by transformers with enhanced energy efficiency. Transformers contain large volumes of material which, through intelligent design and use of material, can be made more sustainable. Eliminating mineral oil leakages for protecting surrounding ecosystems and enhancing safety is vital. In addition, end-of-life recycling and reuse are an important step towards a circular economy. Our iconic transformers are just one of the ways we contribute to the energy transition in which electricity will be the backbone of the world's energy systems. Let us be your partner in the sustainability journey.
In a world where energy drives progress and shapes the future, Indotech Transformers stands out for its unwavering commitment to powering your world with reliable, sustainable transformers, leading the way in the global energy transition. Our manufacturing plant proudly features cutting-edge infrastructure and state-of-the-art equipment, a testament to decades of excellence. Our Winding Bay facility operates under dust-free conditions, ensuring the highest quality of production. In our NABL-accredited lab, every transformer undergoes rigorous quality checks, ensuring reliability and safety you can trust. Our transformers extend their powers across nations worldwide. Our product range encompasses a spectrum of possibilities, powering your possibilities with reliable transformers. Distribution transformers, tailor-made for residential, commercial, and industrial applications, come in various capacities. Large power transformers, manufactured under sterile conditions, offer capacities from 5 MVA or 11 kV up to 315 MVA or 400 kV, including substation, generator step-up or down, and more. Inverter duty transformers for a wide range of solar applications. Skid-mounted substations, a game changer in wind energy, offer convenience and efficiency. At Indotech Transformers, we prioritize sustainability. Our commitment to values runs deep. We prioritize eco-friendly practices to reduce our environmental impact. Rooted in the principles of social and governance, we invest in our people, skills, and careers, propelling our company toward greater growth and innovation. Because at Indotech Transformers, we nurture connections that power progress and light up a brighter, more electrifying future. Indotech Transformers, your partner for a sustainable energy future. A simple flick of the switch transforms night into day, helps make dreams come true, spreads smiles, offers comfort, promises a better tomorrow. Transformation is the key to advancement. We are Technical Associates Limited, and we transform electricity into happiness. Established in 1969, what started as a humble endeavor is now regarded as a pioneer in transformer technology. Since its inception, Technical Associates has supplied more than 150,000 MVA equivalent transformers, both to domestic and overseas markets. And it is our consistent performance which makes leading customers trust us for their power transformation requirements. These transformers are manufactured at our state-of-the-art manufacturing unit located at Sitarganj in Uttarakhand, India. Continuous innovation and upgradation with single-minded focus towards customer satisfaction have defined our journey of over 50 years. As a result, we are one of the few Indian manufacturers with the capability to manufacture 500 MVA, 400 kV class transformers. Our engineering capabilities and stringent quality systems help deliver superior quality products to our customers on time and in line with global standards. We use internationally acclaimed and best-in-class transformer design software that helps validate our designs for withstanding the most stringent of operating conditions. This has also resulted in one of the best performances in short-circuit testing, with many of our transformers up to 220 kV having successfully cleared short-circuit testing in the first go. We also offer services of repair, upgradation, servicing, and remanufacturing of EHV transformers upon request, helping preserve critical assets, hence their productive lifespan. Furthermore, our widespread sales network is backed by a strong service and support team to ensure that a technical associate service engineer is never too far from the customer when required.
Good afternoon, ladies and gentlemen.
Constant focus on learning, training.
Are we ready for the next session? I hope all of you have also filled the feedback form, because we are going to have a lucky draw in the end today before the dinner. Okay, so please, everybody who has not filled the feedback form, please fill it and give it to one of our colleagues from EMA, and then we will conduct it after the 5th session, before the dinner break. Okay? So we are going to start the next session. Hand it over to Pragati, please, Pragati.
Thank you, Imtiaz ji. So post-lunch, after having a nice lunch, now we are moving to a very interesting topic, session 5 on emerging trends in transformer, input materials and accessories. So very, very important subject again. As I said yesterday, transformer is the heart of power system, but the material is the heart of transformer. With great pleasure, I would like to invite our session chairman, Mr. Kuleshwar Sahu, the authors, Dr. Sunil Tonde, Dr. T.C.S.M. Gupta, Ms. Manjusha Nambiar, Mr. Anuj Sharma, Mr. Baburav K., Ms. Khushbu Thakur, and Mr. Pranav Shankar. Allow me to please quickly introduce our session chairman and authors. Our session chairman, Shri Kuleshwar Sahu, is Chief GM CCAM Power Grid. He has done his BTech from NIT Raipur in Electrical Engineering and worked as a faculty in Technical Institute as Assistant Professor. Also worked as executive in Solar Division of Rajasthan Electronics and Instrumentation Limited, Jaipur. He joined Power Grid in 1995, and some of the key activities performed by him are basically he has got 8-year experience in O&M and erection, testing and commissioning of various EHV substation and transmission lines, monitoring of regional transmission, asset and grid management, establishment of oil testing facilities at Raipur substation for facilitating the oil testing facilities within Power Grid and outside transmission service provider. He is responsible for implementation of reliable center maintenance in Power Grid, as well as the providing training on safe practices on transmission system under Central Electricity Authority. Presently, he is leading digital team at Corporate Office of Power Grid. Now I come to our authors. Dr. Sunil Tonde, he has done his PhD in chemistry. He is Vice President of Savita Oil Technologies Limited. His field of expertise is transformer oils, specialty and fine chemicals, organic synthesis and catalysis. Dr. TCSM Gupta, he has done his PhD and he is a Senior Vice President with Apar Industries Limited. His field of expertise is refining, dielectric fluids, lubricants, specialty oils and additives. Ms. Manjusha Nambiar, she has done her MSc in Applied Chemistry and currently pursuing PhD in Applied Chemistry at Faculty of Technology and Engineering at Maharaja Sayajirao University, Vadodara. She is working as Assistant Manager with ERDA. Her field of expertise is condition monitoring of transformers through dissolved gas analysis of oil, analysis of mineral oil and ester oil used in transformers. Mr. Anuj Sharma, he has done his BE Electrical and ME Industrial Electronics from Maharaja Sayajirao University of Baroda in 2001. He has done his MBA in Technology Management from IIT Delhi. He is General Manager, Proterial India Private Limited, which is formerly Hitachi Metals. His field of expertise is soft magnetic materials for transformers, inductors, sensors, power electronics, electrical engineering management. Mr. Baburao K. has done his MSc Chemistry and MTech from IIT Bombay. He is Deputy GM R&D with Raj Petro Specialties Private Limited. He has got 37 years of industrial experience in insulating materials, liquid and solid insulations for transformers and switchgears. Ms. Khushbu Thakur, she has done her MTech and currently working as Regional Application Specialist with Omicron Electronics Asia. Her field of expertise is power transformer partial discharge. Mr. Pranav Shankar, he has done his BE Electrical and currently working as General Manager with CTR Manufacturing Industries Private Limited. His field of expertise is switchgears and Six Sigma. I would hand over session to Session Chairman. Thank you.
Thank you, Madam. Good afternoon to all of you. After lunch, it is difficult, but hope our presenter will make it a very good session. Ladies and gentlemen, esteemed colleagues and distinguished guests, it is with great pleasure and honor that I am here before you as the chairman of this technical session on emerging trend in transformer input material and accessories. This session promised to be dynamic exploration of a cutting-edge advancement in the era of the transformers, a critical component in power infrastructure. The industry has witnessed a paradigm shift in the monitoring and diagnosis through the incorporation of the smart materials. Transformer embedded with a sensor made from these materials enable real-time monitoring of a critical parameters such as temperature and moisture level. The shift toward predictive maintenance not only enhances the lifespan of the transformer but also minimizes downtime. A crucial factor in ensuring the reliability of power infrastructure. A nanofluid, a novel approach to cooling, involves suspension of the nanoparticles in a conventional transformer oil. The addition of nanoparticle improves the heat transfer property, thereby enhancing the cooling efficiency of the transfer component. Solid insulation material have become a focal point of exploration, offering an alternative to traditional liquid and gas insulations. Composite material and polymers are being investigated for their potential to improve environmental performance and reduce the fire risk. In pursuit of the sustainability, biodegradable insulating material have garnered attention. This material aim to mitigate the environmental impact at the end of the transformer life cycle, aligning with the broader initiative to create a more sustainable energy infrastructure. The industry's commitment to sustainability is a further exemplify the ongoing research into environmentally friendly materials and manufacturing process, underlying a collective drive to reduce the ecological footprint of the transformer technology. So our today agenda is diverse and forward-looking, encompassing a range of topics from the aging of the thermal upgraded kraft paper to the exciting development in the nanocrystal advanced core material for medium frequency transformers. As we know, this subject is crucial to recognize the vital role transformers play in the distribution and transmission of the electrical power. They are the silent workhorse enabling the seamless flow of energy across our grid. However, as the technology advances, so much our understanding of the material and accessory, this make a transformer efficient, sustainable and reliable. In this series, I request our first presenter from the Savita, I think just for aging of the thermally upgraded crop paper with ester-filled, I request Dr. Sunil to have a present. And just I request please adhere with the time. Time is 10 minutes, I think.
Yeah. So thank you very much. So we in this session we will mostly go through the chemistry of the oil and the paper, which is a very crucial part of the transformer. So as I said, chemistry is very important. We would see we can very well equate the life of the transformer with the life of the paper as a broad perspective. So the life of the paper in turn is important, is actually monitored by the polymer present in that, which is cellulose, and this kinetics of the degradation of the cellulose is broadly affected by the oil present in that. So therefore, selection of the oil, appropriate oil in the transformer is very important and critical part. So in this study what we have done was synthetic ester and the mineral oil, they were compared for the stability of the paper inside paper, and this was actually the accelerated stability which actually has very harsh condition as per the IEEE 57 guidelines. And in this particularly what we have done was in this particular study what we have done was DP value of the paper and the acid value of the oil were measured. If you can see the data over here, some of the data what I have presented here which clearly show the mineral oil which is transol taken over here, this degrades very fast. So DP value of the paper it decreases very fast, whereas in case of the transol synth 100 which is a synthetic ester, which rate of degradation is comparatively low. But on the contrary what we can see here is synthetic ester acid value is increasing, however the paper is protected, and we will see slowly why this happens. Before that, there are some more insights in this paper. Actually, the degradation of the paper, it has in the experimental scale it has two phases. In the first phase, it degrades very fast, whereas in the latter phase, the degradation rate was comparatively low. Even in that, in the blue line, what you could see here, degradation continues with some rate, whereas it flattens in case of the ester oil. In both of the cases, what we can very well see that the mineral oil decomposes much faster, as in the first case 40% was degraded in the first degradation phase, whereas synthetic ester was only degraded 27%. Latter case was also, almost double degradation was noted in case of mineral oil. So, in short, the ester protects the paper, and why this happens, that we can go slowly to the actual chemistry behind that. So, to prove some concept, what we have done here is, as we have seen that oil builds the acidity, but protects the paper. Why this happens? So, in this case, we can very well see the trend of degradation in the mineral oil is much sharper if we consider the acid value versus the DP value correlation, and it steadily decreases, whereas in synthetic ester it has it has achieved some steady state, and the steady state remains with a very wide range of acidity present in the ester oil. So, it is from 0.9 to 2.7 milligram KOH per gram of the oil. So, in such a wide range of this, why this happens? So, if we see the chemistry of that, then this severe degradation of the paper in the mineral oil, this is because mineral oil is very non-polar in nature, whereas this synthetic ester is comparatively polar. And as this non-polar oil, it is not capable of taking the polarity generated during the study or maybe during the transformer operations. It cannot be held up in the oil, but as the cellulose in the paper, it has some polarity, it tends to absorb the moisture generated in the in this due course, as well as the acidity generated in this due course. So, and there are a lot of literature, and in the previous sections as well, we could have seen that acidity and moisture are the major culprits for the degradation of the paper. So, as the paper holds the moisture and the acidity because of its nature, mineral oil leaves the moisture and acidity to the paper, it experiences the accelerated degradation. Whereas in the synthetic ester, it has a polar nature and it acts as a sump for the acidity, and for that matter as well water. So, it reduces the interaction of the paper with the moisture and acidity by acting it as a sump, acting itself as a sump, and thus it protects the paper. So, another aspect what we have seen was how the natural ester, this up till this it was for the synthetic ester, now natural ester, we have studied the biotransol and comparison to that which was the mineral oil transol. In this case, what we can see is this study was also done at accelerated stability, at accelerated condition. In the retrofill condition as well, we can see the mineral oil degrades much faster, whereas the biotransol degradation rate was comparatively lower, and the retrofilling conditions did not have much effect when we studied. So, if we see the comparative rate, here also we experience the degradation happens in the two phases. First phase is comparatively faster and the another one is comparatively slower phase. If we see the rate of degradation, which is almost double in case of synthetic ester, whereas mineral oil in case with comparison to the natural ester. And in the red and green plot, what we could see, it shows that the retrofill conditions simulated in the lab, it has almost no effect. And there are some literature previously, natural ester or any, for that matter, any ester component has a capability to absorb the ester water and acidity to the media. So with this, we conclude that the non-polar media, non-polar nature of the mineral oil, it does not hold the polarity generated in the system because of any reason for that matter, and it gives to the paper, and that way it degrades the paper. Whereas the ester components, that for that matter natural ester as well as the synthetic ester, they hold the moisture and protect the paper. So for the acidity, there is a very wide range where we can operate the esters.
Dr. Sulit, please write up.
Yeah, so in general what we could see is synthetic esters as well as the natural esters, they were very much superior to the mineral oil to protect the paper. Of course, there are a lot of other effects happening in the transformer, but if we consider the oil as a major part of the transformer, it has a major role to play. So this is how we could conclude that these ester components are better than the mineral oil in the transformers. So with this, we thank the audience as well as the EMA for allowing us to present this work to you.
Thank you, Dr. Sen. Now, second paper is presentation enhancing the sustainability, reliability, new generation natural ester based transformer oil. I request Dr. TCS Gupta sir, please.
Yeah, thank you, Chairman. Good afternoon, members of Transformer Community of India. The theme of the conference is Transformers for Sustainable Future, and thanks to the last few sessions where experts have shared their experiences about esters at various capacity levels, whether it is GETCO, power grid, and T&R, and then experiences in the distribution transformers, and also my friend Dr. Tonde for setting the tone for the subject of alternate dielectric fluids. The time has come for looking for alternate dielectric fluids. Not only in India, globally, most of the power and energy sector are looking for sustainable means of generating energy and power. Generating power through renewable and reliable sources is becoming order of the day. We have seen the last few years, most of the global energy companies have been investing heavily into alternate resources other than petroleum, because everybody understands carbon footprint is no longer an individual's priority or obligation. It is collective responsibility of the country, not only company, because we need to really get to the levels that as a country we are promising to meet. Everybody has to do their bit of sustainable efforts. Today we are going to talk about how you further enhance the sustainability and reliability of the product, because not only power generation, the equipment, today somebody was asking, can you enhance from 5 years to 15 years? People are talking about supplying reliable power to the end customer. It's the whole paradigm shift is there. So we are talking about a new generation of natural esters. This is a development that we have done during COVID. While COVID had its own experiences on the personal and social level, we took the opportunity of developing a product where we can overcome and we can improve certain aspects of natural esters. When you talk about sustainable development goals, sustainability is not an isolated item. You need to look into an overall aspect of ESG, And UN has come up with the 17 sustainable development goals, all of us know very well. And our sector especially focuses on responsible consumption and production of energy or raw materials. Whenever you talk about a sustainable product, it should compete with the existing product. The machine availability, that means downtime should be less. There should be an improved operational safety when you talk about renewable resources. Of course, carbon footprint. When you talk about normal sustainability, you are minimizing the waste. When you are talking about renewable resources, you are talking about carbon footprint order of change into at least 2 to 3 times, in some cases much more than that. And as much as possible, environmentally we should be responsible. It should be biodegradable, not harmful. And of course, being a dielectric fluid user or manufacturer, the product should be stable, consistent in its dielectric performance as well as other chemical and physicochemical properties. We have seen since 2008, a lot of issues have been there in dielectric fluids in terms of copper corrosion. I'm talking about mineral oils in general. Similarly, designs are changing, things are becoming very compact. So when on dielectric fluid, a lot of requirements are changing. People are talking about fire safety as frequently as possible. It should be non-toxic, and it should have very good oxygen stability. There should not be any compromise compared to the the existing brothers of like mineral oils. And of course, when you're talking about insulating fluid, it should provide uninterrupted insulating service, and electric property should be stable. And today we are shifting from major power generation from coal to anywhere, everywhere power is being generated. So it should be safe wherever you are using this product or a transformer which contains insulating fluid, and floating solars, and it's becoming very common. We have seen that natural esters have been one of the proven alternatives. They have been used last 30, 40 years. They have a reasonably shown good stable electrical properties. They are biodegradable, reasonably aquatic stable. There is no harm to aquatic fauna. Fire safety, yes, they are K-class fluids. They improve the fire safety wherever you use, whether it in a, and of course, they improve the insulation life, as our friend mentioned. They keep the solid insulation dry, and there have been studies. In fact, I will also share some studies. It improves the thermal life of insulating material. Low carbon footprint compared to mineral oils. There are various studies, but if you see the LCAs, they are as much as 10-20% compared to mineral oils. But there are also, because of not availability of technology or products or raw material, there have been certain limitations, and the standards also have been set based on the existing technology or products, where, for example, if you see the oxygen stability has been set at 48 hours compared to mineral oils, which is 164 hours. And the behavior of these vegetable esters, even we have seen in our house also, if you keep on frying something over a period of time, it becomes sticky, gummy, grease-like. So oxidative stability, and because of thermal and oxidative issues, it becomes very gummy, sticky, very thick. You can't use. Heat transfer is a casualty. And compared to existing products, limited life. Of course, there is always an opportunity whenever you want to look at improving. As we have been talking, you should innovate and improve the products. Can you improve the product oxygen stability? Yes. Can it be compared to mineral oil or synthetic ester? And improve thermal stability, suitable for all types of transformers. We have been talking hermetically sealed is the only where you can use this product, but can you really use it in breathing type transformer? Maybe it is possible. And of course, improved reliability, because once you know there is no oxidation stability issue and thermal stability is good, there is no viscosity buildup, and it may be used as a general alternative which like, for example, mineral oils become now. People talk about biodegradability, this is a very misconception in the market. People talk about various types of biodegradability, but ultimate biodegradability is the only measure. So 301B, whether it is passing or not, and when you are using this product in various applications, whether it is aquatic, toxicity is low, it should not be harmful to the fish, what you call acute immobilization or acute toxicity is the key. Otherwise, you cannot use in floating transformers, floating solar farms. We have come up with a product, just because of that technical conference we have changed. This product is called Power Oil NE Premium, but technically it is called high oleic natural ester type of product, which has extremely high oxygen stability, as much as similar to mineral oils. Conventional natural esters are 48 hours, this is 164 hours, no viscosity buildup or very low viscosity buildup. And then even when you see RBOT, it meets like inhibited mineral oils. Conventionally, it is 34 minutes. For say normal ester, this is 240 minutes. And spray gassing, lot of data has been reported in the literature. Natural esters have very high generation of hydrocarbons, which for which there is no explanation. Though there is no standard for spray gassing, but these products show extremely low hydrocarbon generation, ethane. There is no comparison of any order. If for special application there is 50 ppm is the limit, this product is much lower, 15 ppm, both under IEC as well as ASTM condition. This is one of the added advantages. There is no surprise. Because what happens is, if you have seen in this result at IEC, which you do at 105 degrees, 48 hours, the generation levels are low. When you extend it as per ASTM, the generation levels are so high. But whether you owe it to a fault into the transformer or it is the nature of the product, this mineral oil we are using that are being used in distribution transformers. Lowest carbon footprint compared to any natural ester, because the life of this oil on a bench test is 3 to 4 times more than the conventional esters. No spray gassing, no worry, no viscosity buildup. And are there any limitations in terms of breathing or non-breathing? No, it can be used in all situations. This becomes a universal product where it takes away a lot of existing problems that you see in the market now. So it is always possible. Every 5 years there is a new wave comes in technology that we have seen in whether it is deep learning, machine learning, artificial intelligence. What's happening, the way people are monitoring, assets. Also, products can come when we
Gupta sir,
work.
please,
Yes,
please
yes,
wait down.
thank you. I'm done with it. So this is the product which is we have developed during the released after COVID, and then these are the results of the thing. Thank you very much.
Thank you, sir. You have rightly said about this biodegradable and sustainable fluids. Now, next session is it is on-load tap changer diagnosis based vibroacoustic analysis by Khushbu Thakur. Just a minute, just why you have sent me just sorry, just
Share guessing tendency of mineral insulating.
oh sorry, sir, just. So I request Manjusa Namir, yes, please.
Good afternoon, all of you. I really feel honored to stand before you all in this platform, and I am thankful to IMA, Trafotech, and ERDA for providing this opportunity to me. I am Manjusha Nambiar from ERDA, and today I will be speaking about stray guessing tendency of transformer oil. Transformer oil, also known as liquid dielectrics, apart from its normal functions like liquid insulation and cooling purpose, it also plays an important role in the operation and maintenance of transformers also. And nowadays, along with mineral insulating oil, ester-based oils are also getting used because of its enhanced advantages like biodegradability, environmental friendliness, fire safety, moisture saturation level, and so on. Now, gases are generated in this transformer oil as a result of faults which get dissolved in the oil. There are some other sources of gases also, such as corrosion or other chemical reactions, reaction of steel with water, or reaction of free water with special coatings on the metal surfaces, or internal transformer paints. Also, gases which are getting absorbed during manufacturing process or welding process get released into the oil later onwards. Now, with the help of these gas, dissolved gas analysis is one of the most important method of transformer condition monitoring. And depending upon different energy levels, different gases are getting generated, and by analyzing these gases, different fault categories such as partial discharges, discharges of low and high energy, and thermal faults of different temperature levels can be analyzed. For mineral insulating oil, this dissolved gas analysis is a well-established method with different interpretation methods such as gas ratio methods, key gas method, and different triangle and pentagon methods. Now coming to stray gassing. What is stray gassing? Gases may get generated in transformer oil without the occurrence of any thermal or electrical fault, and sometimes even at low temperatures, that is less than 120 degrees Celsius, and without any operational stress also. Such gases are called stray gases. Stray gassing may not be harmful for the transformer operations, but their presence in DGA may lead to misinterpretation of transformer conditions. And again, for mineral insulating oil, there are IEC and ASTM standards for analysis of stray gassing for fresh mineral insulating oil. But for ester oil, this dissolved gas analysis and also stray gassing behavior is still a study of interest. Hence, to generate more and more data regarding gas analysis for ester oils is of great importance. Now, in this paper, two transformers in service are discussed, one with mineral insulating oil and the other with natural ester oil. In both the cases, gas generation is observed without any fault indications. And again, one study is done in laboratory experiments of fresh natural ester oil using the standard methods of mineral oil, IEC and ASTM methods applied to natural ester oil for stray gassing analysis. And this data of transformer, natural ester oil transformer, and also this laboratory generated experiments applied to pentagon 2 of mineral insulating oil. We can see the results of. In the first case, this is a transformer with mineral insulating oil. Here we can see that the concentration of hydrogen gas, as the number of years goes, this concentration getting increased, and after a period of time this gas concentration reaches to a stable value. This gas generation may be due to stray gassing because there wasn't any operational difficulties for the transformer. This is another case of a transformer with natural ester oil. In this case, ethane gas seems to be generated even at initial level, and as the number of years goes on, this gas concentration increases and reaches to a stable value. Ethane is a gas which gets generated in ester oil even at low temperatures due to the oxidation reactions of that oil type. Now this transformer oil data of natural ester oil is applied to dual pentagon 2, then it was observed that the fault indication is getting the same as that of stray gassing for for natural ester oil also. This table shows the laboratory experimental data of natural ester oil using both ASTM method and IEC method. Again, this data also, when applied to dual pentagon 2, we can also here also we can see that the fault zone is getting indicated as stray gassing zone itself. We know that for low temperature faults such as stray gas, there are two standard defined methods for mineral insulating oil, that is dual triangle 4 and dual pentagon 5. When these data are applied to dual triangle 4, then we are not getting the fault zone for natural ester oil, but in the case of pentagon 2, the same fault zone is getting as stray gassing only. So we can say that in the case of mineral insulating oil, there is a high possibility of getting confused between stray gassing behavior and also partial discharges in the transformer. This can be differentiated either by continuous monitoring of the transformer oil through DG analysis or by partial discharging testing of the transformer. And in the case of natural ester oil, ethane gas is getting generated even at a low temperature, even less than 120 degrees Celsius. Even at initial fresh oil sample also we can see there is, sometimes we can see there is ethane gas generation. This is because of the oxidation reactions of the ester oil type. And in this study we can see in both the cases, that is the data from the transformer with natural ester oil and also the data of experimental analysis, in both these cases dual pentagon 2 could identify this stray gassing behavior of natural ester oil also. That's all. Thank you.
Thank you, madam. Now, next session is medium frequency transformer using amorphous and nanocrystal advanced core material. As this material represents a leap forward in its transformer design, mainly in distribution sector, offering improved efficiency and performance over traditional core-based transformer design. I request Anuj Sharma for presenting.
Yeah, good afternoon everyone. Today I will be presenting a paper on medium frequency transformers using amorphous and nanocrystalline cores, advanced core materials. So let's first of all talk about the history of, history of the transformers. So basic concept of transformers was developed in 1830s when Henry and Faraday, they did a experiment on electromagnetism and which remains unchanged till now. But it took around 70 years to evolve from principle to a usable apparatus. So for example, the first experiment was done in 1830s, but it took them around 70 years to build up a workable transformer, which was done in the 1900. A picture of the same is also shown over there. And below we have also shown a basic principle of a transformer, that there is a core and then over the core there is a primary and a secondary winding. So from primary side the primary voltage comes and the output side there is a output voltage. So what is the challenge in the transformer? So if we see the trend in any electronic and electrical engineering, so everybody is now focusing on reducing the size and increasing the performance. For example, if we see any mobile, any TV or maybe any other electronic equipment, everybody is focusing on reducing the size and increasing the performance. But same thing is not happening with the transformers. So how to achieve that? So that mainly depends upon the frequency. So there are two key elements of a transformer. One is a core and one is a conductor. So for the core, if we talk about the transformer core, so for the transformer core, the area of cross section can be calculated as a function of a voltage and inversely proportional to the operating flux density and a frequency, and n is the number of turns. And if we talk about the window area of a transformer which houses the conductor is defined as the following, where I in is the primary current, n is the number of primary turns, and kW is the window utilization factor, which can be which can range between 10 to 60% based on the insulation needs of a transformer. And J is the current density of the conductor. Typically it is either copper or aluminium. And from this above two equation we can calculate the core area and core conductor, this area product, which determines the overall transformer size. So if we see the product of area of cross section and window area, it is directly proportional to Vi, which is equal to P, and inversely proportional to B max or a frequency and a window utilization factor or current density. So in the last, if we see, it is inversely proportional to the frequency. So if we will increase the frequency, then automatically the size of the transformer will reduce. So this slide defines about the what exactly is the medium frequency transformer. So any transformers which operates in a higher frequency, maybe 1 kilohertz and above, and limit of the frequency can be in tens of the kilohertz. So here we have shown a separate block for the medium frequency transformers. Isolation capabilities up to medium voltage range being applied for substantial power range for utility application also. So this is a basic about the medium frequency transformer. So in the medium frequency transformer, what are the global mega trends? So if we see different applications either it is a solar PV energy or a data center power distribution or a UPS application or a wind energy, either it is a railway mobility or a EV charging, means rapid DC charging. So in all these application, as of now, there is not much of a usage or application of medium frequency transformer, but we can see there is already some kind of a power electronic circuit already available in all these applications. So by slightly modifying the power electronics, we can increase the switching frequency of the transformers, and we can convert this low frequency transformer to a medium frequency transformer, and the advantages will be like the reduction in the size and the improvement in the performance. So this is a typical example of a medium frequency transformer convenience with a coexisting power electronics arrangement. So all the application which I have discussed in my earlier slide, in all these application, by slightly modifying the power electronic arrangement, we can introduce a medium frequency transformer. For, like at the input side, there will be a medium voltage grid, and then there will be a medium voltage DC link, which can be either mega solar, mega wind, mega EV charger. And after that, the medium frequency transformer will come into picture. We will which will convert the medium voltage into low voltage, and output side, then there will be a LV DC link. Again, it can be a small solar UPS, EV charger, fuel cells, and LV grid will be there. So what are the advantages of using amorphous and nanocrystalline cores only for this medium frequency application? So in this table, we have compared different type of metallurgies available with us, and what are the losses of these materials at different Tesla values, flux densities, and different frequency range. So in our table, we have compared at 1 Tesla and 1 kilohertz, and in second column, we have compared at 0.1 Tesla and 10 kilohertz. So the different material which we have compared is a nanocrystalline uncut core, nanocrystalline cut core, amorphous 2605 SA1 matte glass cut core, 6.5% silicon steel, 0.05 mm thick, and 6.5% silicon steel, which is 0.1 mm thick. And in last four is the grain oriented silicon steel with our different thickness like 0.05 mm, 0.1 mm, 0.23 mm, and 0.35 mm. So if we compare either at a 1 Tesla 1 kilohertz condition or a 0.1 Tesla 10 kilohertz condition, in both the condition you can see the losses in the nanocrystalline and amorphous material are very much lower, so which can give you a very lower losses and a very good performance, and also you can operate your transformer at higher operating flux density to reduce the size of a particular transformer. So this is the main advantage of the nanocrystalline and amorphous material. Yeah. Thank you. This is all about my paper. Yeah. Thank you. Thank you, everyone.
Thank you, Anuj. Thank you. Now next paper is Superior Ester Dilutive Fluid for Sustainable Future, case study by Babu Rao from Raj Petro.
Good evening, friends. I am just talking in front of you regarding the sustainable era where we are moving. The government of India has started to cut down the CO2 by 2050. We have to restrict, so that we are moving towards the sustainable era where Raj Petro has come out with sustainable fluids, that is superior dielectric fluids for sustainable future. So why the need? Today our mega cities are becoming highly congested. So when there is a congestion, there is a safety issue arises, and when the safety issues are there, then the sustainable fluids come into play. That's how. So if you go in the past, unsustainable growth affecting climate, which is happening today, its users, then natural resources leading to droughts, then floods, then air pollution, then land erosion, deforestation, then rising sea levels. This is all happening because of unsustainable growth. Now, in the past, with the mineral oil filled transformer, one tragedy has happened in the Green Park of Delhi. That is Upar Cinema tragedy in Delhi, where in 1997 it has killed 59 people due to suffocation, and injured 103 persons because of transformer fire. Because matinee show was going on, the transformer was repaired and kept operating, and it suddenly caught a fire, and it has become a burning this thing. So that's how it has led, and that case has till 2023 it has continued. The unsolved brothers who have been penalized by the Association of Victims and they had to pay 63 crores, but they have went on halving that 25 crores, and lastly they paid very few amount to the survivors. That's how, and they have been put behind the bars. So now I'll just take you to the what are the advantages of sustainable fluids. Okay, sustainable fluids, when we say, they should be biodegradable and safe to the environment, and they should be fire safe. This is the very big advantage, these two parameters, and they should be K-class fluids. Okay, and biodegradability should be more than 60%, that is natural ester is 99%, whereas synthetic ester is 72%, and renewable carbon content should be high. That's how it is, and it should be water friendly. It should not hazard the water, so it should be water friendly. The flash points are very high here. For natural ester it is 327 degree, whereas for synthetic ester it is 265 degree minimum. The fire points are very high here, and auto ignition temperature, if it catches a fire, it takes hours to, if you compare with the mineral oil suffocate, comes out with a soot and it catches fire very fast, but where in sustainable fluids it is very late. You can take, it will take very long time, at the same time it will not harm the environment. Okay, it will not spread any soot, and at the same time net calorific value will be very low, so it will not harm the environment. That's how from this slide we can make out. Now fundamentally, if we see what is the difference between the mineral oil and the natural esters, the sustainable fluids. Okay, we are using this mineral oil since 1891. It is almost 132 years now. So they are all coming from when the OLTC has invented the transformer in 1891, then the ABB, Asia Brownbody engineer, who had said ki oil can be used as a coolant, but that time he had overseen ki natural ester will be the best oil, but the susceptibility of oxidation has made it took almost 32 years to use. That's how now natural esters are coming. So here, when we talk about mineral oil has non-polar bonds. Okay, they are susceptible to their moisture is a poison to them. Okay, whereas if you move from the esteric fluid, okay, the sustainable fluids, where the ester bond has a very polar bond. Okay, this polarity is the major gain for the sustainability. That's how it has a tendency to tolerate the moisture to such a high way, it keeps the paper always dry in the system by converting the moisture into a trans-esterified cellulose molecule. Okay, that molecule also is acting as a very, very good insulant inside the system. That's how the hydrogen bonding, if you see, the polar nature will always comes towards polarity. So that's how the water molecule and the ester molecule, they have a van der Waals attractions and the hydrogen bond. Because of this, it has a very high tolerance to moisture. That's how, if you see at the natural temperature, normal temperature, around 2500 ppm it can absorb in synthetic, whereas in 1100 ppm in natural ester. If you go to 80 degree, 5500 for synthetic esters and 2800 for natural esters. This much ppm you can hold, and this will make a product keep the product very healthy for many, many years. Okay, so now I'll just go to the case studies. We have done 2 case studies here. One is on the natural ester dielectric fluid. So I'll just take a first case study where we have studied the extended oxidation stability, because natural esters are made from the renewable source of oils, okay, vegetable oils, where the acids, the bonds unsaturation is present in the natural ester, that is susceptible to oxidation. Okay, that's how it leads to oxidation. So that's why the standard has come out with only 48 hours of oxidation stability. That's how we have extended it to 96 and 164, and we found that as you go from 48 to 164 hours, there is a slowly degradation, oxidation stability is there, but at the same time the viscosity will increase and makes the fluid further thick, and the cooling efficiency will go down. That's how it is given here. The acidity slowly it is increasing, and at the same time the tan delta is also slowly increasing, and the color drastically increasing. That's how it has been shown in this slide, where the color, initial color to this color, it has gone very high. That's how we have seen. We did the monitoring also. We did the stray gassing. We have seen in the previous paper the stray gassing ultimately for both the mineral oil as well as this oil we have measured here and we have shown it. They are within the limits. For the ester-filled, the ethane gas is the high. That's what we have to see in natural esters. And we did a monitoring for one of the transformer which feeding the power to the northern part of India, and we have done that. The transformer is, there is no degradation in the oil and it is working well. I'll just take you to the second case study where the similarly extended oxidation we have done up to 500 hours. The synthetic esters are very, very good. They are oxidation stable, and we have done the compatibility with the construction material. They are compatible except few materials, and we have done the monitoring study here, and the monitoring study in the retrofilled product, it is very good, and we have seen that the combustible gas concentration is within the limits. Okay, overall if you see the conclusion, the sustainable ester dielectric fluids are the best option to address the fire and environmental risk, and they tolerate substantially very high amount of moisture. Okay, that keeps the product very long and extending the life of the products for many years. Okay, natural esters are used in sealed systems because of susceptible to the oxidation, whereas the DJ fingerprint is same with the conventional mineral oils, and ultimately this product can be used for retrofilling, for enhancing the product life and taking the advantage. Ultimately you can develop a design a compact product where the product space can be reduced and at the same time the fire suppressants can be avoided. These are the advantages. So thank you.
Thank you, sir. After this ester oil, now we have a time for this OLTC. So OLTC diagnosis for, I request Khushbu Thakur for present this paper.
Thank you for having me here. We'll now divert slightly from the topic that we've been talking about, ester as a replacement for the conventional oil. So I'd like to take you to the OLTC. So it's a very commonly used component in your power transformer. Now, when we talk about OLTC, it is a key component of your power transformer. It is one moving part in your otherwise stationary device. So you're maintaining stable voltage with that, you are controlling the power flow, you don't want it to break before make, so you don't want to interrupt your current flow. And just to look at that small graph, it does contribute to quite a big amount of failure for your power transformer. So if we look at what are the different diagnostics that is possible with OLTC, this is just a quick comparison. The idea is that if you do static winding resistance measurement, that means what you're doing is you're measuring the resistance at individual taps. That means if you have some contact issues, if you have some kind of challenges with the whole circuit of the contact, then you will be able to identify that, but nothing in the motion, right? So it's a very basic test. It's a very good test, and it's an established test, so you can identify the faults. You will have FAT for that. You will do a face-to-face comparison, and great. You can find out problems from there. But what happens if the problem is in the moving aspect of your OLTC? So for that, the idea is to use the dynamic OLTC scan, or dynamic resistance measurement as they call it. What you're doing in that is you are monitoring the transient resistance or current while your OLTC is moving from one tap to another tap. So for those of you who don't really or are not very familiar with the internal construction of the OLTC, it depends on the rating of your transformer. But if you have lower rating transformer, you will have the selector and the diverter switch basically inside the same compartment. If you have bigger, I mean, if it is a generator transformer, let's say, and a huge one at that, so then you will have these two components separate. But the idea still would be that you want to, because you want to maintain that make before break, you want to have some kind of selector, pre-selector, so that that tap movement happens. And you want to have some kind of diverter switch where the movement will happen from one position to another via a few transition resistors. So, okay, so we can perform this test. Great. How do we analyze it? It is a fingerprint test. You need some kind of information in order to be able to compare it to the previous result or to some sister units and then try to compare. So it does check the dynamic behavior of your diverter switch. It can be performed single phase or three phase. And when you do three phase mode, then you can check the synchronicity between your phases as well. Of course, you can combine it with winding resistance, so now you get information about when you have OLTC in static position and when you have OLTC while moving. However, while your OLTC is moving, not everything is causing change in current. So this is only monitoring wherever you have a change in current flow or change in resistance. So then we work together with MR on this and try to, it's not a new test, I would say, vibroacoustic measurement, we have heard about it, but it's more of how to utilize that in assessment of your OLTC condition. So again, this is also a fingerprint test, but it allows you analysis beyond the changes in your conductive path. So any changes in your current flow, that'll be detected by the dynamic resistance measurement or dynamic OLTC scan, and this will detect things which are more mechanical. So it can be measured online and offline, and you can combine it together with your OLTC scan. How do we do it? Idea is to use your same old piezoelectric sensor, of course not same old. I mean, the frequency range would change, but piezoelectric sensor is again not new. But you're using that, you have some data acquisition unit which captures that data, you analyze the raw data and send it to your PC to do all the magic that happens there, right? Where do you install the sensor? So either the best position to install the sensor would be on the OLTC cover so that you capture the data very accurately. Otherwise, you can install it on the transformer tank wall where your OLTC is located so that it captures the movement. And the best sensitivity would be where it causes acoustic emissions. So these are some of the positions where this can be installed. As you can see, on the tank wall, it can be installed through magnetic sensors, and on the tap cover, you can screw it, and it gives you that information. Now, this is the raw signal that was captured from the piezoelectric sensor. The blue one is the signal that was captured from the tap cover, and that gives you the maximum sensitivity. So here you can see at 5 seconds we have a peak, which is actually the diverter switch movement, which is captured the most. It causes the highest vibration. And the green one is actually your motor current waveform. Furthermore, the study was done slightly more, putting the sensors at different locations to see how the sensitivity is affected. And if you see the blue curve in this, that one is for the OLTC cover, which captures about 4 volt. And if we see the green one, which is on the tank wall, this captures about 2 volts. So you can see that the further you move away from the location of your OLTC, the signal attenuation will happen. So you can see a comparison of the signal strength. And if you place it next to the operating mechanism, of course, there is a lot of vibration caused by that, by the operating mechanism. So the signal strength reduces further. When you get the raw data, from the raw data, you will do continuous wavelet transform. So now the biggest challenge is how to make sense of this information that you're getting. So you take the raw data, do a continuous wavelet transformation, and you get a frequency time diagram. Now this one gives you the signal attenuation. So how much is the signal strength? And it is color coded, so you can see very clearly where you have a good signal to noise ratio, and that that indicates your starting of the motor, stopping of the motor, and also the diverter switch operation. So the middle one is the diverter switch operation, and the beginning and end is the starting and stopping of motor. Furthermore, you can, the next step is getting the frequency mapping of that, so from 10 kilohertz to 100 kilohertz. And if you see, this is the envelope curve for that, so that you can see the signal energy of that whole signal during the whole operation of your LTC. So the envelope curve is further zoomed in here, and then we try to combine it together with DRM, or dynamic OLTC scan. The idea here is, one is capable of detecting the current changes. The other is capable of detecting the mechanical changes. And if you see some of the points here, so the red lines, they actually indicate more of current changes, the conductive path changes. And the green highlights are indicating more of mechanical changes. So pre-selector is not so much detected in the current change, but it is detected in the mechanical change. So once you combine these two, it gives you the bigger picture. So it's like you're going to the doctor and trying to do a holistic analysis to find out where the problem lies. This was an example which was conducted
Madam, please
on...
wrap up fast.
Yeah, we'll wrap it up. Thank you. So just as this is one example where two identical 400 kV by 27 kV transformers with MR oil type G was done, and you can see four different tap positions. It shows very clearly the green one, the blue one is the measured transformer, and the green one is the sister unit, and there is a very good overlap, or there is a very good convergence, high convergence of the signals, so they can be seen very clearly. There is a slight deviation in the parity. So when you compare even in odd positions, there is a slight deviation of about 40 to 50 milliseconds. So you can compare fingerprint for equal parity, so whichever is identifying. And this also shows the zoomed in view. So with that, thank you for having me here, and that ends my presentation. Thank you.
Thank you. Now last paper, new trend in OLTC application and Indian perspective. I request Pranav Sankar from CTR.
Yeah, good evening. Thank you, Aima, for having me here, and thank you, Chairman Sir. Chairman Sir, since morning we have been discussing about equipments in few crores, so allow me to present something which is in few lakhs, if not more. So it's a very, very important product, so OLTC. So we are trying to share with you what are the various applications and what are the challenges it gives to the designer for OLTC. Like OLTC seems to be a very simple device, but believe me, the amount of moving parts and the sharp edges, it's a kind of a nightmare for any designer to do a field plot on that. So I'll be taking you through this presentation, which mainly deals with 4 areas of application: traction, distribution, something about digitization, solar, and of course then there is, in the end of the presentation, there is some technical and economical aspects of that. So traction, like traditionally, it has been off-circuit tap changes, but with the advent of railways, we are seeing some OLTC going into this, on-load tap changes. Distribution is a very, very big segment. Now with the advent of renewable, things are like a lot of various applications are coming up. I'll be covering solar, which is the advent of solar parks coming up, and grid connectivity with the solar parks, and the digitization part, which my earlier presenter also shared, and how we are doing on that. So traction applications, as I just said, like traditionally off-circuit tap changes have been the preferred one for railways. Now with metros, OLTCs are which give fine voltage regulation, feasibility for wide range of voltage regulation, less dielectric checks between adjacent taps, reducing insulation requirement, automatic voltage regulation without need for de-energizing, eliminating downtime for regulations. As you can see in the table on the right, you can have regulation per step of 1.67%. So these are applications up to 245 kV. So we have all done all these testing in our in-house lab. So I'll just come to that in later part of my presentation. Distribution is a huge area for application of OLTCs. So it's a large volume driven segment. Large number of suppliers are there, dielectric stresses as in line end and middle end of the winding, increasing demand in commercial load like malls and data centers. So each application has its own challenges. I'll try and cover as much as possible in this presentation. Non-linear load, as you would be knowing, low loads are much bigger challenge with the capacitance and cable capacitance coming into picture. Lack of product type testing. So with the, particularly in distribution segment, so many players are there making transformers as well as tap changers. So type testing, well, I will not comment much, but lack of type testing is a simple word which I am trying to put to. Lack of information on end application, that's where our company is working on a lot. Solar, like with the solar parks, it has brought in new challenges. So like OLTC per se, everybody would say it's the same thing, but different application requires a different design. So we have learned it the hard way. So solar, they are dynamically, loads are changing. In low load condition, voltage application through the cables on account of its capacitive nature. And frequent nature of this high stress can consequently lead to a dielectric failure. Another aspect is introduction of harmonics, which again is a very big challenge nowadays, and transients in the system. This too leads to stress in the OLTC. Digitization, which is something now as a company we are doing it in a customized way. So depending on the customer need, like traditionally transformers and OLTC have been monitored with conventional planners. This is what we are all familiar with. We have seen this in earlier presentation also. Consisting of indication, oil winding temperature, monitoring is done extensively by operators by means of hourly logbooks, so on and so forth. So a need has been felt by our customers need to monitor transformer and accessories. So like we have a feature, though we are a OLTC supplier, we have a mechanism where we monitor OLTC as well as the transformer. So depending on the needs of the customer. Existing methods are only recording data. Data analytics to plan maintenance of timely intervention of major issues. Like what we talk about like predictive and proactive maintenance. So this kind of data is helpful in that. Compliance to communication protocol EM and EMC standard required to get correct data and minimize loss of data during transmission. So coming to the technical consideration, like we all know standards are there, but we feel the standards are only a minimum requirement. So what we have done is we have made our own lab. We do extensive testing, and fortunately that lab is NABL accredited, which we'll share something on that also. So depending on the application, like even a dry type transformer poses a different challenge than all type transformer. We have seen it. The voltage stresses are different. So those kind of simulating those conditions over and over the standards, we do it in our own NABL lab. Product supply needs to be assessed for its reliability, a variety of tests. OLTCs for new emerging application require the reliability evaluation more often and more rigorous than the existing application. So with the new applications coming up, so we need, our OLTC has to be ready for, like we can't give one OLTC for all kind of application. That's what we do in our own labs. Realizing the need to test reasonably predict the reliability of OLTC during the field service, detailed experiments were conducted in our lab. After setting up special facilities for service duty test as per IC specification, it is prudent to share the information of the test and the basic test results. So we try to focus on two things. Will the performance of the oil field OLTC be satisfactory for crucial service duty test, which is considered as an asset test to assess the field performance and capability of OLTC? Will any uprating or derating of the product specification of the oil fuel OLTC will be necessary for a given application. So again, application comes in based on the outcome of the test. Experiments were done to address the above issues. So samples performed satisfactorily for service duty test for 50,000 operations with current and voltage. So we do, after every 10,000, we do some testing and we store that data. So this kind of, and the results in detail of this test are given in the paper which is in our reference if you have that book with you, and which we have presented. Few of these tests we have done on ester-filled also. We have presented in last year in a paper we presented in Spain Civil. So a lot of work has happened in this section. A number of additional parameters were monitored, such as breakdown voltage of moisture content, tan delta, interfacial tension, viscosity, composition of oil, FTR, arc resistance, fiberglass, and other solid dielectric material. Comparative tracking index of solid dielectrics and DGA. So below are the two photographs which you see from our lab, and on the right side are the few samples. This is the last slide, economic consideration. Now, as I just started my presentation, where I am talking about equipment which is worth few lakhs and which is supposed to do work for equipment worth maybe a few crores, if not more. So, a lot of time there is in this cutthroat environment, people compromise on on quality of the tap changer. We are in this business for 50 years, so we know when a customer returns back to us after 5-10 years, he understood what is the quality. So what I'm saying is, like, based on the application, the pros and cons has to be weighed on. The initial cost of equipment should not be the only concern on selection of the equipment. Evaluation of all technical parameters vis-a-vis commercial before selecting the product always help. Products offered without complete tap testing can jeopardize the parent equipment, i.e. the transformer, may incur financial loss outweighing the savings at the time of procurement. Cost of ownership like maintenance cost, spares and downtime cost needs to be carefully considered by the end user before selecting the tap changer. So with this slide, I would end my presentation. Thank you very much.
Thank you, sir. So this is the end of the session. And in this session, we have talked about the ester-oil advantage and about the OLTC. So now, first of all, thank to all the speakers. And now session is open for any question. So please speak.
Yeah, from this side, Mahendra speaking from Hitachi Energy.
Sir, just 1 minute. Just he is first. He raised his hand, sir.
Okay, thank you. I have only one question to Ms. Manjusa Nambiar. You have used the same triangle and the pentagon for the ester and the mineral oil. But for the ester oil, you know, it is a triangle 3 and pentagon 3. But why you have used the pentagon 2 and the triangle 2 for that?
So the reason is that ester oil triangles and pentagons are those just trials. They are not standard methods as of now. So this standard methods of mineral insulating oil, that's why I have implemented that same, tried that same.
No, the Duval has already standardized. Mike Duval, he has got elaborate methods and all, and he has already given triangle 3, and for different type of oils for the triangle 3 he has analyzed.
Yes, that
and
is
also
there.
The triangle, also the pentagons.
Sir,
pentagon 3 specifically he has done for that.
it is there in different papers, sir, but in none of the standards it is mentioned as of now. Even
which standard you are talking about? Like
standard methods of DGA.
I do not know for the DGA for the ester oil whether it is mentioned, but generally in the case of they don't mention about the ester oil in the case of the DGA standards. Like, so for that ester oil there are separate DGA standards.
As of now, sir, for ester oil there is no standard interpretation methods now. And these triangles and pentagons are?
There is one, I think you can. There is one. I also don't have the number, but there is one.
IEEE standards, IEEE is there, but that is also a collection of number of papers, case studies and all that. There is not standardized method as of now it is provided.
Michael Duval has very clearly, he has categorized triangle 1 and 2, triangle 1, 4 and 5 for the mineral oil, triangle 3 for the triangle 3 for the purpose of the ester oil, and pentagon 3 he has given for the he has defined, and it is Michael Duval who he himself has done. It is in his name only. So I thought you should basically try the triangle 3 and the pentagon 3 also to do your analysis through that. That is my only suggestion. Thank you.
Yeah, okay, sir.
So next is from Hitachi.
Yeah. Actually, it is good initiative that saying that Savita, Apar and Raja Petro also developing as a ester oils Make in India initiative. when it comes to acceptance, adaptability of ester fluids by system operator utilities, in the view of economical aspect. Earlier the solar and wind is very high comparing to the thermal, but nowadays it is very comparable also. So my first question is that, is there any initiative to these ester oil suppliers, especially for Make in India, for compare the price of the ester oil with the mineral oil in the same level? And second question is that about the utilities and also system operators and private customers, because ester has special advantages apart from oxidation stability, biodegradable, it has a withstand capability of temperature very high also. So, but still if you see the technical specification, the temperature rises are only for, which are mentioned for mineral, same levels are mentioned in the ester oil specifications. Okay.
Yeah, can I answer on your question? Yeah, thank you Mahendraji for your comments. First, you talked about cost. When you talk about sustainability, you are looking at improving certain things, and then as the market starts accepting certain product, things will improve and you get into that line. So you what is not there in the mineral oil, what is there in the additional benefits in the ester, that is what is the question in terms of sustainability. And regarding market acceptance or whatever, your company, you have been talking all in social forms about that green rated transformers and all, where one of the key component is esters only. So whether you're talking about star rated transformers using esters or renewable this one, so Hitachi itself also practicing use on this particular thing to improve sustainability. So whenever you want to improve sustainability, you need a components which is to be sustainable, and which will most at the moment they have to come from renewable sources. So there will be a point where when the usage starts becoming, if you see for example lubricants, the earlier era of lubricants all have come only from vegetable oils. When mineral oil has become more and more available, crude oil has started exploring, and then everything has changed. So I think these are dynamics will keep changing, and yes, there are a lot of advantages, and then thermal capability, heat capacity, thermal conductivity of these esters, whether it is natural or ester, they're more than this one. And then regarding the handling of esters, even our Indian OEMs have come up with in terms of design changes. Mr. Jala also mentioned about what they have done on 400 kV that reactor, or now what GETCO has done when they tried this one. I think design will improve when you need, for example, today when you want to improve the fire safety, Mr. Baburao talked about Upahar incident or wherever, a lot of incidents, this is the point where you need a K-class fluid, so you have to, you cannot get the same thing. If you want to get the similar K-class product in mineral oil, you need to get a viscosity of 100 plus. Is it possible to really use this in, no, it is not possible. So definitely, and when you talk about made in India, yes, the products are made in India, are made for India and made for the world, and people are exporting these products. Transformers, a lot of OEMs are also exporting the products with esters also. I think time has come, and time will come, continue to be there for esters and alternate fluids.
Yeah, and another thing I would say, maybe so the dynamics of the market, it is always there. So one fine day you can see that there are price can slightly to some extent can go down, but it is based on the availability of the raw material what the manufacturers can provide.
My question to Pranav. Pranav, you said that you said that for different applications you need to consider some factors for selecting a tap changer, right? So what precautions you are taking for the tap changers which are to be used for evacuating power to the grid from the solar parks?
Sir, firstly I'd like to tell you we have learned it the hard way. So when we are giving a tap changer to a customer, we understand the application what he wants. Like I'll just, without naming, I'll give you an example. A solid transformer required an entirely different tap changer. We tried supplying the conventional one, it failed. So we are, I'm not saying there are standards for all application, but we at our own, that's why we made a lab in-house, just to understand what is going on. So for solid, solar, maybe wind now, so solid and solar is something which we are working on extensively, and other applications. So it's not, we are not able to predict what design we're going to have. We first understand the application, do some study, and we have our past experience where we have failed and we have learned from that, and that's how we give different tap changer for a different application. Maybe for solar it will be slightly different. A solid transformer it will be different. A conventional transformer, maybe like what Crompton is making, it will be different. So it's something which is ongoing.
So
it's because of our lab which we have, we are able to do that. Otherwise, we would not.
No, I understand that.
Yeah.
But we have been supplying transformers for the solar parks for evacuating power.
Yeah.
But nobody has asked us what is the application, whether it is meant for solar or anything, and none of my tap changers, whether I bought it from X or Y, has failed. So neither we have received any complaint whatsoever, for that matter, or even I don't know. I'm hearing it for the first time.
Nice. Yeah, what you're saying is right, because you see, even the failure rates may be negligible, but we don't, even like our other products like NIPS, we have a slightly different design for solar, like my colleague will be able to answer on to that also. So what you're saying is also right, the failure rates are very, very less, but we have seen from failures it requires a slightly different understanding. Dry type transformer has a slightly higher potential on the winding port which is coming to the tap changer, so we need to design it slightly differently. So those things come into picture, like tap changer, it's a complicated product, like so many sharp edges, so many moving parts. So we at least now we are doing it. For the last 3-4 years, which I am like aware, I went too deep into this subject, we are trying to understand the application and we are supplying according to that.
Okay, last one question.
I have one comment to make. I'm Narasimhan from Savita Oil. I have just one comment or clarification to make with respect to what Dr. Baumik has commented about DGA. This is just to clarify that there is no DGA standard from any international body of IEC or IEEE on DGA of esters. I think IEEE may be having, but IEC for sure doesn't have a DGA standard for esters. They have all standards for mineral oil. For the simple reason that we don't have enough field data or experience with respect to ester oils on DGA. And DGA, of course, will cover not only the fault gases, it also will cover the stray gases, which are non-fault gases. So to that extent, I think it is, whatever Michael Duval has written, that is another thing I must clarify. Whatever Michael Duval has reported, they are essentially based on limited field experience and laboratory experimental data. So under various conditions, how the esters behave, that data was collected, and he has, Duval has come up with his extended triangles for stray gassing and other DGA. In fact, not only stray gassing, he has also given clarifications on the DGA gas, fault gases. So this is by way of clarification.
I think due to shortage of time, just last question, one more question, please.
Hello. Yeah, this is Ashwini from Adani.
Question, not any comments, please.
Hello. Yeah, this is Ashwini from Adani. My question is to Mr. Gupta. In your presentation, you have shown limitation of ester related to the lifespan of this oil as compared to the counterpart mineral oil. So, is there any study or on unit basis you can just tell us, let's say, what would be the lifespan of ester oil as compared to mineral oil?
The data I have shown is based on the bench test, that is the IEC 601125 method C, which is used for evaluating the oxygen stability of natural esters. The standard itself is defined as at 48 hours, 120 degrees centigrade, and then at the end of the test you measure the viscosity buildup and total acidity. Whereas for mineral oils, for uninhibited mineral oils, as per conventional IEC standard, it is 164 hours. So what we are comparing is the method is same, and when you extend this test from 48 hours to, as you proceed to 164 hours, the way of evaluation is increase in viscosity. The conventional esters that are available in the market, they cross the limit of 30% viscosity buildup. That is at the end of the test. So they start building up the viscosity. Basically, the oxidation continues and polymerization makes it more and more polymeric, high viscosity. So the data what I have shown is compared to that standard oxidation test of 48 hours versus 164 hours. So that is one. The second is we are talking about thermal aging in the open and sealed beaker. What we are, again, that is showing the viscosity build-up in thermal aging at 120 degrees centigrade as per the IEEE method. And then when you see how the viscosity builds up, how the some of the data only we have shared here, but basically, yes, the product what we are talking about is got high thermo-oxidative stability compared to the conventional esters. When it compared to, normally you accept a product based on, and that is the standard timeline of oxidation. That is the criteria where you say the product is, stable for, how many times or kind of thing. That is what is the data we have shown.
Sir, the lifespan will be approximately 8 times because of the tolerance of moisture. What happens? This product keeps the paper always dry. Okay, because of that, the lifespan of the product will increase drastically. So the initial cost will be very high. When you are asking the initial cost, why not to bring down? Initial cost will be high, but the lifespan is so high, the cost is incurred. So that cost will be covered. That's how it is.
Thank you, sir. So at the end, just concluding, we can pave the way for future where transformer not only meet the demand of our evolving energy landscape, but also contribute to a more sustainable and reliable power infrastructure. Thank you to all.
Thank you so much, session chairman and all the authors for touching upon very important topics of the input materials. Today we have with us very distinguished guest, Mr. Debjot Das, MD, Assam Electricity Grid Corporation Limited. Sir, I would request you to come up on the stage and felicitate our authors and the session chairman. Dr. Sunil Tonde. Yeah. Dr. TCSM Gupta. Ms. Manjusha Nambiar. Mr. Anuj Sharma. Mr. Baburao K. Ms. Khushbu Thakur. Mr. Pranav Shankar. And our session chairman, Mr. Kuleshwar Sahu. A big round of applause for him because this was the biggest session of the conference and really conducted very well within the time frame. Requesting all the authors for the group photograph, please. Thank you so much. Before we break for the tea break will be for 20 minutes. Prakash sir has some announcement to make. Thank you.
Good evening. Nice to hear this. Friends, before you break the tea, there is one more nice technical program is there, and after the session you carry all the knowledge. Tomorrow we have some great programs. Do not miss it. Third day is a crucial day. We have Lifetime Achievement Awards. We have a great speech from Mr. Rajaram Shinde. We have an Industry Academia panel discussion. Very beautiful thought process are coming. Professors, it's one of the very few audiences where professors, our industry, utilities are collaborating together for new ideas. Do not miss it before you go back to your own city. So, program starts tomorrow at 9:15. Please be there and finish the lunch. We can push off after the lunch. Are you okay? Will you participate tomorrow? Thank you, boss.
of our customers, stakeholders, and partners for the better. And since we are in the business of transformation, our goal is to transform the future via our three-pronged strategy focusing on best-in-class energy efficiency, reduced global carbon footprint, a sustainable and inclusive future. The time to transform is now. Join hands with Technical Associates Limited. Let's transform for the better together.
What is omnipresent, just like air? What is the force that surrounds us? What is it that gives wings to dreams and ambitions? It's energy. Energy that illuminates lives. Energy that builds a nation. Energy that brings cheer. Energy that unifies and unites. It's in every form and it's everywhere. What is this energy that connects and binds us? It's REC. It's the core of an ecosystem that's all about energy. Energy for the now and energy for tomorrow. It's about industry and growth, integration and diversification. It's about opportunity and productivity, connectivity and community. For the here and for the future, REC unleashes the potential of energy. REC funds energy. Funding that catalyzes, funding that inspires, funding that transforms. It brings us together with each other and our partners. For sustainability and reliability, for investment and development, adding value every day in every way. This is what our energy is. This is REC. It carries with it the dreams, the aspirations, and the hopes of 1 billion, with the promise of endless energy
and infinite possibilities.
Established in 1937, CG Power and Industrial Solutions Limited is an engineering conglomerate with an impeccable and diverse portfolio. Our products, solutions and services support our economy's power, railways and industrial sectors. Industrial Division. This is the largest business of CG and is primarily India-focused. 1 out of every 3 motors in India is a CG LV motor with international certifications. CG is the largest manufacturer of low-voltage motors in India. We are the first to develop a complete range of IE2, IE3 and IE4 motors in India. Our single-phase motors unit caters to agricultural, domestic and industrial applications. Our HD motors are designed to meet diversified application demands. Our stampings division is fully equipped with the latest high-speed blanking lines, H-frame high-tonnage presses and CNC precision notching machines. Drives and Automation has over 40 years of experience developing, manufacturing and delivering state-of-the-art motor control equipment with cutting-edge technology. CG re-entered the FMEG segment in 2019 with a wide range of consumer electrical products like domestic and agricultural pumps, industrial and domestic fans and water heaters launched over the last few years. Power Division. CG is a leading Indian manufacturer of developing and supplying power and distribution transformers. We supply locomotive and trackside transformers of various ranges to the Indian Railways. CG manufactures switchgear products like condenser bushings and current transformers suitable for high altitude and seismic zones. Our various switchgear products conform to IEC, IEEE, ANSI and GOST standards. At the switchgear unit, we manufacture the finest gas circuit breakers and surge arresters, polymeric and molded to suit multiple industrial applications. We have indigenously developed gas-insulated switchgears from 11 kV to 245 kV class. We also offer customized power quality and automation solutions with crucial equipment. Railways Division. CG is a leading manufacturer of traction motors, alternators, control equipment, propulsion systems for electric locomotives, multiple units, diesel-electric tower cars and railway signaling equipment. Our TMS unit offers traction motors and alternator control panels for diesel-electric tower cars, loco and multiple units. Our RTTE unit offers propulsion systems, traction converters, auxiliary converters, vehicle control units, control panels and drivers' desks. Our RSD unit manufactures a signaling product range with innovative expertise. Management transition. In November 2020, Tube Investments acquired a controlling stake. Working ahead, our plans include doubling the motor capacity to cater to the domestic demand, export EV, expansion of our transformer manufacturing capacity to meet the rising domestic and global demand, and to have technology tie-ups to participate in several projects announced by the Indian Railways. At CG, we are constantly working on empowering people to do great things every day. Let's energize the world together.
Transformers are static electrical machines, but need proper maintenance and operation, which is often ignored, leading to their failure. Transformer maintenance is a periodical and expensive affair, currently involving a lot of human intervention, resulting in data which may not be fully accurate or reliable. Therefore, it is difficult to monitor transformers with a reasonable sense of accuracy. However, what if your transformer could self-diagnose itself and inform you or alert you accurately about its health? In short, what if your transformer became an intelligent transformer and could speak for itself? In addition, you could extract enhanced power from your transformer at maximum efficiency and utilization with cost savings. Introducing BOLA, that is, Better Operation and Life Cycle by Analytics, for distribution transformers taking a leap to the next level of innovative digital and enhanced technology solution from CRIFS, an investee company of Toyota Motors Group Company. This would result in your maintenance staff managing your transformers from schedule-based maintenance, which is expensive, to condition-based maintenance. You can observe your asset location, critical and vital operating parameters in real time, spread across geography, and compare this operational data for productivity, cost, and plant efficiency parameters. BOLA can be fitted on new transformers or can easily be retrofitted on existing transformer at plant location. Installation of the sensor and hardware can be done with minimum plant interruption. CRIFS Technologies aspires to help utilities and industry to reduce failures in distribution transformers, thereby saving OPEX and CAPEX costs and making the distribution system more efficient and reliable.
Power Oil from APAR is the leading brand of specialty mineral oils. With 2 large lube blending plants, APAR offers cutting-edge technology solutions in transformer oils, industrial oils, liquid paraffins and white oils, and lubricants. Automatic filling and sealing of drums with centralized SCADA control. Driven by continuous R&D, APAR has developed a diverse product portfolio of more than 400 grades of specialty oils. APAR introduced several special grade oils for demanding applications, including transformer oil for 800 kV extra high voltage DC systems. Powering the performance of new generation vehicles in the South Asian market, APAR offers the world-renowned ENI brand of engine oils and greases through an alliance with ENI SPA of Italy.
takes pride in being recognized as one of the leading quality-conscious power equipment manufacturers and exporters from India. At Danish, we believe in building a legacy by looking to the future. Established in the year 1985, we are manufacturing and exporting products ranging from power and distribution transformers to control and relay panels with substation automation systems. With a state-of-art infrastructure coupled with a testing facility accredited by NABL, we produce and test as per the highest international standards. With a detailed integrated management system including ISO 9001 for quality, ISO 14001 for environment and ISO 45001 for health and safety. We cover all aspects to make a quality and sustainable product. Our people are our strength. With an in-house design team, continuous design and development work leads to most robust designs. At Danish, exports continue to be a major focus area for Danish, and thus we are exporting to over 30 plus international markets currently. We are also manufacturing various types of special application transformers.
For eons the planet has provided, and we have taken. It worked beautifully until scientists realized that increasing contamination of ecosystems is disturbing the natural balance, and the rate at which we extract resources is not sustainable. The human race is ingenious, and when determined to find solutions, we usually do. At Hitachi Energy, we take sustainability seriously, and that responsibility is at the heart of our iconic transformers. Developing sustainability solutions, co-created with our customers, is the key to our iconic transformers to achieve decarbonisation, enhancing safety for people, protecting surrounding ecosystems, and responsible use of resources. A quantifiable, evidence-based approach built on our deep domain expertise in transformers offers transparency on environmental impact using scientific methodologies such as life cycle analysis studies, followed by best-in-class solutions to improve sustainability performance. Even small electrical losses in transformers add up over the lifetime, resulting in significant carbon emissions and wasted power that could be saved by transformers with enhanced energy efficiency. Transformers contain large volumes of material which, through intelligent design and use of material, can be made more sustainable. Eliminating mineral oil leakages for protecting surrounding ecosystems and enhancing safety is vital. In addition, end-of-life recycling and reuse are an important step towards a circular economy. Our iconic transformers are just one of the ways we contribute to the energy transition in which electricity will be the backbone of the world's energy systems. Let us be your partner in the sustainability journey.
In a world where energy drives progress and shapes the future, Indotech Transformers stands out for its unwavering commitment to powering your world with reliable, sustainable transformers, leading the way in the global energy transition. Our manufacturing plant proudly features cutting-edge infrastructure and state-of-the-art equipment, a testament to decades of excellence. Our Winding Bay facility operates under dust-free conditions, ensuring the highest quality of production. In our NABL accredited lab, every transformer undergoes rigorous quality checks, ensuring reliability and safety you can trust. Our transformers extend their powers across nations worldwide. Our product range encompasses a spectrum of possibilities, powering your possibilities with reliable transformers. Distribution transformers, tailor-made for residential, commercial, and industrial applications, come in various capacities. Large power transformers manufactured under sterile conditions.
Good evening, everyone. I think after a cup of coffee and tea, all are awake again for the wonderful session. So may I now request everyone who are standing may take their seats so that we can start the last session for the day, which is one of the most interesting sessions because it is going to take you about the innovation and futuristic trends. So everyone please take their seats, and with that we will start the session. For the session chairman, I would now request to call upon Mr. Jayasanan. Mr. Jayasanan possesses an impressive academic and professional background. He has obtained his Bachelor of Engineering in Electrical Honours from NIT Durgapur, West Bengal in 1987. And later he completed his Master of Science in Manufacturing Management from Birla Institute of Technology, Plani. With 35 years of experience in transformer design, he has held position in renowned companies like Andrew Yule, KEC, BBL, and Virginia Transformer USA before joining to Siemens Energy. He is well versed in various transformer technologies tailored for different markets. Presently, he holds leadership role and heads engineering at Mr. and Mrs. Siemens Energy Transformer Factory, India. His expertise extends to transformer up to 1200 kV and shunt reactors up to 800 kV, and he is recognized as a local key expert in the field. We welcome you, sir. For the sessions, I would now request for the first paper, Mr. Basu Madhuvanath. Mr. Basu obtained MTech in Power and Engineering Systems in 2008 from National Institute of Technology, Karnataka. He joined Siemens in 2008 and working as design manager in electrical design of EHV transformer and shunt reactors with more than 15 years of work experience. We welcome you, Mr. Basu. The second is Mrs. Manali. Mrs. Manali possesses a Bachelor of Engineering Electrical degree from Father Angel Institute of Technology, Mumbai. She has done her postgraduate diploma in Electricity Regulations from Maharashtra Electricity Regulatory Commission in 2010. Presently, she is working as a Deputy General Manager at Adani Electricity Mumbai Limited and looking after transformers and reactors vertical for the engineering section. We welcome you, Ms. Manali. The third is Mr. Mrunal Pandit. Mr. Mrunal Pandit is an electrical engineer working in Hitachi Energy and having more than 8 years of experience in design of power transformers and distribution transformers ranging from 250 kVA to 140 MVA and 400 volt to 220 kV voltage class. We welcome you. The next is Mr. Sunil Sachdeva. Mr. Sunil Sachdeva, having an experience of 25 years in transformer design, Department of Power, transformers and shunt reactors up to 800 kV voltage class, controlled shunt reactors and phase shifting transformer at BHEL Bhopal. He has received Best Paper Award at Transform 2011 and CPRI Conference 2014. He also possesses 7 patents related to transformers filed on behalf of BHEL. We welcome you, sir. Next is Mr. Budi. Mr. Budi earned his Bachelor of Engineering, Electrical Engineering from PLN Institute of Technology in Jakarta in 2003 and has over 17 years of experience in electrical and mechanical engineering, particularly with the design and manufacture of electrical transformers. Based in Jakarta, Indonesia, as MIDEL application engineer in APAC region, Budi is well placed to help MIDEL customers maximize total cost of transformer ownership, drive down risk and bring about safer, greener power network. We welcome you, Mr. Budi. The last is Mr. Srivastav Govind Srivastav. Mr. Govind Srivastav is BTech in 1994 from Lucknow University and a doctorate from IIT Bombay in 2020. He has 29 years of experience in design up to 800 kV transformers and reactors. He has also worked in quality testing and commissioning area extensively. We welcome you, sir. Now I hand over to the session chairman. Over to you, sir.
Good evening, all of you. It's my prestige and honor to chair this at the last session, the titled "The Future Innovation and the Future Trends of India, Future Trends of Transformer Industry and the Futuristic Transformers for 2030." As the name suggests, the innovation is a very, very important topic, and according to me, the transformer industry is at the crossroads of a massive technological changes are expected to come, because yesterday I happened to attend one event which was about AI, and when I looked at certain things in that, the way in which the outside world is moving, I honestly believe that the transformer industry has to, and the ecosystem in the transformer industry has to change or adapt itself
to the latest technologies. So the innovation is the key thing to achieve that, and therefore this session is of great importance for the whole of us, all of us. And and today we have 6 papers. All of them are very interesting papers, because when you say futuristic, we can expect whatever we are discussing today, we can expect these type of transformers in the year 2030. So that will be the objective for all of us. So we need to watch out for all these papers today, because we can expect this type of transformers to come up in 2030. And I am sure that because most of the papers, whatever has been prepared, are also fully aligned with the power sector or Ministry of Power expectation on various topics, such as offshore wind, or you talk about sustainability and the carbon footprint emission, environmental product declarations, and esters, and some of the, in fact, changes in the way in which we operate our industry. Even the change of business model may be required. So these are all very, very important and vital for us, and therefore we need to listen to each of this technical paper very carefully. And being the last session, we have very limited time. We need to stick to our time. I request all the authors to stick to the 9 minutes time which has been given to you. So please ensure that the timeline is mentioned. To start with, I would like to start with in the reverse order, and I request Mr. Govind Srivastav to take up the first paper on case for business model transition in transformer industry from product to service-oriented digitalized product industry. Thank you.
So please pardon me, sir. I have to change the presentation here. So the last presentation first. This one? No, it's the last one. Govind Srivastav. It will come up. Okay. So good afternoon, Chairman sir, and August gathering here. I would like to present a very simplistic approach to all of you, and that is looking to what our industry has been doing in past eventful 1.5 decades or 2 decades, and then I would like to take the data-oriented validation from field, how that work has translated into field performance, and then we reflect, are we on the right track? Mostly yes, but some adaptations, some changes are needed because all other industries are also changing. So that's how my presentation will be. So if I go to the data that is published by CEA or Powerline magazine or Ministry of Power, and if we take a window of 2014 to 2019-20, we see the capacity addition of basically power transformers. It has moved from 5.82 GVA, from 5.82 GVA to 9.42 GVA. And this is a significant, close to 5,000 GVA addition. And in this, in the backdrop of this capacity addition, if we see 2007, first 800 kV transformer comes into our system, and in 2010 we start to discuss standardization. So we are not far behind about thinking what should be done in such a trajectory. 2015, circa 2015, we roll out first set of standard losses. And 2021, there is already a comprehensive one nation, one specification rolled out. It's a very, very comprehensive document. And industry rose to manage this growth by heavily investing in plant and machinery, technology absorption, upgrading all systems, processes, and never to forget the human resources, because this technology is still cutting edge. Not many countries have this kind of experience. So this is how we have been doing in this time span. And interestingly, there is a SIGRE work group A227 report. And if we try to see where are we compared to this report, which talks about field failures, wherein they talk about 22,000 transformers, power transformers, and they report a failure rate of 0.53% between 1996 to 2010. And this is a very interesting report. It says that the much talked about bathtub curve, which we also quite believe that after a certain age the transformers start to fail, but network transformers are not fully loaded. So this report does not give any indication of bathtub curve. And report clearly mentions that instead of time-based maintenance regimes, one can go for condition-based maintenance regimes, whereas there is no 1:1 data available for our Indian setup. So I try to do a very broad, near approximation, but that will not be far from the reality. So on that other slide, I was showing that we added around 500,000 MVA, and CEA reports publish 3 consecutive years the failure reports. So there are 89 failures reported on CEA website, and if we list them down, add up the MVAs, approximately we reach to 15,000 MVA. And if we work out percentage, it works out as 3.77%. And very interestingly, 50% of these failures are in the initial 7.5 years. And for a asset like power transformers, it's quite a painful data. So this is one aspect. So this is one aspect. And on the other side, what is happening in the backdrop and in the context of this discussion, that the government of India's thrust on competitiveness and competitive tariffs and availability of power is now is in the center of discussion. So if we scan the specifications, we see TBCB specifications where transmission is clearly mentioned as service, and policy of procurement of power from grid connected solar power projects. Here both of these documents talk about very, very clear penalties if availability is below certain percentage. So if it is, say, 95% or below, then there is a penalty. And clearly specifications are asking for this kind of expectation. We have heard our esteemed customer from Telangana, I could recollect that why not 180 months. So this kind of expectation is legitimate when such heavy investment is made into transmission equipments like transformers. So with 89 failures sitting on that list, and if you read those reports, these are consecutive reports of many years. They are not reports published in one single year. So if you read 2013 report, 15 report, 17 report, 19 report, they say because of lack of data, the RCA could not be completed, and therefore one could safely assume that there are no foolproof CAPA done for them.
Yeah.
Now,
Try
so I
to
will
speed up,
yeah.
please.
So now, in the meantime, while we were discussing this addition, there were many processes coming up. So, for example, if we see design reviews, very elaborate design reviews are happening. We publish all critical design reviews with customers. MQPs, very, very strong MQPs, FAT and field quality programs, and then system and protection. These are all very, very strongly upgraded. But then, why failure is happening? Onto this, my thought is that perhaps there are data islands, and I was very happy to see that CESE is maintaining some very good quality of data, but these are data islands, and feedback is not going to the whole system. So, if it's a simple problem where in some small fix could do, or if this is a systemic issue where we need to really look into the whole concept of designing, and thereby the concept of digital twin comes, which other industries are leveraging. There are sensors fitted, and over a lifetime they sense the data and relay it back to the centers, data centers which OEMs maintain, and therefore a different business model can emerge, wherein a regulator is having a role apart from OEM and customers, and data is live, and of course it is protected, and of course IP issues are there, and the information is not public for sure. So certain things have to be worked out, and in SIGRE in 2023 August announces a digital twin standard to be discussed. And my submission is that IMA and this August House should decide to have a digital twin standard for Indian conditions, Indian data as we see ourselves. So with this, I'm mindful that sir, my time is running up. So see, longer warranties are not the solution of a service guarantee. So product cost and service cost, they cannot be clubbed together, and then they cannot be bundled as warranty. So services should be identified separately based upon the data and the risks that the OEMs and field conditions put together have, and then service contracts should be separate, and standard warranties which are natural for such products, they should be maintained separately. So with this, I would like to conclude, sir.
Thank you. Thank you. Now I call upon Mr. Mudawat Basu to take up the paper on sustainable power transformer for reduced carbon footprint.
Good evening, and thank you, Ima, for giving me an opportunity to present this paper. My paper is on sustainable power transformer for reduced carbon footprint, so which fits into our theme of this Trafotech, and there are 17 sustainable developmental goals set by United Nations to protect the planet, and 12th goal is about sustainable consumption and production. So mostly I'll be talking about this trend in my next slides. And I'll be going through concept of life cycle assessment for power transformers, methodology for assessing environmental impacts at all stages and associated international standards, concept of product carbon footprint, minimum peak energy efficiency index, and for different size of transformers on the lines of European norms, optimize losses and measure raw material content in power transformers, and how it impacts carbon footprints. Some examples of OEMs, how to reduce carbon footprint during manufacturing process, and recommendation on sustainability measures for supply chains and suppliers. Life cycle assessment is a measure and aggregates the potential environmental impacts of a product, process or service across its life cycle under selected scope based on consistent and reliable data that should reflect the full range of industrial processing stages. And carbon footprint is a measure of total greenhouse gas emissions generated from a product from raw material to extraction to disposal. And there are different type of standards, especially ISO 14000 series. 14067 is particular standard which quantifies and which tells how to measure and report the carbon footprint of a particular product. And then there is an environmental product declaration, EN 15804. GPW 100 is a commonly used metric to quantify the greenhouse gas emissions over 1,000 years. GPW is a global warming potential. It is calculated for different kind of products like fossil, biogenic, land use, aircraft, and etc. So product life cycle is from processing raw material, manufacturing, packing, distribution, usage, and up to disposal. When we relate this product declaration to power transformer based on different life cycle stages, there are different type of life stages for power transformer, like raw material acquisition, like steel, insulating paper, insulating oil, copper. So at every stage there is an energy consumption, and this cycle is a material composition. And there is also assembly, what we do at transformer manufacturing stage, iron core, winding, tank, accessories, and we make together with some other accessories as a transformer. And during the process there is also energy consumption. After that there is a cycle of transportation to installation sites from OEMs, and there is also a fuel consumption during that stage. And then operating stage of transformer, which is about 35 years of lifespan, and there is also a major power loss during this stage, that is the losses we call them. And then end of a life of the product, that is a transformer. My right hand side is a raw material representation. It depends on transformer size, losses. So it is a rough estimation. One example I have taken from 220 kV 125 MVA transformer, where coal, copper, iron contribute a significant percentage, insulating oil and steel. So these materials can be quantified into percentages, and we can check them how much carbon emissions they produce each. So below that figure there is also chart that indicates different type of products, CO2 emissions in percentage, electrical steel, steel parts, copper parts, and all other parts. Here there are different process, different life cycles, like manufacturing, distribution and installation, maintenance, and end of life cycle. So here we in our organization we indicate this A1, A2 as a manufacturing, A1 to A3 as a manufacturing processes, and distribution and installation from A4 and A5. Maintenance is a basics, end of life C1 to C1, C2 and C4. So typical example I have taken, example is 125 MVA 220 by 33 kV 3-phase transformer, 50 years, and losses for 56 kilowatt no load loss and 330 kilowatt load loss. So if I put into a tool which we have, our organization is having, so it gives an overwhelming response during operating stage, that is a B6 category stage, that is life cycle stage of the transformer. There is a huge equivalent CO2 emission, that is about 8 into 10 power 6. It is a very huge CO2 emission in tons during 35 years of service of the transformer. A1, A2, A3, there is also CO2 emission, but that is very less compared to B6 stage. Then we need to have a trade-off between these two, like raw materials and losses. And here we suggest we should have some Indian standards which categorizes or mentions CO2 emissions for Indian industry. Then there is also a parameter like peak efficiency
please
index.
speed up.
There is a formula, empirical formula given here. I have calculated one transformer with 315 MVA, 400 kV with different type of losses, and PEI value is 99.44 percentage. And next, there is a European Union which issued an Eco-Design Directive 548 in 2014 with stricter norms in 2021. So my left hand chart gives that values for different type of MVA values, different type of PE values. And my right hand side is a chart which gives PE values for CEA standard losses. We have a CEA losses from CEA specification, and we have just analyzed that and put into that. So our CEA losses have higher PE values than Eco-Design Directive of European norms. So there is a scope for reduction and reduction in losses, that is optimization between losses and material. Then we have some suggestions, and we in our organization, that is Siemens, we do some CO2 emission reductions. We have already started monitoring and mentioning these things. Like we use solar energy in our processes instead of conventional energy. We replacement of split AC into chiller system, consistent effort to avoid plastic usage. We use oil reclamation resulted in CO2 reduction, alternative fuels in drying oven instead of diesel, reused of packaged material, and digitization of engineering documents. And then we also recommend some suppliers or supply chain what needs to be done. They need to use renewable energy wherever possible in their operation. Can be used paperless or digital manufacturing process, usage of recycled packing material, usage of green transportation for processed raw materials wherever possible. And being an Indian industry, I have studied with some countries. They have CO2 emission factors for core, copper, insulation paper, oil, like they have established, and this factor depends on per capita energy consumption of particular country. So I am not reporting that, but depending on our Indian per capita power consumption, we should establish such carbon emission factors, so we can still make optimization during design reviews. So that's it. Thank you.
Thank you, Basu, for the insightful presentation on carbon footprint and product environmental declarations. Next paper is about AML experience of 125 MVA green transformer using synthetic ester in a transmission substation.
Good evening to one and all. First of all, I would like to thank IMA to give me this opportunity to present in this forum. And I would be presenting on the paper MS AML experience on 220 by 33 kV 125 MVA green transformer using synthetic ester oil in the transmission substation. So I would like to say that this is a joint paper between Adani Electricity Mumbai Limited and Siemens Energy. First of all, I would like to take you all through the AEML transmission overview. We at AEML are a transmission licensee and we are operating in the region of MMR. So we have a network of substations which are 8 in numbers. Out of these 8 substations, 3 substations are completely AIS substations and 5 substations are GIS substations. We have a transformation capacity of 3250 MVA. Also, the peak demand of the Mumbai region that was recorded this year is 4108 megawatt. With this, I can say that we are catering to around 70% of the demand of the AEML distribution consumers. Also, to interconnect all these substations, we have a network of transmission lines as well as underground cables to connect all these 8 substations. So now let us see the load growth scenario in Mumbai. As we all know that Mumbai is a densely populated city and it is undergoing rapid infrastructure development and also witnessing a continuous rise in the power demands. So this power to the city's infrastructure is being fed from the substations, and hence it is necessary for this transformation capacity to undergo the augmentation. So considering the need for the electricity demand for this vertically growing infrastructure projects like metros, data centers, etc., AEML has adopted a twofold approach. The first one being that we are augmenting the existing substation capacity, and the second one that we are commissioning new substations in the load growth areas. So in response to the escalating power demands of the Mumbai, AEML found it imperative to augment the existing transformation capacity. Green transformer at AEML. Now, as we all know that AEML substations are located in the heart of the city and near the load centers, they pose a great risk to the surrounding life in case of property in case of contingencies. So AEML is also Environment Management System certified organization, and there is a growing interest and need for the environment friendly dielectric fluids as a viable alternative to the mineral oils. So esters are an alternative to the conventional mineral oil, posing a greater advantage in fire protection. AEML conducted a comprehensive analysis of various technical parameters of the alternative oils and recognized the manifold advantages of the synthetic ester oil. AEML has embraced synthetic ester oil for one of its substations in the Mumbai region. So AEML decided to go for a green transformer. Along with the synthetic ester oil, we have also adopted resin impregnated paper bushings and vacuum type OLTC for this transformer. Now let us see the classification of fluids. Now the IEC 61039 has classified the fluids. So this is synthetic ester oil is a K-class fluid, and it is having a fire point greater than 300 degrees Celsius, and also it has a calorific value lesser than 32 megajoules per kg. Also it is a biodegradable type of oil. Now let us see the engineering considerations at AEML. So as I said, we have adopted the resin impregnated paper bushings. These bushings are significantly reducing the risk of fires as they are not oil filled, they are light in weight, compact and non-brittle material. They are also environment friendly as there is no oil leakage. Secondly, we have adopted the vacuum type OLTC. So conventional OLTCs may result in the mixing of the oil in case of contingencies. So vacuum OLTC has also increased the maintenance up to 3 lakh switching operations and the contact life up to 6 lakh switching operations. We have also adopted a color coding for this kind of a transformer for easy identification. We have given a green color as we can see from the photograph. Environmental protection, we have gone for a low noise type of a transformer, that is 68 dB, which is 15 dB lesser than the NEMA standard. Also we have adopted the marshalling box, which is IP56 rated and also has a SS grade material. Other features that adopted are careful oil handling and oil-filled transportation of this transformer. Now let us see the design and manufacturing efforts by the transformer OEM. This transformer is built in a very compact design of 11 by 8. Mechanical design challenges of 220 kV ester-filled HV cable box were there, and a small size 33 kV air-filled box were there for the LV side. In factory, dedicated equipments were used for the oil handling for ensuring that there was no mixing of this oil along with the conventional oil. Repeated filtration cycles were carried out with the filtration machine as well as the lines to ensure that there are no traces of the mineral oil and that are remaining, and there is neither in the machine nor in the line. Also, no low noise emissions was specified. Entire manufacturing was also done in the COVID-19 pandemic lockdown period in the OEM factory in Mumbai. Some of the other design features that we have gone for and have led to the space saving at AEML are as follows. HV side cable connections with oil-filled cable box, LV side air-filled cable box, vector group of the transformer as YNZN11, which has zigzag on the secondary, and this eliminates a neutral grounding transformer which consumes a lot of space. So the NGR was used, which is a tank mounted type of a NGR. Now let us see the conclusion and the forward path. This green transformer erection and commissioning was completed within a record time of 15 days with strict adherence to standard operating procedures and safety protocols, like I mentioned during the COVID-19 pandemic period. Pioneering endeavor enhances the reliability and resilience of Mumbai's power infrastructure and paves the way for a greener and more sustainable future in the realm of transmission systems. This will help to serve quality as well as quality power supply to the Mumbai consumers. As the world develops strategies for sustainable recovery from the pandemic, we all should seize the opportunity to work together to improve efficiency, reduce the waste and pollution, and shape a new circular economy. Substations are commissioned in residential and commercial surroundings, and it is paramount important to see that these operations of the substation happen without any risk to the environment and human safety. With this, I would like to say that AEML is the first utility in India to commission the synthetic ester oil-filled transformer at 220 kV voltage level. Thank you so much.
Thank you, Manali, for a good presentation about your experiences about synthetic ester application for a 125 MVA transformer in Mumbai. And now I call upon now the next paper about offshore wind application. This is another very interesting paper which we can look forward in the 2030.
So, good afternoon, everyone. Firstly, I would like to thank EMA, the technical committee, and Hitachi Energy to give me an opportunity to be present at this event. So, my topic is offshore wind application transformers. So, going to the introduction, as we all know that there has been a significant increase in the renewable energy resources and generation from these resources in the last decade. More and more wind power generating plants are also commissioned. So these wind power plants are of two types, onshore wind and offshore wind. So today we are focusing on the offshore wind application transformer, where the wind farms are located at the center of the sea or far away from the shore. So the wind speed offshore is higher as compared to that on onshore, resulting in more generation of electricity. In conventional onshore substation, the size and weight of the transformer are not major consideration since they are located on the land, but are primary factors affecting offshore substation cost. As of 2022, the worldwide offshore wind power capacity is 64.3 gigawatt, with China accounting to 49% of the generating capacity and UK to 22% and Germany to 13%. India has identified offshore wind energy potential of 70 gigawatt in parts along the coast of Gujarat and Tamil Nadu. MNRE and National Institute of Wind Energy are doing feasibility studies for offshore wind generation in India. The power transformer is basically the heaviest equipment at the offshore wind substation. Its mass, footprint, and location within the platform directly affect the platform mass and dimensions. It has been estimated that a reduction of 1 ton in equipment mass can further reduce approximately 3 tons of the total weight of the platform. Consequently, the goal for transformer designer is to design a transformer as compact and as light as possible. The transformer is usually located on the top floor or top deck of the offshore platform, as this facilitates its installation, maintenance, and suits a possible contingency where the transformer must be removed or replaced. So now let us discuss about the challenges that we face.
Hello, slides are not moving, if you can show. Okay, sorry.
Yeah, thank you. The main challenges for offshore transformer designs are, first, it is surrounded by sea, so no place to escape in case of any incident. Second, the materials are transported by supply boat or personnel are transported by choppers, which makes the logistic difficult. The real estate is costly, that is, the hull cost is very high, hence small footprint of the transformer is required to reduce the size of the platform. Due to the constant salty sea spray, constant humidity, and hot sun, the painting shall be provided for highly corrosive atmosphere. Also on offshore, there are constant hurricanes, typhoons with high wind speed. So external components like conservator, terminal connections, coolers, etc. shall be suitably designed. The transformer shall be designed for marine motions like pitch and roll, with its value specified for both transportation as well as operation, including lateral and vertical accelerations. Now let us discuss about the key parameters of the electrical design for offshore transformers. The wind turbine generates at a voltage level between 690 volts to 3.5 kilowatt voltage. This voltage is transformed to the collector voltage of 36 kV to 66 kV voltage via 2-winding or 3-winding transformer. At the offshore substation, the collector circuit voltage must be then stepped up to the voltage of 132 kV or 245 kV or 400 kV for further transmission to the onshore. These transformers are the largest and most critical components on the offshore platform. The transformer needs to be compact due to the costly real estate, as we discussed in the previous slide. This compact nature of offshore platform means the transformer failure or fire could damage the adjacent equipments. Nevertheless, the risk is negligible, but it could cause a major threat. As a result, the offshore transformer must need to be lighter, compact, reliable, low maintenance to reduce the overall platform cost. So the main parameters that we consider are use of ester fluids to minimize environmental risk. Transformer must be designed to minimize the risk of fire in case of any explosion. The transformer should be optimally designed to reduce the footprint, since we need compact size, weight and capitalization rates are based on the losses as well as the size of the platform and size of the transformer and weights. Transformer should be designed to be low maintenance to reduce costly interventions. Further, a designer shall try and utilize up to maximum limits where possible for flux density and current density, which shall of course be agreed with the customer. So talking about compact design, the main thing to consider in offshore transformer is the compact design. For offshore transformer, usually the capitalization costs are for losses and like I said, for the dimensions as well as the weights. For compact design, high temperature insulation materials can be adapted in winding at the location of the hotspot. This can be effective solution for extended life of insulation system and also effective for any overloading conditions of the transformer. According to IC 60076 part 14, there are four types of insulations given, that are hybrid insulation, semi-hybrid insulation, mixed hybrid insulation, full hybrid insulation system and high temperature insulation system. By adapting this insulation system, the maximum continuous temperature rise limits for the transformers can be increased as compared to the conventional insulation system. The limits are mentioned in 60076 part 14. Another major challenge for an offshore substation transformer is the cooling system. So the type of cooling shall be strategically and optimally designed to get the optimal results. Next is the major consideration for considering the alternative fluids. The alternative fluids that are ester oils are readily or completely biodegradable, which gives them major advantage in the offshore applications. The available ester oils are synthetic and natural esters. The main advantage is that there is no toxic residue that could harm environment in case of spillage. Also, they are readily or completely biodegradable. The maximum continuous temperature rise limits are higher for transformers with higher temperature insulation systems for ester oils. The next key parameters to consider in mechanical design are the acceleration and vibration considerations. So the forces that we face in offshore platform are forces related to land transportation, forces related to transport for fully assembled transformer to offshore platform, forces for lifting platform from barge and placing the transformer on the foundation at the sea, vibration resulting from earthquake, wind gust, waves when installed on the offshore platform, vibrations occurring from electrical equipment transferred through the construction components. Some customers specify the values of acceleration during tender stages. In case we do not receive such acceleration values, it is better to consider the maximum limits that we can with discussion, along with discussing with the customer. So painting and accessories is another important parameter to consider in offshore application. So as one of our friends presented paper on painting yesterday, it's better to consider high corrosive paints for transformer as well as the stainless steel hardware along with all the accessories should be accordingly considered. So coming to the conclusion, we can say that the optimal design must be developed not only based on standard transformer solutions with capitalized loss evaluation, but also considering the transformer weight and footprint with a goal to minimize the total cost of the entire offshore substation, that is transformer as well as the offshore platform. The reduction of weight and footprint on offshore transformer results in high cost of losses, which is often overly compensated by the cost reduction of the offshore platform, which is also resulting smaller and a lighter platform. Therefore, the use of compact transformer can be very useful solution to achieve optimal offshore substation cost. I thank you for.
Thank you, Mrinal. Wonderful paper. Thank you. And as I said in the second paper, we first showed the experiences gained on installing an on-land transformer, Easter transformer. Now, as I said, in the future we will have more challenges. Now we will have to do a Easter transformer mounted on a platform. So it will be having additional more challenges. So we need to graduate ourselves from one level to another. So that is the expectation which is going to come up in 2030. So now let me call upon the paper on 500 MVA 763 kV Tapless auto transformer. Mr. Sunil.
Good evening, everybody. I firstly thank IMA and Trafotech for accepting this paper for the presentation, and also I thank my management for approving this paper. Now this paper is about 500 MVA 765 kV tapless auto transformer. Now why this tapless auto transformer is required? Actually in 765 kV system, 1500 MVA 765 kV three-phase system forms the bank, in which 500 MVA 765 by 400 by 33 kV ICT, single phase ICT is required. And it has been seen from many utilities data available that tap changer have been seldom used in over the almost lifetime. So Power Grid has come up with the specification in order to remove this tap changer, and actually we require in this industry reliable, robust and but simple and smart and yet economical transformer. So removing the tap changer makes it a lot of simple, and as per the reports available, this contribution of transformers failures, majorly it is through winding and bushing. After that 16% is contributed by the presence of tap changers. So specification was such that tap changers have been removed, and this will be used in power evacuation in receiving end through non-conventional sources at NCR and western region in systematic order for Narela, Navsari, Bhadla and other substations, Khavda substation of Power Grid. And BHL is the first company to have supplied this type of transformer in India, and we have supplied 15 transformers. 10 already are at Narela under erection and commissioning, and another 5 for Navsari are have been manufactured. 6th one is on test bed. Now the specification of this transformer. It is 500 MVA by 500 by 5 MVA, that is thermal loading of LV, and it is 765 by 400 by 33 with percentage impedance 14% between HV-IV. HV-LV is 195%, IV-LV is 180%. Lightning impulse voltages 1950, 1300, 250 for HV, IV and LV, and switching 1550 and 1050. And cooling is 2 into 50% radiator bank with 45-50 rises. and the specific requirement is the CA losses are guaranteed in this design, that is 80 kilowatt for no load loss and 450 kilowatt with 335 kilowatt for I square R losses and 10 for auxiliary losses. Now this higher impedance of this design makes life of any designer a bit difficult, because had this been 45, 60 or 35, 50, 40 percentage, life would have been simpler for any designer. Place 3 windings from core, LV, HV and common winding, and it is done. But in this case, to achieve this higher impedance, we have placed the 3 windings, that is tertiary, common and series, in the main limb, and the side limb is also there, which is having LV winding and 1 compensating winding in order to distribute the flux in both the limbs equally. And now the 3 major challenges of this design are dielectric design philosophy, placement of special shunts, short circuit withstandability. Actually, due to higher impedance, it gives rise to lot of stray losses, and this placement of shunts and the design of shunts plays a major role, which is done by latest FEM tools available. And the gaps of the between winding gaps have been studied, and winding to winding gaps and winding to tank and core to first winding gaps have also been studied with some minimum factor of safety, which is achieved in our 2D electrostatic analysis. Now short circuit, with regard to short circuit withstandability, BHL is having a rich experience of short circuiting more than 40 power transformers at CPRI, NHPTL and KEMA. Latest being 330 MVA 765 kV GT for North Chennai project. So we have experience, all this experience have been combined in designing the short circuit withstandability of this transformer. And various combinations have been tried, like feeding the fault in 3-phase, single phase from HV, IV and HV and IV both, and rigorous design review was done by Power Grid for this, and we could get through, and it was all in line with IC 76 part 5 table A.1. This is the analysis of plots done for LISI power frequency. Now such high rating transformer requires high dielectric requirement, complex CG and higher magnetic stresses, which have been achieved by clean environment, humidity control and appropriate material choosing and stringent process controls. With regard to design validation, as I already told, we have tested 15 transformers, and the design has been validated, and in right side we have given the tested values, and we could achieve all the impedance and losses as per specification and rises. Now the advantages achieved due to absence of tap winding in OLTC. It is known to all that there are advantages, but we have tried to calculate the advantages based on the weights and other data available with us vis-a-vis the similar rating transformer, because we have orders of many transformers of this rating from Power Grid, and 70% are tapless and 30 are with tap changer. So we have compared that there is saving of 14% in core, 11% in copper, 100% in TG cable, because you have done away with tapping winding, steel 10%, transport mass 14%, oil 11%, and footprint of tank, base tank 15%. So this sum up into reduction in national waste and lesser carbon footprint of for manufacturing this type of ICT. And next is the less maintenance cost due to absence of OLTC and simpler TG, which we can see in this photograph, came from our PROE that cumbersome TG can be avoided. And with that conclusion, it is for this reliable manufacturing of 765 kV transformer, a well-proven, robust yet simple design is required, and material from sub-suppliers with right quality, modern equipment and well-educated designers and shop operators is required. And there are many examples globally for tapless transformers in hydro power stations. Thank you.
Thank you, Sunil. Now, the last paper on synthetic ester, synthetic organic ester to improve sustain. Mr. Budi.
Yeah, sorry to interrupt. Actually, we are facing some issue. There is a laptop bag which is being kept into the kit bag is missing. It is of Mr. Kalyan Tata, he is from Hitachi Energy. So he was sitting into the second column and on the 6th row, seat number 16. So anyone who is near to him, and we request if anyone can check it on their kit bags, if anyone can found it, please let him know. It will be great. Thank you. Over to you. Thank you.
Thank you.
Good evening. Thank you very much for the IEMA and Trafotech for the opportunity accepting the paper and also to be present here. And today I have to demonstrate how synthetic organic ester to improve sustainability. So there are many challenges on the future grids, like an increase urbanizations, which is impact on the densely populated remote communities. Climate change will also impact to the extreme weather, integrating renewables and also battery energy storage, which is all this thing. It is available in the sustainable development goal. So how do you manage the risk for existing or the new substations, considering about people, environment, and also with the business? And here, the hierarchy safety of control, it is widely accepted methodology for eliminating or minimizing hazard in the workplace. And we can see here, the hierarchy of control is step by steps to eliminating or reducing risk from hazard elimination as the most effective and down to PPE as least effective. So the inherent risk of mineral oil field transformers, it is required additional control such as firewall or blaze wall, fire delay system, and also increase separation distance to other assets and also larger band design in order to account the full pool fires. And then this influencing cost of the installation project. So in the case of the fire delay system, this will also required administrative control, including the predictive maintenance testing, to ensure that operated on demand, and which further add to the total cost of the ownerships. So these are of increased consequences if this engineering control are allowed not to perform. Okay, here about behavior, fire behavior on the liquid. As we know that the fire property is classified by flash and also by the fire point. And the liquid also subclassified according to the low heat value or the net calorific value, which is a higher number indicating less energy available for combustion to sustain a fire. So how does this relate to the fire scenarios? In a typical transformers operate at roughly 100 degrees C, so much greater temperature change is required for K-class ester liquid to reach their fire point. Yeah, if assuming there is no heat loss on the transformers, so the table here, it is demonstrate the amount of energy required to reach this dangerous state is roughly 3.5 times higher in esters. So we have an experiment in the real transformers demonstrate the fire resistance. This is 630 kVA with 365 kg of synthetic ester liquid. And then we have a measures 12 temperatures thermocouple in the 12 positions and recorded automatically. And then we have also the fire load provided by 180 kg pre-dried wooden grips, and then put surrounding the transformers underneath the radiator fins. And then let the transformers, the wooden it is burnt for 70 minutes. And the transformers internal temperature peak at 180 degrees C and the bottom, and 204 degrees C and the top of the transformers. And then this value, mean the temperature value, still well below the ester flash point. So during the fire itself, that there is gas escaping from the pressure relief device, it is also cannot be ignited, and synthetic ester it didn't contribute anything on the fire. And the transformer here, when it is finished the test and then bringing to the factory, and then it is still find that have a good electrically working condition. So here about the substation design impact, using mineral oil in transformers usually make it mandatory to use either extended separation, firewall, fire suppression systems for adjacent building and something like that. And these mitigation measures to add project capital costs, yeah, as I mentioned before, also increase operating and also with the maintenance costs to ensure that they remain functional on demand throughout the lifetime of the transformers and also with the substation. So larger separation distance also required extra cable length, longer cable trains, marshalling box, and anything. Yeah. If we see here the example from the FM Global data sheet or IC 61936-1, the area will reduce by up to 90%. So without the additional concrete required for the firewall and also with the containment, shortened cable runs and potential removal of flash absorption system, switching to ester-filled transformers can make a significant impact to the total cost ownership of the substation. Yeah, we know that the price of the ester-filled transformer it is expensive, but we need to see the holistic view. Yeah, the holistic view will remove or we can reduce the capital cost elimination of the fire suppression system, reduce civil infrastructure, shortened cabelan, and also we can also not needing to maintain the fire suppression equipment. So in total cost ownership with the transformers, we can see a lot of saving on that. And the next one, environmental legislation now is becoming tighter, and adoption of ester has been extended to their environmental benefit. So synthetic organic ester, it is readily biodegradable and also non-toxic, so will be viewed as less harmful. Yeah, and regardless this biodegradable, yeah, not only for the new liquid, but also some tests, we do some tests for the transformer still operation, that the cold climate is still showing that it is still in the high biodegradable. And regardless the containment regulations, we can also make a simplified containment with this liquid. So synthetic esters not only just innovations on the transformer on the grid, but also extensive to the offshore oil and gas, wind farm, and also can be putting solar. But it is very good because it is very rare that maintenance engineer will take a look at the transformers that using synthetic esters will have a high oxygen stability, will give a better option on that. And synthetic ester also support the economic and sustainability. Simplified design, yeah, reduce clearance, it is also means that less materials, and avoid capital and maintenance costs for extra equipment. Ester also have a longer solid insertion life, yeah, and we can also make overload the transformer without decreasing the transformer lifetime. It is proven not only just distribution but also for transmission. Synthetic esters, due to excellent oxidation stability, enables for recycling and support the circular economy. So synthetic ester also can be regenerated and also to be reclaimed. Sustainability, it doesn't mean it is will be expensive. Yeah, EPC, total cost ownership, we can, total cost or holistic view, and we can have a reduced total cost ownership. And this is example that synthetic organic ester for extra high voltage transformers, yeah, 220 kV and also 400 kV in national grids. It is still a focus on that, and up to now, it is continued to become a standard in another substation. And now these conclusions, switching to ester synthetic ester-filled transformers, even this is new or retrofit transformer, will enable substation innovations. Yeah, it is proven liquid, since that it is increase the fire safety, and so far that transformer with synthetic ester, it is 100% fire safety records, and also the biodegradability and non-toxic, it is also protects the environment, not only just protect the environment, but also can make a simplified design of the containment. And although that the price of ester's field transformer is more expensive, if it is we can see the holistic view, then we can reduce the project cost and also total cost ownership, and not only for the new transformers, but also can be done for the retrofitting. So far that we have experience total retrofitting for 132 kV. And ester transformer fleets are proven in thousands in applications with a zero compromise with approach, like a necessary. I mean that put in the building. And
can you speed up?
Yeah. Yes. And the last thing, since prevention is better than cure, the continuous adoption of ester transformer liquids in substation design will provide substation operation with entire life cycle benefit. Thank you very much.
Thank you. A very good paper. Just to sum it up, we had the first paper starting with business model transition, the analysis of the various CEA data, and then we continued with the journey on how the environmental product description or a declaration from the manufacturer. Today, EPDs are not required for the transformers, but those regulations will come or will be applicable if you are exporting those transformers outside the country. So as we discussed in the first day, how to export, then this type of things also we need to take as a transformer manufacturer, so that our products are able to meet the global market. And the third paper about the Easter experience of 220 kV is the first Easter experiences in the city, a congested city like Mumbai, and their learnings, how it can be applied, how it can be multiplied further. That we need to look at that. So again, that will be again looking at the future. And the next paper about the offshore paper was also because majority of the, as I understand, the potential for power generation in an offshore is much higher than onshore. Therefore, there will be good potential for offshore installation, and therefore, whatever we discussed today is going to be coming up in the future, and there are also already some offshore platform tenders are, I think, already released according to my knowledge. So that is going to be coming up in the future. And the next paper about the 765 kV 500 MVA Tapless transformer, because in the past we have seen a lot of challenges making with the tap changer, and as per the CEA guideline, we have already the purchaser can choose either with the tap, without tap, with or without tap changer. So the development by BHEL about transformer without the tap has been discussed. And finally about the synthetic ester, the benefit is known to all of us, but it highlights one point which also correlates with the offshore platform. If you look at the paper, in that paper it says elimination of firewall or the blast wall, and because it is an offshore platform, you may not be able to construct any firewall or anything. And if you correlate both, you can see why synthetic ester was specified in offshore platform. So if you correlate the Buddhist paper with the Mulang paper, we can correlate both the things. And with that, I would like to conclude, and the session is open for additional questions.
First question to Govind. Govind, you talk about the failure rate of the transformers on the basis of the MVA installed. Is it logical What I feel is, it should be numbers. Number of transformer failed is to be considered, not on the basis of the MVA installed. It will give you a construed figures. I don't think it's right thing to do. Moreover, do we have any statistics about the failure rate of the 66 kV, 132 kV, 220 kV, 400 and 765 kV transformers? That will give us, what we need to do to improve or to reduce the failure rate of those rating of transformers. That's one point. This was my observation. It's not a question. Another thing was about the losses. You talk about the losses, CA losses versus European losses. Should not we consider the loading? The loading in India for all the power transformers, whatever you consider, is average loading is not more than 60%. And when the average loading is 60%, load losses to reduce below what, I think the load losses specified by CA is again very low. When the loading is only 60%, why should we bother about those kind of losses? And if you see in America or in Europe, the loading is almost 100%. They never do with 60%, 50%, 60%. Another thing about, it was again, once you must be doing that for the offshore transformers. See, the load will be when the wind velocity will be there. So automatically, you must be considering the design of the cooling based on the velocity of the wind during the load cycle. That reduces the footprint of the transformer, because the footprint is because of the radiators than because of the transformer. So these are the main observations which I had. Yeah?
Okay. Yeah, next question.
My question is to Mr. Pandit. I want to know that these offshore transformer, what are the ambient temperature considered for designing, and oil and winding rise for typical oil and winding rise, and whether these transformer are indoor or outdoor or semi between these two? Thank you.
So thank you for your question, sir. So firstly, talking about the ambient temperatures, so when an offshore platform is, the location is decided, the substation designer or substation contractor will identify the location and the temperatures at that location. So once agreed with customer, we can reduce the ambient temperature as compared to the IEC limits. So accordingly, with the usage of high temperature insulation materials and ester oils, we can also increase the temperature rise limits based on table 3 of IC 76 part 14. So that we can do.
There are different temperature rise limits for different type of insulation. That's what he is referring.
It can be indoor, but looking at the size of the platform and the transformers, we are talking about the collector transformers that are around more than 100 MVA or around 100 MVA. So we prefer it on the first floor of the platform, not on the top floor, but on the top floor itself, not on the bottom floor. So it does not come in direct contact with the sea water. And it's of course, it depends on the offshore platform designer if they want to keep it indoor or outdoor. It can be both.
Sir,
Yeah.
Jason sir, let me answer my question.
Yeah.
Sir, to your question, sir.
Yeah.
Yeah,
Tom Taram.
Yeah, actually I'm in the view of increasing the CA losses little bit higher. PEI efficiency, which I calculated, for example, which I stated in my paper, it is higher. In the sense, we have to increase the losses and make efficiency lower, then our losses will increase. Yeah, that is what my suggestion is. Yeah, and we can optimize the material. That's it. That's my part. Yeah, yeah.
We charge for 24 hours. So there shouldn't be any problem with that. Another question which I wanted to give to Sunil. or to the entire design team here in the forum, that why, when the impedances are so high for the windings between the tertiary and the HV and the LV, why can't we think of going for an external reactor? I think Crompton did it in the past. That's what I remember, somebody told me that. And it's a good solution which will reduce the losses, which will reduce the cost of the transformer as well. So, this should be the suggestion which can we give to the utilities, especially the power grid who buys maximum number of 765 kV transformers.
Sir, currently the EM, including the CEA specification, does not allow series reactor because we have, I think most of the leading factories, designers are fully aware of the benefit of the series reactor, and it is a very proven concept that has been supplied even from Indian transformer factories.
Yeah, that's what I'm saying. Yeah.
But the thing is, it is because of the fear in the minds of the people who are buying the transformer. It is not the fear of the transformer manufacturer.
No, that's what I'm saying. It is our duty to convince them that that there is no point. We can give the extra warranty if required.
Yeah.
That's the national benefit, and then we can convince. If we can see, there are Power Grid is a very powerful organization, and there are very intelligent and learned engineers there. They can always give the clearance for doing that, and once they do it, CA has no right to reject that.
Yeah. Your idea is well taken, sir.
Yeah, maybe Jason sir, to answer to Mamtura sir. So sir, you're right. Like SIGRE, we don't have number of transformers which were surveyed and incidence of failures. So that is what the difficulty is. But if we talk of these 5 years or 6 years, so the number of failures is available, and it is say 89 or 90, and 25% of them are rupture of tank. So that is what they mention, and 50% of the failures happen in first 7 years or so. And I mean, this is what the data was available. So I was trying to work out from MBA versus this. So this was my thought. But nonetheless, what is happening, sir? Maybe these are very simple reasons. Sometimes storage, we do not know. Maybe sometimes prolonged storage is causing it because they cannot be fundamentally so much wrong things. So if we have data, we can perhaps fix very easily low-hanging fruits. And if there are certain things which also could be there, because 800 kV, such a large system doesn't exist perhaps in entire world. So what is happening is maybe having a technical dimension. So we bring in both the sides when data is available, and then we fit into what digital twin and for example fleet management or automotive industry is doing. So like that we can quantify risk.
Yeah. Right. Thank you, Govind.
Sir, may I?
Yeah.
Thank you. Good evening. I am A.S. Jala from T&R. My question is to Ms. Swankar. Madam, would you like to share us the thought process, adopted behind the selection of the type of the fluid, I mean synthetic over natural? Thank you.
Hello. First of all, I would like to stress upon the point that considering today's environment of transformers being located in a very densely populated region, like I mentioned, specifically for AEML, wherein we are located in a very close environment to maybe residential quarters or places where there are high footfall, there is a basic need for going for an alternative kind of fluid. That is a basic understanding that is there with everyone. Further to that, I would like to add that there was a comprehensive analysis done for the alternative oils at AEML, wherein the entire technical team of AEML was involved, and we found that as a pilot project, going for a synthetic ester oil, considering the benefits, will be a good option to start with. And that was the reason to select the alternative oil and to commission the TR3 Borivali in Mumbai. Does that answer your question?
My question was little different. I wanted to, understand your thought process is, adopted behind selection of type of fluid, synthetic versus natural. You adopted synthetic. Generally in India, the trend is more of, going to the natural ester fluids because of, the price, of course. So why synthetic ester fluid was selected over natural ester fluid? That was, if possible to share, please.
Yes. Like I mentioned, it was a conscious call considering all the benefits of the alternative oils and a comparative statement that was done between the alternative oils as well. So it was a conscious management call taken. So that is the reason.
Yeah, new questions?
Yeah, myself Ravish Kumar from CSPCL. My question is from for Manali. We have you have shared your experience of commissioning transformer, ester oil transformer. I want to know, is there any particular difficulty or any special safety precaution which have to taken for erection commissioning of ester oil? Is there any difficulty faced by your team, if any?
You are specifying about the erection testing commissioning activity?
Yeah. Yes. Practical experience.
Yes. So I would like to say that considering the alternative oil, which is a synthetic ester oil, first of all, we have to be very careful with non-mixing of the oils, that is the conventional oil. So basically, I want to stress upon the fact that the filtration machines that are used on site are generally used priorly for the mineral oil filtration. So utmost care has to be taken that this kind of mixing with respect to this filtration machine is not occurring on site. So we have taken utmost precautions to have very much taken care that this mixing is not happening on site, and that was the prime most thing that is done.
Okay.
Yeah, next post. Yeah, backside.
So, Namaskar, I am Balan from CEA, and very good lectures we got today. So, I would like to ask 3 queries. First one is Tapless transformers, 70 kV by 400 kV. Normally in grid, we keep the high voltage lines night time off due to high voltage. So if Tapless transformers are there, how they will respond to the voltage test in the system? Whether your reactors, sun compensation or whatever compensation, it is mostly fixed only you are having. So how to protect our transformers in the absence of taps?
This protection scheme will be same as we are having in with tap changer, but still the internal faults can be avoided by using not using the tap changers or tapping winding. Otherwise, protection scheme and everything will be same as which we are having as of now.
No, I am talking about voltage test continuously applied on your bushings. So how do you protect your transformer when you don't change your taps or whatever it is now?
No, still today also we are not changing our taps, so it is at rated voltage, at least it is there. So rated voltage it is able to sustain, or higher voltage if we have 5% or 10%.
Okay. Then, okay sir, then next question is regarding this loss, you are talking about loss, CA loss you are saying. Here I am finding you don't specify the core type of core which you employ. Whether it's CRGO also we go many grades of core we are having, M5, M4, so many are there, and high B. Mostly NTPC, PGCL, they use the high B core material which is having more flux density, around 1.9 Tesla I was told. So which type of core we are using, then only easily can compare also. The others can specify, can clarify which type of core you are using in your transformers.
I would like to take the question because the losses in CEA, even no load losses are very low. So if you want to design high rating transformers and reactors, we have to use definitely a high grade course, then only we will achieve the losses. We have designed a few transformers and reactors, and we are telling out of experience.
Okay, thank you. Then regarding offshore wind transformers, you were specifying ambient, you were saying that this high-speed wind can be used for the cooling up the, what type of transformer is specified, whether ONAN type, I think oil is not there, whether you will be specifying the normal ONAN type or offshore wind type of cooling? But ambient is maybe very cool only because of seawater.
Actually, we can utilize ONN, ONF or water cooled. It depends on the design. It should be evaluated which solution we get an optimal result, and depending also on the rating and the losses, we can decide which type of cooling to adapt. In general practice, ONN and ONF are popular used cooling methods.
Okay, and one more query related to that only. Some of the others were saying that high frequency transformers will occupy less space now. This philosophy can be thought of for offshore wind platforms?
We are yet to explore that topic, but it's a nice feedback. I can take it as a feedback, and research topic could.
Aeroplane they are using, I was told the aeroplane they are using the 400 hertz. So one more thing, this regarding this series reactor, somebody was saying Siemens, I think, series reactor to increase the impedance between transformers. This also I think is a very good suggestion. Because now we increase the sources in the system, so fault current is going up and short circuit level also going up. It will now come to 70 kiloampere or 60 kiloampere. So this series reactor will definitely help the system also. The breaker cost will be reduced. Breaker cost, all system cost. You don't want to upgrade your breakers also. Yes. Yeah. So this is a very good suggestion, sir. We will try to also learn. We'll also study more about this one. We'll also try to implement also.
There was a paper, technical paper, which was presented in the, I think, Trafotech by Govind in 2009 or 10. If you remember, it was presented by Govind. Yes, so you can also refer that paper of very old 2009-10.
Yes, sir.
On this topic itself. There are many papers, but that is one which I came into my mind.
We supplied one auto transformer wherein we used series reactors. And I think to this date it has been working satisfactorily, and it was very it was a very compact design in that sense. To achieve the same impedance, it would have perhaps needed much bigger active part. So this was good, but as Mr. Jasaran was telling, there is certain kind of apprehension about putting that element inside transformer. But electrically, there is no difference having a tap winding, wherein at the junction you can have oscillations, versus a series reactor connected to tertiary, which can also have similar oscillations. Only thing, we should know what are the magnitude of those oscillations, and precautions should be taken.
Right. In Chennai, I have seen the 110 kV series reactor. I have seen, bus reactor, series bus reactor, to split the fault current. I have seen also they are having. And one last query. Regarding this fire safety, because earlier I was an electrical inspector, so I have seen number of transformers throughout the western region, southern region. So earlier there was TSC, Tariff Participation Committee was there. They used to specify the guidelines for fire safety of transformers. And IS is there, 164cc is there, IS 3034 is there, many IS is there, NEC, NPC, all are there. So in USA, we are NAPA is there. Normally, what we learned there, that fire safety measures are specified by the insurance companies now. In India, what is the status? Whether the fire safety is you follow any CE regulations or IS or any code, or insurance companies, they specify the further norms for fire safety. This I want to clarify.
This is mostly related to substation queries.
Yes.
Customers also can answer this query. According to me, there are IS is there, IEC is also there on blast wall, how to select that. Substation design IECs are there. and we follow that only. Because whenever a substation designer designs a complete thing, yard, at that time he considers the blast fall based on the IEC or IS. According to me, those standards have not undergone massive changes or not undergone recent times revisions. This much I know. They are very old.
Still do you follow the tariff advisory guidelines? It is there in the website is changed now. I could not locate tariff advisory guidelines. They used to have TSC committee. Tariff advisory committee was there. They used to specify fire safety norms for all transformers. And still it is there. Acha. 20, I know. I was also committee member. I know it. No, that's CA regulation. I know.
Yeah.
I'm a CA only. I know it there. I'm asking TSC guidelines are there. You're following or not? I am asking.
Okay. Yeah.
Okay.
Thank you.
Thank you, sir. Thank you, sir.
Yeah, I'm unable to. Yeah, I'm unable to. Wait, one last question. Only last question. Okay. I need to conclude.
My question to Basu Mudawat. Is there any comparison study for mineral oil and natural ester and synthetic ester in the amount of carbon emission for considering the complete value chain from manufacturing and also suppliers and also operation point of view?
Complete study we have not yet done, but we can do it. But there is a definitely benefit in CO2 emissions because completely about 30% of product is oil. So that much CO2 emissions are reduced directly. So that I can tell directly, but we have not done one-to-one comparison because if large power transformers are made, then there are some, we have to increase some dielectric, and then normal footprint of the transformer is a bit bigger than conventional oil. So that we have not done, but it can be done.
Okay, thank you.
Yeah, welcome.
Yeah. Sorry, I'll have to conclude. Maybe offline we can discuss one-to-one, whatever questions are there. And thank you all the authors. They made a very wonderful presentation today. And I would like to conclude this session. Thank you.
Thank you, sir. With the claps, it's mean that the session was good. So once more, one won't clap so that everyone get awakes. Finally, thank you. So I would now request Mr. Ajay Jain from CG Power to grace our stage. I will call out the name for the session authors, and I will request Mr. Ajay Jain to facilitate our session authors. Sir, please. Starting from Mr. Basu. Mrs. Manali. Mr. Manal Pandit. In the meantime, delegates who have not submitted their feedback form, please do submit it. The quiz round for that also will be available. Please. Mr. Sunil Sachdeva. Mr. Budi. And for Mr. Govind Srivastav. Also, for an extreme person, for a wonderful session chair for our Jason sir.
Thank you.
We request all the session authors to please accompany us for a group photograph. Sir. So any more feedback forms are left with any of the delegates? Okay.
Send somebody to collect it. कोई भी जो पास में volunteer है वो ले लेगा.
Volunteers who are near to there, please do collect it. So by the time we collect, so an announcement is that the dinner is going to start by 7:30. In the meantime, we will do some sort of a round for the feedback form. So we request all the delegates to please have a seat, and I will now request Mr. Imtiaz Siddiqui to take over the session.
Good evening, everyone. So everyone has given the feedback form. Can we collect that fast? Rishabh. So tomorrow morning we will have the award for the best papers. Are you guys excited? One runner-up, two runner-ups and one winner. 3 prizes to be won on the basis of the results done by the juries. So I'll check with you guys tomorrow who in your eyes is the popular choice for the best paper. Who has asked the maximum question in last 2 days? Any name, any guesses? You? Mamtora sir? या पटनायक जी या झाला ममतोरा साहब? ओके. भौमिक साहब ने भी पूछा. नहीं, I need one answer. Who, as per the audience, has asked the maximum question in last 2 days? Mamtora sir is a clear winner. Okay. So one prize for the person who has asked the maximum question during this 2 days of conference, because this shows that he was awake maximum time. Done? और आ रहे हैं? I need 3 lady volunteers from the audience to pick the winners.
Blank forms.
Blank form को पेनाल्टी लगेगी अगर नाम लिखा हुआ मिल गया तो. अच्छा पटनायक जी आप डिस्क्वालीफाई हो गए. अगर फॉर्म में सजेशंस अच्छे नहीं हुए तो प्राइज वापस ले लिया जाएगा. थैंक यू. वन मोर वॉलंटियर. One of the tasks that we all should give to ourselves is that in next Trafotech the number of lady participants should be more. Isn't it? We are happy that this time almost in every session we had couple of authors, but we have a long way to go. तो इसको आगे सारा अभी पटनायक जी करने हैं. तो इसको इसमें से निकालेंगे या इसमें निकालेंगे
and it will was feed जाएगा डायरेक्ट उस पे.
Thank you very much for volunteering. You both are from Elda, right?
Yes. It is good that Adda is, at least becoming equal opportunity employer. Done?
So it will be going there.
यहाँ रखिए, नीचे से उठाएंगे, so that people can see. First you, Bhumi.
I'll hold it.
हैं?
पलट देते हैं.
Any more?
Yes, sir. Gifts are ready. Sir, गाड़ी आ गई होगी और साढ़े 9 बजे देवेश गेट पे आ गई होगी नहीं आई ये जानते हैं गाड़ी वाले को जानते हैं
But now it all depends upon.
No, हम इसको पलट देंगे तो it will not be a chance for anyone कि वो पहला है या दूसरा है. हमारा कार्ड डाल सकते हैं.
Only if you can sponsor 3 more gifts.
I will offer 3 whiskey bottles.
Not tonight. कल सुबह 9:15 पे सबको इधर होना है. Which price है? No, फिर फंड खत्म हो जाएगा. सर लकी प्राइस का वैल्यू नहीं होता है, कौन लकी है उसका वैल्यू होता है सर, प्राइस कुछ भी हो. अभी वो होंगे तो मिलेगा, नहीं होंगे तो वी विल टेक नेक्स्ट वन. मिस्टर आशीष प्रधान BSES. Is he around? Prakash bhai, you come. You distribute the prize. See, out of 400, I think it should be not, less than 300 or 350.
Thank you.
Mr. Ashish Pradhan is the lucky winner. आप लॉटरी खरीदा करो. इसको आप रख लें, अभी इधर ही रहो सर. प्रवीण कुमार राज पेट्रो स्पेशलिटीज लिमिटेड. ओ वाह, ये तो बाद वालों को ही मिल रहा है ऐसा लग रहा है. Time is in your favor. Saj?
हाँ सर.
Next round.
ठीक है सर.
So the third winner will be selected by Kimmi Tiwari. लाल गजरा जी, आपको प्राइज मिलने से तो मुझे भी हिम्मत बढ़ गई है मैं भी कभी लकी हो सकता हूँ। Congratulations.
Thank you, madam. मुझे कभी हाउस ही नहीं लगी है।
वही मैं सोच रहा हूँ। अभी तक किसी का मिस नहीं हुआ तो आई एम टेम्पटेड टू डू वन मोर और टू एटलीस्ट। लेट्स ट्राई वन मोर टाइम। Two more ladies, please volunteer. You in the corner, please come.
Both in the corners. Both in the corners.
Please. Perfect. देखिए इतना मतलब नॉलेजेबल सेशन के बाद थोड़ा फन तो बनता है. At least we can see amongst us who is lucky. So next time we try to be around them. Please come. मुझे याद है वो और एक और चार अभी और हैं. One. Please. अभी और डेडलॉक होता तो मैं बोलता अल्फाबेटिकल ऑर्डर में किसका
दो हैं.
Let's see who are the coupled winner. So जिनकी हैंड राइटिंग ज्यादा अच्छी है पहले उनका नाम पढ़ूंगा. मिस्टर विशाल शर्मा फ्रॉम विद्या मेटल मैन्युफैक्चरिंग कंपनी प्राइवेट लिमिटेड. है नहीं है? So second winner is दीपेश कपूर विद्या मेटल मैन्युफैक्चरिंग कंपनी. तो दोनों ने एक साथ करके दिया था. They are on the same flight? Okay, one more time. No, you. जेटको वालों को बहुत मिलता है प्राइज. मेरा मतलब रिकॉर्ड है, मैंने जितनी बार भी लकी ड्रॉ किया है जेटको के किसी ना किसी को जरूर मिला है. और आज है पार्थ आर पटेल फ्रॉम जेटको. बिना जेटको के मेरा लकी ड्रॉ कंप्लीट नहीं हो सकता. अरे आप रुके, आप लोग छोड़ के जाएंगे तो ये फिर ये भी चली जाएंगी आपकी. अभी एक और होना है. So the last draw by Manali. ये भी एक है, दो है. एक है. I am happy to announce this because they have really come from very far place. Swapan Kumar Das, Irrigation Department, Assam. I see Assam team here, but where is Swapan?
He has gone very far.
Oh.
One more.
One more. So the replacement is Yash Malviya from Rekem RPG. he's there. Great. अभी वो वाली लिस्ट कहाँ है जो कल? And yesterday we got the list of 3 people who were the fastest in giving the feedback form to us. And so the first three people who gave the feedback form first to us yesterday is Mr. Mihir Merchant. नहीं है. Miss Anjana Talashikar. So जो एक मिहिर भाई का नहीं है वो भी फिर हम लकी ड्रॉ करेंगे. And my colleague Tony Magrill, he was in fact the first one to give the feedback form, and I have to look at it what feedback he has given. No, no. Welcome, Tony. So we award merit also, you can see in India. Yeah, but so the last lucky draw in place of Mihir Bhai will be done by Anjana. Priyanshu Pratya, TPDDL. No Priyanshu here? One more. Unlucky Priyanshu. No, not unlucky, but yes. फिर वो सीक्वेंस गड़बड़ हो जाएगी. इनको दूं कि नहीं दूं? इन्होंने फीडबैक में काट दिया. So I leave it to the audience. No feedback, just the name. Shall we give or no? No. Okay.
One more.
One more. No, I don't want to embarrass. This is a good feedback. Please organize a conference like that every year. Mr. Manoj Hirani, CPRI Bhopal. वो भी नहीं है? अन्ना तो अंदर से निकालो. इसने पहले ही बोला था 3 निकाल.
इन्हें पता था.
Mr. Rajat Kumar Nayak, TPNODL, ओडिशा. ओडिशा वाले सब चले गए, खाली पटनायक जी को छोड़ गए. Help her in finding the right. पहले तो कौन सा निकाला? पहले कौन सा निकाला तुमने? He is there. Mr. Shuja Ali Mir, JK SPDC. No. उनको क्यों भेजा तुमने? ये तो पक्का है। अक्षय दवे, BHEL भोपाल। अक्षय भाई सबसे गौर से देख रहे थे कि कौन विनर निकलता है, एंड हिज पेशेंस हैज पेड। You are real lucky one, you know, because you are getting it in place of someone from Bhopal only. Mihir bhai is from Bhopal, he is also from Bhopal. And the last but not the least, the Popular Choice Award for asking maximum question to Mr. Mamtora. कहाँ गए सर? एक और निकालेंगे अभी प्रकाश भाई। हैं? अच्छा हाँ नहीं, सेकंड क्वेश्चन वाले को देते हैं। Who was the second one for asking question? Vamik sir? Okay. Vamik sir.
Sir, the prize is for you. You have to ask one question.
And the last prize for not allowed to ask questions, Mr. P.K. Patnaik. That's true.
You also come because you have imposed that particular rule. Yeah, I have a contribution to his prize. Actually, let me to tell you a very important point. The moment I just asked the very question, I was the first man to ask the very first question in the first
Session.
So, from that point of view, I am just getting this prize. But thing is that moment I just asked the question, in the end of the session, Imtiaz bhai came and told me that you are not supposed to ask some more questions.
See, the problem is that in T20 game, if you allow a team to take more than 2 DRS, every over there will be 1 DRS. so that is why we restricted that, okay, only 2 questions per day for Patnaik ji. Come here.
I'm sorry.
Sure, actually I will be adding also one more point. When we just impose this kind of point that you will not be asked for the questions and all, what I did, I changed my strategy. So whenever I just asked those queries, it was not of queries rather than the suggestions. In the mode of suggestions, I started off putting the queries. Then whenever I asked him also whether it was the correct way of taking your imposition or not, he told that, oh, it's okay. So thank you anyway, it's a nice of kind of things, and very well to be here, and at least of getting the last prize which has been declared over here, and basically
No, yours is not last prize. I missed something. Yeah.
Oh,
we have. Sorry. I missed something. I will take two more minutes. We have 3 prizes also for the people who have registered first online for this event. So, and I have the list with the time stamp, and that first prize goes to Mr. Yogesh Sood. Is he here? Yeah. He was the first to register, and he and his colleagues, but since his was at it was 1 second, I'll tell you the details. It was 4th November 9:25 a.m. and the second colleague was 26 a.m. So he has won it by 1 second. Then second company to get the prize is Miss Preeti Chatur from Prayog Electrical. नहीं है?
Lucky lot?
हाँ, वो लास्ट में जो मिस होगा वो लकी में जाएगा। आ रहा है? Okay, okay, please come fast. My team is really excited to give more prizes, so now probably I will announce another category after this. So this encourages us all to, register as soon as you hear about it. Maybe you can get a better prize next year. And the third company is Grasim Industry, Mr. Shiv Ratan Setia. आइए सर. So the next prize is for someone who submitted the first technical paper which has been selected for the presentation in this Trafotech Global, and the winner is Mr. Dr. T.C.M. Gupta from APAR. And the title of the paper was Enhancing the Sustainability / Reliability New Generation Natural Ester Based Transformer Oil. है या चलेगा? तो अच्छा second. First I remember the second. Lucky draw. Second was from Atlanta, but that was rejected. Third?
No, मुझे याद नहीं. It's okay, I'll take it.
अच्छा कुछ और करते हैं, और भी कुछ टेक्निक.
Third paper was from Manu Nair, Hitachi. That was included in bound volume.
Okay.
Yeah. That is like Manu Nair. Bound volume.
So the second paper which was submitted, it was not selected for the presentation here, but it has been accepted for the bound volume, and that goes to Mr. Manu Nair of Hitachi. Is he here?
Third paper?
Third paper?
Third is from that effects of harmonics on transformer losses.
So after that was the paper from ERDA, Miss Bhumi Patel. That has been selected. So, and it's a law of natural justice. She picked up the first winner. So she is the last one to receive the prize today. But are they here?
Yes, yes.
तो नाम दो ना.
ये सामने बैठे हैं सर,
तो
नाम
नाम तो
बता
चाहिए
दो.
मुझे. डेलीगेट लिस्ट में होगा. अभी हमारी टीम ने बोला इतना जल्दी आप कैसे छोड़ सकते हैं, अभी खाना तैयार हो रहा है, सबको खाना खाना है. तो the first 4 delegate from international who has registered. So one is Mr. Abdul Rahman Al Manauri from Voltamp, Oman, and his team. So we are there are 4 of us from Oman. We are felicitating them all with the prizes.
All the 4 of them can invite. Yeah,
No?
yeah. All the 4 of them can come together.
All the 4, please come here. So their presence has made our event a truly global event. अच्छा ठीक है उनको बुलाता हूँ एंड
Yeah, sure.
अभी मेरी नजर एक अपने बहुत पुराने दोस्त पे पड़ गई। पांडे जी आप आए इधर, एक आपके लिए भी प्लीज 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 कम टू द स्टेज, वी कैन नॉट लीव यू जस्ट लाइक दैट।
All the prize winners will get an entry to my party tonight.
If you are ready to be awake until 4 o'clock and come back here tomorrow morning at 9:15.
You also come.
आपको कैसे छोड़ देंगे सर? आइए come on sir. पांडे जी ने यहाँ पे आकर के ट्राफोटेक ग्लोबल को कंप्लीट कर दिया, because it was, we have never had a Trafotech, without him and his presence. Thank you for.
And without his songs.
You called me, invited here. Thanks for coming. Without your songs.
इनको हम कल देंगे। चलिए सर, लेट्स
डिस्प्ले
क्या है?
एक इंटरनेशनल कस्टमर।
Please sit, please sit. Much more fun is awaited. Please sit.
क्या हुआ? क्या ये आज कल का प्रोग्राम?
So for all of you, there was some a little bit change into the tomorrow's program. So we have displayed it on the screen just for your kind concurrence.
जी ग्रिड सॉल्यूशन से फर्स्ट इंटरनेशनल आया था ऑनलाइन मीडिया टेक्नोलॉजी
है कि नहीं?
ये डेट ये डला हुआ है, एक बार देख लेते हैं होते हैं तो।
जी ग्रिड सॉल्यूशन
राजीव गुप्ता, ये फर्स्ट इंटरनेशनल पेमेंट था, एक बार देख लीजिए।
मुश्किल है।
GE Grid International, Mr. Rajiv Gupta is here.
Oh.
Please come, sir. Yeah, you get the prize for the first international payment on our website.
And also on our international gateway.
And for also bringing the foreign currency to our country. Welcome. So thank you very much, sir. और तो कुछ नहीं है सरप्राइज? Okay. So let's break for the dinner, and we will assemble tomorrow morning 9:15 to felicitate and award 2 distinguished members of our community who has given the untiring you know, his life and efforts to our industry. Prakash, you have to say something?
No, I only said the person who leaves the last from the dinner will get one prize from me. It's just a dinner.
Thank you. Thank you very much, everybody. $1 lakh वाला प्राइज हमेशा इन्हीं को मिलता है.
The dinner will be served at the lunch area itself. Pardon? The laptop you have got? No got. So delegates, please do search once you reach back to your hotel. Please check your delegate kit bag. In case if anyone is having, we'll appreciate it, and one more gift will be given to him for that. Thank you. Yeah.